मैंने अपनी ऑडियो चेक करनी है। जी मेरी ऑडियो क्लियर है? मुझे आपकी तरफ से आवाज कट के आ रही है।
सर क्लियर आवाज आ रही है?
जी जरा बोलें।
हाँ जी सर, अब आवाज ऐसे क्लियर है आपकी?
ठीक है, मेरी आवाज क्लियर है ना? मैं क्योंकि मुझे
सर आपकी आवाज क्लियर आ रही है।
चले ठीक है।
Can you hear me?
Yes, we can hear you.
Great.
Okay. We'll start in 2 minutes.
That is fine. Do I have sharing permissions? It's showing share as grayed out for me.
You will get once I introduce you, right?
I'll get the permissions to share?
Yes, you will get.
Okay.
Okay, Bismillah wa salatu salam ala Rasulullah. Assalamu alaikum and good morning, everybody. On behalf of the organizing committee, I welcome all of you to the 15th IEEE International Conference on Open Source Systems and Technologies, ICOST. This is the second day of our conference. My name is Dr. Amir Mahmood, and I'm the faculty member at KICS UET Lahore. Today, I will be the session chair for the session on cloud computing and big data. We will be having 3 distinguished talks in this session. The first talk is by Dr. Ali Khayyam. Dr. Khayyam is the General Manager of Internet Monitoring and Software-Defined Networking at Amazon Web Services. Prior to AWS, he was the Director of Engineering at VMware and Senior Director of Engineering at PlumGrid. He has co-founded 3 startups in Pakistan. He did his PhD in electrical engineering from Michigan State University and also served as a faculty member at NUST. So, sir, please start your talk. He will be talking on AWS monitoring planet-wide network. Sir, please start. Please unmute.
Can you hear me?
I guess now we can hear you.
All right. Thanks, Amir. Nice to be back at UET. It's been a while. So thank you for having me here. And Assalamu alaikum and welcome, everybody. It's a pleasure to be back. I actually presented at ICOST when I just came back to Pakistan after my PhD. So this is pretty nostalgic after, I don't know how many, 15 years. I'm coming here presenting again. So a lot has changed in those 15 years. Today, I'm going to talk about what I do at AWS. I'm not just going to talk about what I do at AWS. I'm also going to talk about 2 other teams that do network monitoring as well as software control of the network. And those slides, this is the same slide deck that I presented at SIGCOM a couple of years back, a year and a half back. And I had 2 principal engineers from 2 other teams who also accompanied me on that presentation. So I will be presenting their slides today as well. It's somewhat inconvenient time in the Bay Area, so they couldn't join us today. But yeah, I'm going to be presenting their slides as well. So let's get started. I'm going to talk today about internet measurements and SDN controllers at AWS. This is my team. Fun fact: this is the only slide deck. I've been at AWS for about 4.5 years. This is the first and only slide deck that I've ever built. Which is really interesting for a company of this size. So in Amazon, there is no concept of a PowerPoint. Everything is written like a research paper, like a very dense 3-page, 4-page, 5-page, or 6-page, maximum of 6-page research type of memo. And then everybody comes and reads that, and all the decisions are made based on the paper right there and then. So this was actually in Jeff's shareholder letter in 2017, where he was talking about we don't have any PowerPoint presentations at Amazon. We write structured 6-page memos, and everybody reads them silently at the beginning of the meeting. So this is pretty interesting because anybody who has a research background, they'll feel at home over here because this is what we do anyway. We write papers for a living. All right, let me talk about the wide area network infrastructure. That's the infrastructure that my team owns, the monitoring and controlling. AWS is a planet scale cloud, so it's got 26 regions across the world in many different continents and countries across the world. There are 8 more regions that are announced, and this footprint is expanding pretty fast. These regions are geographically distinct so that they can be closer to the end users that they're serving, as well as they have a smaller blast radius. If something happens, it is contained to a particular geographical region and not spread across. Each region in itself is then divided into multiple availability zones, or AZs for short. The availability zones are also geographically distinct, and even inside of each availability zones, the data centers are generally in different cities. So one geographical problem should not impact other places. Just give me 1 second. Sorry about that. So I was saying that there are 26 regions, 8 were announced. Each one of these has multiple availability zones. So it's a pretty large scale footprint. As you can see, it's spread all across the world. And then in addition to this infrastructure, what connects us to the internet are these points of presence. And there are hundreds of these across the world, multiple hundreds of these across the world. These are what we call edge sites that connect the regions to the internet. The connectivity inside of the regions is done by our global backbone. We have a backbone network. We have our own lease circuits or our own fiber, which Amazon owns, and we connect every region to another region using our own backbone that we have all over the world. And to connect to the internet, inside of these points of presence, we have transit and peering connectivity. So we have almost every big network in the world, we transit and peer with them, and we send traffic over to them, and then they carry it over to the end users. For example, in Pakistan, we'll hand it over to PTCL, and PTCL will then carry it over to all the different end users in Pakistan. Let's talk a little bit about technologies. So we talked about a little bit about internet environment in the beginning, but think about this huge planet scale internet footprint with so many different providers that are carrying our traffic to the end users. And when we're carrying this traffic to the end users, we have multiple different types of connectivity. One of these connectivities is called transit. The other one is called private network interconnect, and the third one is called internet exchange. Transit is the full internet routing table. We hand it over any prefix in the world. We can hand it over to them. It can route it back to that end user. PNIs are generally large networks that we have peering relationship. We directly connect with them, and generally most big clouds are directly paired with each other, and we are not charging each other. Generally, it's a settlement free peer, so we're not charging each other. And internet connects, internet exchanges are these large-scale exchanges. I believe there's one in Pakistan now as well, where everybody comes and connects into a common fabric, and from there they connect out to different end users. To monitor this footprint all across the world, we need a lot of different data sources, and we combine them together in interesting ways that we'll talk about later on. We have what we call active as well as passive measurements. Active measurements are where we're sending some sort of probe traffic, some synthetic probe, and we control what probe we are sending and where we're sending it to. And that's one source that we have. We have a lot of outbound probes going from regions over to internet destinations, as well as from internet destinations coming back into AWS regions. Similarly, we have a lot of passive measurements. We are Amazon, so we have a lot of services that actually come together to make AWS what it is. So we can actually look at traffic coming to all of these services and try to build a map of just regular customer traffic and just look at the networking connectivity, TCP socket parameters, and we can figure out what kind of connectivity experience, what kind of latency, retransmissions, and other metrics there are which are impacting end user experience. As you can see, this is both control plane as well as data plane traffic. So we not only monitor how traffic is flowing over the internet as a data plane, but we also look at PGP advertisements, how our prefixes are being advertised all over the world. What is it if somebody's blackholing our prefixes, or if there's a route leak of some sort by misconfigurations? We have systems that detect those as well. So these are a bunch of different microservices. They're all working semi-independently of each other, but they vend all this data into a big data lake from which we make inferences. We collect it all together, we aggregate it, and then we make inferences of this data. When we find out something is wrong in the internet, and think about it just like a huge network. This is a huge network and a lot of measurements that are happening all the time. Every time we find out that there's a problem, there is no human workforce that can keep this network up or which can actually solve this problem. So we have software-defined networking controllers. These controllers are just what they control every single internet session. And every time they see that there's a problem on the internet, which is figured out by our internet measurement systems, they move traffic to healthier paths that actually do not have that problem. When they're doing that, they actually need to solve this pretty interesting and complex optimization problem, conduct optimization problem. So they have to optimize traffic for availability. We should congest the network. It should be available. It should reduce loss, but also for performance, which means the latency should be good. If we've got two paths, we want to put traffic on the path that has lower latency towards our end users. While we're making these decisions, we also want to take into account the cost of routing, which is the financial cost of routing. Like I said before, there are three different types of networks: transit, PNI, and IX. And what we pay each of them is very, very different. So we want to take that factor of cost and how it's impacting our routing into consideration as well. And finally, there are business constraints as well. Like there are certain networks we just don't want to use. There are also some networks who we have committed certain traffic rates to, and we want to maintain at least that much traffic level on those networks. So all of this sort of comes together with the internet measurement data, and the controllers make a decision to move traffic across different sessions and interfaces inside of a POP or across POPs as well. The goal is the same. Both the systems work in a closed loop, but the goal is the same: is to optimize the connectivity experience of Amazon customers. One thing I should mention is that this internet footprint is not just AWS. AWS is a big part of it, but all Amazon services are using the same footprint. So Amazon.com, which is a retail site, is using the same internet footprint. Prime Video, which is our video streaming service, is also using the same footprint, as well as Amazon devices, Alexa and Fire TV and Fire Stick, are all using the same internet footprint across the world. So you can also understand that these workloads have very different expectations of what's good and what's bad, and they operate on very different metrics. So there's an interesting challenge for the controllers to balance out workload-specific requirements in their decision making as well. Lots of interesting challenges. We have lots and lots of data that is collected and ingested globally, like continuously. We make inference on the data. Like I said, we aggregate it in many interesting ways. We build many different views by those aggregations, and we then use algorithms to infer what's going wrong and where. So some of these algorithms are more sort of temporal in nature, where they're really trying to figure out what's going wrong. There is something going wrong in terms of a time series analysis, and then there are some other systems that actually go and look at spatial analysis to see which network is actually impacted, what's causing this problem that we're seeing in the network right now. And then, like I talked about, SDN routing decisions are optimized across multiple dimensions. And then there's another problem of, even when you make a decision, so SDN is the brain, and it makes a decision, this is traffic needs to move from this particular session to that particular session. And implementing the decision in the network in itself is a pretty interesting distributed systems problem, because we need to do it consistently, which means it needs to be an eventually consistent system, and it needs to have strong consistency guarantees as to when it will actually implement a decision that it made. And also, when it makes that decision and it implements it, it needs to make sure that it's always correct in the network as well. So there has to be some correctness guarantees by metrics and canaries, so that it is making sure that even if the device is misbehaving, if there's something hardware related which is going wrong with the device, or an upstream network is sending us traffic that we were not expecting, our decisions that we have encoded in the network are still holding true to what the brain of the SDN decided they should be. And we got to do all of this in real time. So this is it's a pretty interesting challenge. We've got to do it within minutes, no more than 5 minutes, and we've got to ingest all of this data, make decisions, and then make decisions. First, figure out something is wrong, make decisions of where to move traffic, and then implement it in the network all in real time. Let me talk a little bit about my team. I've got software engineers. I've got people in multiple locations. Most of them are software engineers, essentially people with strong coding and distributed systems background. We also have scientists. So I know I'm talking to a lot of PhD students probably here. So I got a lot of scientists in my team as well. Scientists are people who come from a strong math and stats background. Many of them have done internet monitoring or networking problems as their PhD problems as well. And they come and support the software engineers in terms of all the mathematical formulation of the algorithms that we're building and the convex optimization problems that we solve. And then we generally have some support from network engineers. These are not the strongest coders that we have, but they're the strongest in networking fundamentals. And some of you folks will probably fall in this yellow circle over here. If you're looking at this, the kind of thing that excites you, feel free to reach out to me, send me a resume. I'm like, this is my brazen hiring pitch in the middle of a conference presentation. So just to give you a scale of what we were talking about. So we talked for about 15 minutes. So we collected close to 600 million. Actually, it's probably a little bit more than that. This many measurements have been collected since the start of this presentation. They've been ingested. Decisions have been made. So it's a network of a scale that, like you can see, right, this many hundreds of millions, billions of measurements coming in every few minutes. There's no human workforce that can actually ingest it and make decisions or sense out of it. So all of this has to be done through machine learning as well as esteem controller. So everything is automated over here. All right, I'll move to the second part of my presentation, which is essentially put together by John Evans, who's the principal engineer in our networking team. And we're going to talk a little bit about network availability and performance engineering, again, instead of the AWS network. But now we are sort of going beyond just the wide area network. We're also talking about our data center network, what connects our data centers inside of the regions to the what we call the border network or the edge network. So now we're going across multiple different things, and we're talking about availability and performance. So we'll talk a little bit about how we measure the network performance that we deliver to our customers, and how do we assure that this performance is actually being delivered, and availability is what we could maximally offer to our customers. So again, everything at Amazon starts off with data collection. So each router that we have, and we have so many of them inside of our data centers as well as in our edge locations, we collect data from them. We collect all sorts of data. We have routing data. There is system logs. There is interface statistics, and like lots and lots of other data. This is just raw metrics that actually end up in a system. The system then does data transformations, and these transformations are where we combine them all together, just like I was talking about internet on the internet side. We combine them together to make sense of correlation, as well as figuring out what kind of aggregations that do we need, which metrics do we need to continue to stay disaggregated. And while earlier I was talking about more aggregated metrics in terms of internet scale, over here we do need some metrics that are still very raw in terms of they are very device or router specific, because the action that you're going to be taking are going to be router specific. There's a lot of very, very sophisticated anomaly detection algorithms that are running on top of this this data that we have, and those generate alerts that get into a correlation and causation system. The correlation and causation system is connecting everything together and making sense of what action we should be taking. And by we, again, I don't mean a human taking that action. This is, again, the automated system that take a device, for example, there's something wrong with the device, some hardware is failing, and this happens all the time. We've got so many things that 1 in 10 million thing is happening to us like 10 times a day, right? So we basically have these things that are considered very rare by even hardware vendors that are happening very regularly in the network, because there's so many of these devices out there. So we have systems that actually can take these devices out of service, fix them in certain ways. They do some remediation workflows, take some actions on them, and then can bring them back safely into operation as well, without a human ever touching them or even knowing that this is happening. So these are very complex systems, because you have to do it without impacting the network at all. So the design of the network in itself is done in a way that it is not impacted by these systems taking devices out of service, fixing them, and bringing them back into service, which is the mitigation and remediation workflow that I was talking about. And these are even huge and bigger than my world, like, because there's so many more devices over here. So in the past 10 minutes, these network systems actually collected 6 billion measurements across the world and made decisions on top of those as well. All right, this is the last part of my presentation. Now I'm going to talk about something completely different. So I talked a little bit about data center, talked a little bit about wide area network. Now we're going to talk about our satellite network. So Amazon under Project Kuiper, by the way, this presentation is by Andrew Dickinson. He's my colleague, principal engineer in the Project Kuiper team. So Project Kuiper is where Amazon is sending 3,200 satellites up in space, low orbit of the space, to provide connectivities to places where physical network infrastructure has just not reached. Or even if it has reached, this is going to be an easier way to provide that connectivity. And our goal is to provide it at parity with what you get from terrestrial networks, so your wireline networks. So this is about Andrew. He's been there for a while. He's built a lot of really cool tech at AWS. He couldn't be here today, but yeah, it's built some really, really big system, including EC2, Amazon VPC, and now he's building Kuiper. So like I said, it's these are the 3,200 of these that we're launching in low Earth orbit satellites, and they already started going out in space. So there's a lot of interest in this area already. We're not the only one. A lot of other companies are doing this as well. Now, Project Kuiper has its own very unique type of SDN, and we'll spend like 5 minutes talking about that, and then I'll take any questions. So it has its own very interesting type of dynamics, because the difference between it and any other network that we're used to is that over here, the network is continuously moving. Your base station, generally even in mobile network, your device is moving, but your network is, the base stations are in fixed locations. So it's easier to hand off stuff. But over here, the network is moving. So the thing that is actually providing connectivity is in orbit, and it's continuously moving. It's actually moving really, really fast. So it's moving at thousands of kilometers per hour. And at that speed, if a device is communicating with a particular satellite, it must hand over to the next satellite. But if you think about it, there's about 2 millisecond delay between when it is communicating with one satellite and then it needs to move over to the other one, which means there's a lot of data in flux already. While the satellites are going across the world, there's a lot of data that is already in flux that is being communicated between the device itself and the satellite. So the sixth example of this particular satellite sent something to this device on Earth. And this other one is still communicating with that one. So that communication hasn't fully finished. Sorry. Now, for it to be able to hand over this information to the next satellite, this device over here is going to really literally shoot its data into space, like into complete emptiness. And it has to be done in a way, the software-defined networking had to work in a way that by the time in 2 milliseconds it actually reaches that lower orbit, that new satellite has actually taken over and is able to receive that traffic. So imagine the kind of sophisticated system that you have to build where you're actually shooting data into the dark, knowing exactly when the next satellite is actually going to come over and take that data. Similarly, the data from the previous one, you cannot just drop it. You need to store it for a while and then pass it over to the next satellite as well. And you need to do it continuously. There's no break in this, and like this happening just like continuously, you're getting handed over to the new satellite. So it's a very unique type of a network, and the software-defined networking technologies that you use in this one are fundamentally different from what we see in rest of the network, wireless or wireline networks or data center networks. So there's an interesting new initiative from Amazon that is coming to fore now. And I think that's all I have. I'm like, I'll take any questions that you have.
Okay, so
really nice I told 30 minutes, so I presented I prepared about 30 minutes.
Right. So I think a really interesting talk. So the internet measurement area is very close to my heart. So I worked as well with Ania there in Germany. So the first question is that the SDN has brought a lot of automation, right? And can you hear me?
Yes, I can.
Yeah. So, but recently what we have seen that the whole network of Facebook went down, and that was also I think the culprit was one of their automation stuff when they started pushing some started checking some automatic configuration, and then the whole system meltdown and the cascading effect happened. So what do you think that the big players, when they do these automations, uh, do they do it like in a manner that is more than required? Because then even the human needs some time to recover the network.
Yeah. So when these things, let's look at the flip side of that equation, right? I mean, it is not possible to not do automation work. Let me just put it that way. Network of this scale, even if it melts down, if humans were touching it, it will melt down even more. The most stable part of the entire internet, and you've probably seen it, you're in the internet measurement space, is the holiday season, right? The one that we're walking into right now, Christmas and New Year, because everybody stops touching their network at that point. So the network melts down way more if humans are touching it than machines are touching it. I think in that sense it is way more stable. But it is like the airlines, right? Like if an airplane goes down, it's big news because it just happens so rarely, and when it does happen, it's big news. Whereas people drive on the street and die all the time, and that's not reported that much. So it's similar for network automation as well. It's not that there's an option to do it some other way. Having said that, all of these providers, Facebook included, actually spend a lot of time thinking about blast radii of their systems. You know, how they're going to fail and what is the blast radius of these things, and they still fail in unpredictable ways. And one of the biggest reasons why things really break is BGP. I mean, like, it's a very legacy protocol. It was designed for very different types of use cases. Was designed to be completely decentralized. But the whole internet just speaks that protocol, so we can't just really get away from it very easily. So a lot of these, even the Facebook misconfiguration, was based on BGP bringing down the internet, and that happens. It happened to Amazon as well. So it's one of those things that we, as a consortium, internet consortium, need to go away from BGP to something else. But until that happens, it's going to be a thing. But I still believe that it's way more rare with machines than it was with humans.
Yeah, I agree. So you mentioned that there is a lot of measurements going around. Like you mentioned that during the talk, we have collected so much of our data. So how much of this data Amazon is willing to share with the researchers, or if they want to have some kind of analysis?
Yeah, no, Amazon can't share this data. This is our customers' data, so I'm never going to share it. Even if it's at network level, people can make inferences. They can infer where our customers are located, where traffic is going. It is going to be largely used by internal teams at Amazon.
And the SDN controllers that they are developing, so they are also proprietary, or is it like the open source?
Everything is built mostly from ground up. We use a lot of open source, but at component level, not at the business logic layer. The business logic has been built from scratch. If you're looking for data sources, some of these data sources or similar data sources do exist on the internet. For example, CADA has been collecting a lot of data from different internet measurement systems for a decade, more than a decade now. Similarly, RIPE and route views, different university projects, they've been collecting BGP data from many different routers across the world for a long period of time. So there are some pretty interesting data sources that are available out there. Nothing that are at the scale of Amazon simply because of the size of Amazon, but for researchers to do some work, there is some publicly available data sources already available.
So can you shed some light that how the big telcos are using SD-WAN? I mean, are they adopting in their backbone similar to Amazon, or they are just like, or they don't need it?
Everybody is doing something, but yeah, the telcos had traditionally been just interconnects. I mean, like they basically were the infrastructure over which you write automation or which you write something. So think about it like somebody's building servers, right? And then somebody else owns the applications. So that's traditionally been their in their play in the entire ecosystem. But of course, they also want to, because the value is really where the software is. So all telcos have something or the other around automation, but they're generally behind cloud networks by many years. But everybody, they do have systems. It's not like we are the only ones in the world who have it. All other clouds have similar or parallel systems, and many telcos do as well. They're just a little bit behind.
Or alternatively, they can just ask Amazon those services. I mean, they can just buy out the services. Yeah.
They can, but think about it like if I'm, let's look at a real interconnect, like level 3, right? I mean, if I'm level 3 in the United States, I'm basically fiber. I'm on fiber interconnect across the US. But while I'm a fiber interconnect, I can build intelligence into my network, not just the intelligence that MPLS or those kind of technologies or fiber, failover technologies provide, but even more intelligent than that, which actually route me across the world, different paths and so forth. So that if it is centrally controlled, then I disassociate myself with the routing logic on the routers, and I can actually innovate much faster. I can deploy business logic that is custom to me. I can offer something which is more specific for Amazon, but some other customer, which is more premium, but some other customer doesn't need that kind of connectivity. So I can offer them a different type of a tiered package. So I get out of that business of just being the plumbing to being something more intelligent than just interconnects. And many different service providers are actually going in that space and trying to do that.
So you mentioned a very interesting project by Amazon, Kuiper. I'm really excited to hear about this. Because it brings a lot of new challenges in the networking stack. So for example, I can imagine, will this standard TCP will work on those swarming networks who are just where half of the network is moving?
Standard TCP won't work, right? I mean, like, I wouldn't say standard TCP won't work, but the underlying physical layer, the fire is going to be completely different because the network is continuously moving and moving at tens of thousands of kilometers per hour, right? So yeah, all of that has to be rebuilt from scratch. So everything that you know about physical networks has to be rebuilt from scratch.
And what about the other layers?
Applications are going to also so at the end of the day, there are applications that are going to open a socket. So from that perspective, they should not feel it's any different from terrestrial networks. That is the hope, that applications don't have to adapt. If you ask that applications to change, if WebEx needs a different adapter to work on a satellite network versus a wireline versus wireless network, then it's not going to work, right? Just like once you write your application, you write to the same socket, and then everything else happens in the kernel, which is different for each of these networks that we're talking about, right? So it's going to be similar, but the application would get the same quality of experience and would get the same APIs.
Right. So the second last question is that how do you see the future in into 5 to maybe 10 years, or the future of networking? I mean, we were foreseeing SD, software-defined networking in the last 10 years, and then what is coming in the next 10 years?
So in the next 10 years, I think network is going to get more and more commoditized. Like that's just the way it's going to be. So network is already getting commoditized pretty quickly, and it's going to get more and more commoditized. The only value proposition in the ASIC or the chip is going to be forwarding logic, as well as they can do some very specific functions like security and so forth. Much of the logic that you have in terms of the business logic is going to start moving into general purpose compute. That is where I see networks going. The second part of the network is that I think from a network boundary itself is going to get decentralized, because now digital borders are becoming a thing, countries and states, they want their traffic routed in certain ways. And this traffic flowing anywhere to anywhere just based on routing is going to change. I have to factor in those business constraints and those laws of different nations into account as well. So that's another trend that requires us to have something software defined. Otherwise, implementing it inside of devices is going to be harder and harder. And the third thing that's going to happen is the network is going to keep getting closer and closer to the or even the cloud is going to keep getting closer and closer to the end users. even now when we think about, like, so for example, you sitting in Pakistan and when you're thinking about connecting to AWS, you're thinking about the BOM region or the Singapore region, and that is still pretty far away. So these networks from the clouds and others are going to get closer and closer to the end users through these points of presence. AWS has the concept of a local zone. You can think of it like a small size mini region that can be installed anywhere. So that's another trend that is going to accelerate, at least from a cloud perspective. And I think satellite connectivity is going to be a real thing. I mean, like, it's not just AWS, sorry, not AWS, Amazon, but it's many different service providers are going to offer it, and that plus 5G is going to be an interesting combination of two very interesting networks, both non-terrestrial, that are going to be the largest network providers, I think, in the world in 5 to 7 years. So yeah, that's where I see it going.
So you mentioned 5G. So that brings me another question of the scalability. So if you see that if networks start, if they keep growing with this rate, so into 5 to 10 years, they will be there'll be huge networks. So managing those huge networks will also be challenging. So what is your opinion that how we can manage the scalability of?
Hello? Did I lose you?
Hello? Oh, you can't hear me?
I can hear you now. I think I lost you for a second. I guess your question was how will we manage scalability once the networks become even bigger than what they are right now?
Yeah.
So think about it this way. I mean, like, networks have this uncanny ability to survive any scalability challenge if you think about it, right? I mean, like, they started. I mean, ARPANET was designed for a tiny network, and today the entire world stands on that essentially similar technology, right? So I think everybody who is extending the network is in a way doing it in a way that it is fairly decentralized, still fairly decentralized, and the fault radii are smaller, and the smaller components then talk to each other. For example, at Amazon, my team's job is to keep the fault radius as small as possible, the change propagation radius as small as possible as well for any system that we build. So I think I don't see a big sort of like Moore's law for networking coming anytime soon. I think it'll be fine. We've been able to survive Wi-Fi and 3G, 4G, as well as the cloud. So I think the network will be fine. Like, it's not going to hit like Moore's law type of limits anytime soon.
So you have been part of the NUS faculty and the Pakistani education system. So what is your advice for the students who want to work in networking or maybe for computer science? So what kind of a research area they should pursue to excel in like 5 to 10 years?
Yeah, it's interesting. I never did any research in networking when I was a faculty member. My area is wireless and information theory. But yeah, I think if you are doing networking research, it's an exciting time to be a networking researcher because so much is happening in this world. So many things are changing. The problem that I see with some of the researchers, PhD students, is that they pick problems that are too small. I think we need to think bigger and longer term. You don't need 5 publications which are B-rated publications to graduate. You should really go for that 1 A+ publication. That's what I used to tell my PhD students as well. If it takes you 5 years to get that one solid publication and really get that strong body of work, then you should just totally do that. I don't see why you would not do that. And at the end of the day, I think there is endless problems that still exist in the networking domain, and there is no dearth of inspiration in this space. But yeah, I think there's somehow a rush. I mean, it's not just Pakistan, everywhere else in the world as well. There's a rush to publish more, and I think we should change that trend to publish less, but really publish high quality research. That'll be my one piece of feedback to students.
Mm-hmm. So one interesting thing that you mentioned at the beginning of your talk was the way Amazon holds meetings. So that is really interesting. So you guys have no PPTs?
We have no PPTs, no.
So people are comfortable with this?
Oh yeah, absolutely. We are like 1 million people 1 million people, right? People just come in, read. Everybody knows this. It's a little bit freaky initially. First time you walk, you're like, have you walked into a wrong room? Why is everybody sitting so quietly? What are they reading? But you get very quickly used to it. So yeah, in fact, many meetings, somebody comes without a doc. People just say, when you have a doc, we'll just reschedule this meeting. So it's a very nice scalable process. And anybody who's bringing a doc, the good thing is you have to put thought into it. And one important thing which actually researchers know very well and have known for a while is that a doc speaks for itself. It's not dependent on the presenter. You can get the same slide deck to two different people, and one can really crush it and the other one can really suck at it. So it really depends a lot on the presenter as well. Whereas a doc needs to stand on its own 2 feet, and it is what it is, right? It's ink and paper. So in that sense, it's also nice that you're not really even expected to be in the room for decisions to be made when these docs are being reviewed.
So the last question is regarding the transit and pairing from the Pakistani perspective. So we are kind of geographically we have only 2 routes. Either we go towards this Oman side, and the second one is, I think, goes to the India side, right? So there are the transatlantic, and then we join to these transatlantic cables. So what do you think that in Pakistan, if we want to have more or good quality of experience, should we invest in these fiber connectivities?
I think we should, at least multiple times in my time at networking, I've seen the Pakistani networks melt down. And there's this one small satellite connection that connects us to the rest of the world before it go dark. So I think we should invest in fiber. We should also invest in satellite connectivity. I think the government needs to make it a priority. I know these are very expensive links, but I think the entire country's economy really depends on it. So it's absolutely a worthwhile investment. Internal to the inside of Pakistan is pretty nice. I used to have fiber to the home from Neatel way back, 12 years back. I still don't have it in the US. So in Silicon Valley, I don't have it, but I had it in Pakistan 12 years back. So inside the country, I think the infrastructure is really evolved. But our external connectivity to the rest of the world is still not caught up with it.
Right. So thank you, Ali, for the nice talk and the question answers. So we would like to present you a virtual shield.
Thank you.
Thank you. So, yeah. So now, thank you, Ali. We will now start our second talk at 11 o'clock local time.
Okay. I'm going to have to drop off because it's really late for me over here. So
thank you very much because I think it's midnight for you, I think.
Yeah.
Okay.
So anyway, thank you. Thank you, Ahmed. Thank you for the opportunity to speak here.
Welcome.
It was fun. Okay. Assalamu alaikum.
Walaikum assalam.
Research and development activities in the areas of information technology and computer science. Al-Khwarizmi Institute of Computer Science, KICS, today stands along with the advanced technology centers of the country. According to the Joint Survey of Knowledge Platform Singapore and British Council, KICS was highlighted as the pioneer initiative among the research organizations in Pakistan. The institute is geared up to provide the country with trained resources and research staff for development of high-tech products and services, to exercise commercialization through incubation of high-tech companies, and to promote R&D culture in the country through technology innovation and industrial collaborations. More than 250 individuals, including PhDs, MPhils, master degrees, and administrative staff, are well focused and passionate about their jobs. Currently, 26 labs are operating at the institute, which are working on various research areas, including artificial intelligence, communication technologies, software development, power systems, industrial automation, language engineering, technology incubation, and media studies.
Quasmi Institute of Computer Science has provided a platform in the education sector in Pakistan, where we have developed solutions not only for the industrial sector in our nation, but also for the private sector and public sector.
More than 100 projects funded by local and international entities so far have been successfully completed. Notable projects that are being worked on presently at KICS include Urdu Search Engine, Brain Informatics, Classification and Modeling of Brain Data, establishment of National Center for Cybersecurity, National Center for Robotics and Automation, National Center for Artificial Intelligence, development for water pump agricultural tube well, energy efficiency measurement and improvement, automatic Pakistani postal address recognition and parcel routing, energy extraction by safe disposal of municipal waste using nanotechnology, virtual reality-based neurogaming for mindfulness in children and ADHD patients, and to name a few. Apart from the research work, KICS runs a testing facility for international tests like Cisco, Microsoft, GMAT, and Oracle. It also offers professional trainings. KICS has signed agreements and MOUs with more than 100 national and international research and academic organizations and industry for mutual R&D collaborations. For more details, please visit our website www.kics.edu.pk or feel free to contact us.
दुनिया अगले 5 से 10 साल के अंदर अपनी शक्ल एक बार फिर तब्दील करने जा रही है और इतनी तेजी से बदलने जा रही है कि हमारा रहन सहन, हमारी चाल ढाल, हमारी वज़ाकता, हमारा लोगों से मेल मुलाकात, हमारा रहन सहन, सब कुछ यकसर तब्दील होने जा रहा है। आज जो मैं आपसे कह रहा हूं, शायद एट दिस पॉइंट इन टाइम आप उस पर बेअनी ही यकीन ना करें, लेकिन जैसे जैसे वक्त का पहिया चलेगा, जैसे जैसे वक्त आगे बढ़ेगा, आप सब लोग उसको खुद एक्सपीरियंस करेंगे। मैं क्या बात करने जा रहा हूं, ये बहुत इंपॉर्टेंट है, बहुत इंटरेस्टिंग है, सुनने से और देखने से ताल्लुक रखती है। मेटावर्स, ये यूनिवर्स असल में मेटावर्स के कॉन्सेप्ट पर ड्रिवन होने जा रही है। अब ये मेटावर्स का कॉन्सेप्ट क्या है? आपने देखा कि फेसबुक ने अपना नाम तब्दील किया है और फेसबुक ने अपना नाम बदल के मेटा रख दिया है। मेटा रखने की वजह क्या है? दुनिया में अब जो कुछ होने जा रहा है वो मेटावर्स के जरिए से होगा। अब जितने बड़े बड़े टेक जायंट्स हैं वो मेटावर्स की जबान में आपको आहिस्ता 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 बात करते हुए, आपकी जहन साजी करते हुए, अपने आलात को इसके तहत ढालते हुए दिखाई देंगे। अब मेटावर्स क्या है? बहुत ही तंदई से, बड़ी तवज्जो से सुनिएगा। मेटावर्स का कॉन्सेप्ट आपको समझने के लिए 2009 में हॉलीवुड की बनाई गई फिल्म सरोगेट्स देखने की जरूरत पड़ेगी। यानी उस वक्त 2009 में हॉलीवुड ने जो आइडिया कंसीव कर लिया था, अब वो इंप्लीमेंट होने जा रहा है। सरोगेट्स क्या है? उसमें बूढ़े, बच्चे, खवातीन अपने घरों में एक मशीनी कुर्सी के ऊपर, एक कंप्यूटराइज्ड चेयर के ऊपर बैठ के, गॉगल्स लगा के, जो कंप्यूटराइज्ड टेकी गॉगल्स हैं वो लगा के अपने सरोगेट्स को कंट्रोल कर रहे हैं। सरोगेट्स यानी एवेटार, आपके जैसे रोबोट्स, आपके क्लोन जो बाहर फिर रहे हैं, चल फिर रहे हैं, लोगों से मेल मुलाकात कर रहे हैं, सौदा सुल्फ ले रहे हैं, रोजमर्रा की जो मामूलात है वो अंजाम दे रहे हैं, वो आपके रोबोट्स हैं। लेकिन उन रोबोट्स को, उन सरोगेट्स को, उन एवेटार्स को आप कंट्रोल कर रहे हैं अपनी कुर्सी पे बैठे हुए। यानी फॉर एग्जांपल मैं रेहान हूं, रेहान ने अगर उस्मान से मुलाकात करनी है तो रेहान को अपने घर से निकलने की कोई जरूरत नहीं है, बल्कि रेहान का जो सरोगेट है वो उस्मान के सरोगेट से मुलाकात कर लेगा किसी भी जगह पर। इसके अलावा आप जमानो मका की कैद से आजाद हो जाएंगे। रेहान अगर पाकिस्तान में बैठा हुआ है और उस्मान ऑस्ट्रेलिया में है तो रेहान और उस्मान की मुलाकात एक ही जगह पर। अगर उस्मान चाहेगा ऑस्ट्रेलिया में मुझे मिलना चाहिए तो मैं विद इन नो टाइम ऑस्ट्रेलिया पहुंच जाऊंगा और मेरा एवेटार, मेरा सरोगेट, मेरा रोबोट उस्मान साहब से जब हाथ मिलाएगा तो उस्मान साहब उस हाथ को एक्सपीरियंस करेंगे। यानी ऐसा नहीं है कि वर्चुअल रियलिटी के अंदर हमारी मुलाकात इंटरनेट पर कहीं भी हो गई, बल्कि बाकायदा सेंसेस के साथ, फीलिंग्स के साथ हम एक दूसरे को महसूस कर रहे हैं, तो फिर आप अंदाजा कीजिए कि लोगों को अपने घरों से निकलने की जरूरत क्या पेश आएगी कि जहां पर वो निकले, खुदा ना खासा किसी हादसे का शिकार हो जाए, कोई एक्सीडेंट हो जाए, प्लेन क्रैश कर जाए, कोई मोटरसाइकिल उसके अंदर जो है वो घुसा दे, उसको जख्मी कर दे। यानी अगर जख्मी होगा तो आपका क्लोन जख्मी होगा, आपका रोबोट जख्मी होगा, आपका सरोगेट जख्मी होगा, आप महफूज रहेंगे। और अगर इतना जख्मी हो जाता है वो कि वो बिल्कुल नाकारा हो जाता है, तो आप मार्केट से जाके एक नया सरोगेट खरीद भी लेंगे। दिस इज समथिंग वेरी इंटरेस्टिंग एंड वेरी अलार्मिंग टू, क्योंकि खतरे की घंटी भी बज रही है। बहुत सारे जो हमारे मजहबी स्कॉलर्स हैं, हमारे बहुत सारे जो ऐसे लोग हैं जो रिलीजियसली चीजों को बहुत फॉलो करते हैं, वो ये कह रहे हैं कि जहां इंसानी दिमागों को कंट्रोल किया जा रहा है, ये एक ऐसी सोच है जो दज्जाल की सोच है, और मुस्तकबिल में इंसानी दिमागों को कंट्रोल करने का मकसद ये है कि आप समझ लीजिए कि दज्जाल की आमद है। आप ये देखिए कि आपकी प्रॉपर्टीज, आपके बिजनेसेस, ये सब कुछ अब मेटावर्स के अंदर ही होंगे। यानी आप अपनी प्रॉपर्टी इंटरनेट के ऊपर खरीदेंगे, इंटरनेट के ऊपर डिक्लेयर करेंगे, और फिर जो एनएफटी का कॉन्सेप्ट है, यानी आपने अपनी प्रॉपर्टी के ऊपर कोई चीज, कोई नक्शो निगार लगाने हैं, तो आप वो तस्वीरें, वो मजमुआ, कलेक्शन ऑफ पिक्चर्स, वो भी आप इंटरनेट पर खरीदेंगे और उसके ऊपर कंधा कर देंगे। अच्छा, अभी इसकी एक एग्जांपल ये है कि वकार जका साहब जो हमारे यहाँ क्रिप्टो एक्सपर्ट है, वो भी मेरे साथ मौजूद होंगे। उन्होंने जनाब $5,000 की एक बंदर की तस्वीर खरीदी, एनएफटी खरीदी, और आज उन्होंने वो $2 लाख के अंदर फरोख्त की है। तकरीबन $1,80,000 के अंदर वो पिक्चर फरोख्त हुई है, वो एनएफटी फरोख्त हुई है। तो आप अंदाजा कीजिए कि यहाँ पर जो करेंसी होगी वो क्रिप्टो करेंसी होगी, यानी डिजिटल करेंसी होगी। यहाँ की जो लैंग्वेज है वो मुख्तलिफ जबान होगी। यहाँ पर जो मेल मिलाप वाले लोग हैं उनकी वज़ाकता मुख्तलिफ होगी। हाँ, उनके दिमागों को आप कंट्रोल कर रहे होंगे। अच्छा, अब आप सोचेंगे ये कैसे हो जाएगा? मैं ये कह रहा हूं इतनी तेजी से होगा कि आपकी पलक झपकने का वक्त होगा। जैसे वेब 1 जो है वो एक HTML वर्जन था, वेब 1 एक HTML वर्जन था। वेब 2 जो है वो एक ऐसा वर्जन था जिसके अंदर, क्योंकि HTML वर्जन के अंदर तो आप सिर्फ रीड कर सकते थे, रीडेबल वर्जन होता था। जब वेब 2 आया तो उसमें आप राइट भी कर सकते थे, आप चीजों को एडिट भी कर सकते थे। ये वेब 2 वर्जन ऑफ स्पेस है। इसके अंदर हम स्काइप पे बात कर रहे हैं, हम जूम के ऊपर बात कर रहे हैं, हम गूगल यूज कर रहे हैं, हम दीगर जो टेक एप्स है वो इस्तेमाल कर रहे हैं। तो दिस इज द वेब 2 वर्जन। लेकिन अब वेब 3 वर्जन आने वाला है, और वेब 3 वर्जन ही मेटावर्स है जिसकी मैं आपसे बात कर रहा हूं। अब ये मेटावर्स क्या है और हमें एट दिस पॉइंट इन टाइम क्या करने की जरूरत है कि हम अगले 5-10 सालों के अंदर अपने आप को इस एनवायरनमेंट के साथ जो है वो ढाल लें और कॉप अप कर सकें। हमारे साथ इस वक्त टेक्नोलॉजी मूवमेंट पाकिस्तान के चेयरमैन और क्रिप्टो एक्सपर्ट वकार जका साहब मौजूद है। अस्सलाम वालेकुम वकार जका साहब, बहुत बहुत शुक्रिया आपके वक्त के लिए। वकार जका साहब, ये जो मेटावर्स का कॉन्सेप्ट है, जरा ये समझाइए कि मेटावर्स क्या है और आने वाले चंद सालों में ये हमारी जिंदगियों को कैसे बदलने जा रहा है।
जी, स्नोफॉल के नाम से एक बुक थी बहुत अच्छे पहले 1984 में, वहाँ मेटावर्स का पहली दफा ये लफ्ज लाया गया। मेटावर्स का मतलब होता है बियॉन्ड यूनिवर्स। अच्छा, इसकी हकीकत ऐसे समझिए कि जैसे हमारी जो रूह है, हम अपनी रूह को खुश करने के लिए हर काम कर रहे होते हैं। जो स्नैपचैट पर हम फिल्टर लगाते हैं या अपने आप को खूबसूरत दिखाने की कोशिश करते हैं, ये जो हमें अल्लाह ताला की तरफ से जिस्म मिला हुआ है, इसके अलावा हमारी जो रूह है, जिससे आप कहते हैं कि जी हम अपने कल्ब को खुश करने की कोशिश कर रहे होते हैं। तो ये गोरों को समझ आ गई बात कि हाँ, रूह की खुशी के लिए इंसान काम करता है। तो इस रूह की खुशी के लिए अब इंटरनेट की दुनिया में इन्वायरमेंट बनाई जा रही है, जिसे वेब 3.0 कहते हैं। मैं और अभी आप आमने सामने बैठे हुए नहीं है। वर्चुअल रियलिटी में तो ये होता है कि हम एक दूसरे को सिर्फ जो है देख सकते हैं या मिल सकते हैं, लेकिन मेटावर्स में ये होगा कि मैं आपसे हाथ मिलाऊंगा तो मुझे फील आएगी कि मैं आपसे हाथ मिला रहा हूँ। ये वो चीज है जिसके लिए इस वक्त जैसे रोलेक्स घड़ियां खरीदते हैं ना, इस वक्त मेटावर्स की दुनिया में लोग जमीनें खरीद रहे हैं, जिसको पाकिस्तान में लोग कहेंगे अरे भाई पागल हो गए क्या, इतने 1-1 करोड़ की जमीन ले रहे, नजर कहाँ आ रही है। तो इस वक्त मेटावर्स की दुनिया वो है जो फेसबुक की नहीं है। फेसबुक ने तो एक मार्केटिंग टेक्निक यूज की है कि मैं जल्दी से अपना नाम मेटा कर दूं ताकि सब लोग सोचे कि मेटा इनकी क्रिएशन नहीं है। फॉर्टनाइट, पबजी, बहुत सारी वीडियो गेम्स हैं जो ऑलरेडी इस तरह चल रही थी। लेकिन मेटावर्स की खास बात ये होगी, जो मुल्क सबसे पहले इसमें आ जाएगा अपनी मेटावर्स एनवायरमेंट, यानी पाकिस्तान का मेटावर्स वर्जन अगर लॉन्च कर देगा तो सारी दुनिया का पैसा वहां आने लग जाएगा। यही बात समझने की जरूरत है कि हमारी रूह जो है उसकी खुशी के लिए आपको जाता है मैं बिल्ली बनना चाहता हूँ, मैं कुछ और इंसान बन के मैं इंटरेस्टिंग कुछ और करना चाहता हूँ। कुछ लोग इंट्रोवर्ट होते हैं जो अपनी शक्ल नहीं दिखाना चाहते लेकिन बात करना चाहते हैं। तो ये जो हमारे मेटावर्स की दुनिया में हम जा रहे होंगे, वहां जाने से फायदा ये होगा कि हमारी रूह जिस तरह हमें खुशी चाहती है, हर वक्त हम चेंज चाहती है, उस चेंज को भी हम अडॉप्ट कर रहे होंगे। इंट्रोवर्ट रहते हुए शक्ल दिखाए बगैर अपने एवाटार के थ्रू दूसरों के साथ जो है बात भी कर रहे होंगे, बिजनेस डील भी हो रही होगी। और दुनिया भर में इंटरव्यू पर फिर नादरा के ऑफिस जाना है, वो नादरा वेरीफाई करना चाहता है, तो मेटावर्स की दुनिया में घर बैठे बैठे वो मुझे वेरीफाई करना है। मेरे थंब इंप्रेशन से हर चीज वो
So we are waiting for the speaker to join on WebEx. We will start shortly.
guys hear me?
Yes, Dr. Fahad, I can hear you. Can you hear me?
Yes, I can hear you. Sorry, please accept my sincere apologies. My internet just went off right at the moment that I was supposed to join, and this I was trying to hotspot it using cell phone, but apparently that was not working as well. But I'm here now.
Okay, good. So our second speaker is Professor Fahad Saeed. He's a tenured associate professor in the Knight Foundation School of Computing and Information Sciences at Florida International University, Miami. Prior to joining FIU, Professor Saeed was a tenured track assistant professor in the Department of Electrical and Computer Engineering and Department of Computer Science at Western Michigan University since January 2014. Dr. Saeed was a postdoctoral fellow and then a research fellow in the System Biology Center at National Institute of Health. He has served as a visiting scientist in world-renowned prestigious institutions such as Department of Biosystem Science, ETH Zurich. So today he will be talking on machine learning models and high-performance computing for big data omics. He will be telling us some recent progress and challenges. So Dr. Fahad, please, over to you. You will get screen sharing rights now.
Oh, okay. Thank you. Let's see. Can you see my screen?
Yes, we can see your screen.
Excellent. All right. Thank you very much for the nice introduction. Again, apologize for being late. So my name is Fahad Saeed, Associate Professor at Florida International University School of Computing, and I'd like to thank the organizer for inviting me for this talk today. So the thing that I wanted to talk about was some of the machine learning models that we have been developing for big data proteomics, and some of the high performance computing models that we have been working on for some time now. And the reason that I wanted to talk about this specific research area is because a lot of things that we have been doing allow us to do would want us to do both of these things, and we think that both of these together is important for advancing science. So big data is everywhere. First thing that comes to mind talking about big data, data from the universe, multimedia data from YouTube, Google, Twitter, Facebook, and so on and so forth. But one of the big data that we encounter now that is necessary for making scientific progress is biomedical data. And biomedical data is something that is growing at an exponential rate. The way that the biomedical data is being used and being produced right now is more than all of the Twitter's data and the data that you would get from telescopes, for example. And we are able to produce approximately 20,000, 2,000 to 40,000 petabytes of data per year. And we are able to produce that using high throughput technologies. Now, what kind of technologies are we using to produce this data? So this is just a graph of NIH data services. And you can see that the amount of data that can be produced and that has been produced in recent years is growing at an exponential rate, right? And we have all seen this specific slide where the cost of producing a genome data is reducing at an exponential rate in a negative way. And Moore's law is there's a big difference between the Moore law and the cost of data that can be produced in a genome. Now, what kind of data? So this data is specific to genomics data, where next generation sequencing techniques are used. We are able to produce 0.6 terabytes of data per run, and the high computational cost and low scalability of the sequential tool is widely known. Right. So now this is the inability of conventional techniques, sequential algorithms that allows us to develop these big data techniques for genomic data sets. But what I wanted to emphasize here today that it is not only the genomic data that is producing these large data sets now, right? So there's a technique in in proteomics known as high throughput mass spectrometers. And here also we can see, and this is from a Nature paper, and you can see that the cost of producing the data from the mass spectrometers, right, is also reducing at an exponential rate, and the sequencing cost per megabyte is also, we are seeing the same trend for mass spectrometers as we would see for genomic data sets in the previous years. And now mass spectrometers produce what is known as spectra, and I will show you some of the spectra. And we are able to produce petabyte levels of volumes of data in a short amount of time. And the instruments that are producing this data are also increasing at a good pace, which makes us confident that we are going to see the same trend for mass spectrometry-based proteomics as we saw for next generation sequencing techniques. Now, what is the problem in big omics data? So one is the volume of data that it produces is enormous, right? So we continue to do that for proteomics, for genomics, and conductomics, and we are also very interested in be able to combine all of these large data sets. Right? Generation of the data is highly distributed. Individual scientists can produce lots of these data in their individual individual labs. And it can exist in a variety of formats, right? So proteomics has different kind of formats. Functional MRI, for example, would have different kind of formats and so on. So, and the other is that we want to be able to reuse this data. The reason that we want to reuse this data is also because the data that is produced from mass spectrometers or from next generation sequencing, although it's although the data to produce a specific small set is low, right? So I can go and get a genome done just for $100, and that is low cost, but remember that these are system biology studies which require us to go on and sequence this data and produce the data for large number of species or large number of cells and so on. So reuse of data is important because this data is expensive to produce, especially when you are doing large scale genomic system biology studies. Now, what is our goal at my lab? So what we want to be able to do is we want to be able to take this big data. And here you can see that the data has different modalities. So we have the genomic data, the proteomic data, connectomic data is the neuroscience data that we develop some of these models for, and other omic data as well. All right. So so that we get this big data, and then we want to be able to produce infrastructure, computational infrastructure that allows us to do precision medicine. Right, and by precision medicine, I mean that we are able to fine tune the specific techniques that are used for prescribing medication for different kind of disease, for example. So in order to do that, because remember that this is big data, there's no way that someone can go on and make sense out of these large high dimensional data sets, right? So we want to be able to develop these machine learning models and be able to use high performance computing models and be able to use some of the domain knowledge that we have acquired of genomic, proteomic, and neuroscience over many years in the lab. And we want to be able to facilitate this analysis in almost real time, right? So we cannot say that, okay, we're going to get data from this patient, right? And we are going to be, we're going to use our deep learning model that is going to take 7 days, and then be able to have the results which might be very time critical for some of the patients, right? So we have been very successful in doing that. We have bbeen funded by National Institutes of Health, National Science Foundation, Intel, NVIDIA, and so on and so forth. So this is what our trajectory is in broader terms. So more specifically, we want to be able to focus on 3 kind of data sets. So we have been focusing on big genomic data sets, right? And big proteomic data sets, the data sets that come from mass spectrometry. And then we have been using brain scans, fMRI or MRI or fMRI scans. And we want to be able to kind of integrate these data sets to be able to targets for precision medicine, including cancer or HIV, to be able to have identification of pathogens for bioterrorism agents and so on and so forth, and for diagnosing early identification of mental disorders such as autism and ADHD. Now, why do we choose these modalities? One is that we have acquired knowledge and domain expertise of proteomics and neuroscience over the years, right? So remember that you can come up with a machine learning model that is very good mathematically, optimization, everything is good, but that does not mean that it makes biological sense, right? That does not mean that it makes sense from the system biology perspective, right? So domain knowledge is something important, and that is why we are focusing on these specific data sets. So what do? The scientific focus is that we primarily the computational lab. We build computational infrastructure driven by scientific questions and needs, right? So the scientific question and needs is the key word here. And our technical focus is, of course, that we strive to come up with these techniques for these high throughput technologies to be able to come up with solutions that enable new discoveries across science, right? So this is how we try to improve the human condition, if you will. All right, so so in order to attain all of these objectives, so these were very large objectives, right? So and we cannot handle them all at once. So that is why we go on and carve out specific projects that takes a field forward and be able to also contribute to the overall objectives of our research agenda. So the things that I want to discuss today is some of the novel machine learning models for mass spectrometry data. And I'm going to skip the autism spectrum models, but I'm going to discuss the high performance computing algorithms and data structures that we have been developing for some of our problems. So I guess for this audience, this is going to be rather simple. Traditional programming had algorithm and data, and you got an output. Machine learning, you want to be able to use the data and be able to train some of the models that will allow us to make decisions with minimal human intervention. Okay. Now, and successes of machine learning are many, and it allows us to have solutions of big data problems, and there are many open-ended problems that can be tackled with machine learning. Right. So I'm going to skip this because just for the audience. But in general, machine learning models can have a model structure, right, and loss functions and fitting parameters. These are the three different things that a typical machine learning model would need, right? And of course, there are models that are already available. Then there are loss functions that are already available, and then there are parameter optimizations of different parameters, and there are many techniques that are available. Now, and of course, someone could go and say, well, this is the problem, and we want to solve this problem, and then take a machine learning model off the shelf and be able to do some of the training and optimization and will come up with a decision, right? So in that case, the contribution is there, of course, right? Because you're solving a problem, but the contribution from the computation size might be minimal. So more often than not, since the data that we are using is high dimensional, and also we are looking for scientific problems that are novel, we have to come up with our own model structures or our own loss functions that might be specific to the problem that we are trying to focus on. So, of course, there are supervised and semi-supervised and so on, so I'm going to skip this. So, but I would like to emphasize here that why are we caring about machine learning models now? So this is kind of in conjunction with how the classic biology as a science has also moved forward. So the classical biology, the biologists would come up with a hypothesis, come up with the data, and then produce knowledge, right? So this was the classical way that the biology was done. Now the big omics data, you would see that the data is produced first, and then massive scale machine learning models are used to come up with the hypotheses, and other computational biology algorithms are used to produce. So high throughput biological research is now data-driven approach, and machine learning is very, very useful in this context. So let's discuss mass spectrometry a little bit. So let's get a little bit into the detail of, so mass spectrometry is a technique that allows us to study proteins in a high throughput fashion. Okay, so that means that we take a lot of these system biology studies and be able to study the proteins at a massive level, right? So there are two or three things that I want you to point out here, right? So protein is a building block that is used in all living organisms, right? Now protein is made up of peptides. So you cut this protein into multiple pieces, and a subset of that piece is known as a peptide, right, in our computer science jargon, right? And peptide is composed of amino acids. So amino acids are, for our purpose, is just sequence of letters, and there can be 20 amino acids. So this is the only thing that a computational scientist needs to know, that there are 20 amino acids. Combine some of them, you make proteins. Combine some of those, and you combine some of them, and you make peptides. Combine some of the peptides, and you make proteins, right? And the instrument that we use is mass spectrometer. So what does mass spectrometer mean? So mass spectrometer is a high level overview of what mass spectrometry machine does. So these are large, expensive machines. So these are $10 million machines. And we do not have mass spectrometers just because we are not a wet lab, we are a computational dry lab. And but we have collaborators that produce many of the data sets that we might be working with, right? So what is the basic idea? The basic idea is you have proteins. This protein goes into the ionization chamber, where all of these specific subsets of the peptide are ionized with high fields, and then they can be isolated because of the different charge states that it might have. So once we are able to isolate the peptide, we get it into the fragmentation area, where high energy fields are used to fragment this red ball here, right? And to be able to, and this red ball represents a peptide here, right? And this allows it to break up, right? And we are then able to use the mass analysis. This is a very sensitive mass to charge ratio chamber that allows us to really really go on and go on and get the mass and charge ratio of each of the fragments, right? So, but we are computational scientists. We don't really care about this problem. What we care about is what is the data that we get, right? So the data that we get looks like this. So this is a mass spectra that is that we get from the mass spectrometer, and it has x-axis, which is the mass to charge ratio, and y-axis, which is the intensity, right? So each of the mass to charge ratio would be for each of the peak, and the intensity is that how abundant this and this, and then we use this spectra, and the idea is that what do we want to do? So this is what the spectra looks like, right? But this is not the output that we want. The output that we want is the peptide. So this is what the peptide is. So this sequence of letters is the peptide that we want to acquire from this spectra. So you can see that this is going to get messy very, very soon, right? So this is spectra, and these are large in number. These can be millions in number, and the idea is we want to be able to deduce the peptide from this spectra. So how do we do that? So remember that these are the mass to charge ratios, and the distance between the peaks represents the mass that is for a specific amino acid. So for example, here between B2 and B3, the mass is equivalent to this amino acid A, right? And between B3 and B4, the mass is A. Of course, in this cartoon figure, the peaks are labeled as B1, B2, and B4, but this is not known, right? So when it comes out of the mass spectra, this is not labeled. So all of these peaks are there, and there's no way to deduce the peptide from these peaks, right? So how do we go on and make sense out of this data? There are different search engines, right? And the protein database is known. So protein database would consist of millions and millions of these sequences. And then what we want to do is that we want to take this spectra right? And we want to match this spectra to each of the protein sequences that are in this database, right? And the database and the search engine will then score them, and then that scored, the highest score is then outputted, and we get a sequence of peptides that are output of these search engines. All right, so this is what the computational workflow looks like for a MS data analysis. So what are the problems? So as you might see, that the problems are that the combinatorial explosions of the combinatorial explosion of the possibilities of different peaks. So remember that each of the peak is a specific possibility, and there are more than 4,000 of these peaks, and this becomes a very, very large number. The other, of course, is that right now the way that the analysis is done is using a lot of filtering, which reduces the search space. But that reduction of the search space comes at a cost, and that cost is that many of the data is not reduced. So, but and of course, the third is that there are different kind of search engines that are used now, and you would see that many of the search engines have spurious correlations. That means for the same data set, when they are fed to the search engine, will give different results for the spectra that is being considered. That means that only 30% of the MS data that is fed into the search engine are accurate enough for further analysis, right? So as you can see in this very small pie chart, that these are the different tools that are used, and only 6,000 of the peptides are something that the search engines are agreeing on, but there are a lot of peptides where they do not agree, and there's no way to know which is which. And this is, of course, a classic case of spurious correlations, and something that is a problem for the field. So what do we want to do? How do we want to tackle and go on and solve this problem? So what we want to do is that we want to be able to learn from the data, right? So we want to be able to take the data, and instead of having a scoring function that will lead to spurious correlation, we want to be able to learn directly from the data. Right? And how do we do that? We want to come up with a machine learning model that allows us to do that, right? And we want to be able to do it in a way that reduces the dimensionality and makes the modality of our data that is used for matching such that all of the noise that is acquired while doing this mapping is reduced, right? And it reduces the spurious correlations. So in order to do that, and this is just a schematic of whatever we just discussed, that how mass spectrometry data is produced and how peptides are acquired from different kind of search engine techniques. Remember that once we are done with once we have the experimental spectra, we take the peptide database and produce simulated theoretical spectra, and then the scoring is happening between the spectra and the theoretical spectra, and the peptide spectrum matches that have the highest score are something that is the output of these. So one challenge is that we have to simulate this theoretical spectra, but as you can see that the mass spectra itself is a stochastic process, right? So in order to model a stochastic process is a difficult problem. So that is why what search engines do is that they come up with a theoretical spectra that is simplistic, which is one of the major causes of the spurious correlations that we see. The other, of course, is that the heuristic comparison of the simulated spectra and the experimental spectra leads to mismatches just because the spectra that is produced theoretically is oversimplistic and can lead to. So what we want to do is that we want to design a similarity network directly from the peptide and the spectra, by learning the scoring function itself from the data. So instead of coming up with a scoring function and say, well, this is the spectra and this is the theoretical spectra, and we're going to come up with our own scoring function, which we do know of previous 30 years of research or 40 years of research that does not work. And although there are search engines that I just showed in one of the slides are good and do work, but they work at a certain extent. And we want to be able to learn the scoring function directly from the data, right? And we think that this is the correct approach because learning the function directly from the data means that we are not introducing our own error. And the other is that we are not introducing the error in a way that that is reflected from comparing different modalities of the data. So the tool that we came up with is known as Speculate. This is work of my PhD student, Muhammad Usman Tariq. He is a former UETian as well. And this Speculate is a deep cross-model similarity network for peptide deductions. And I'm going to show some of the ideas behind this model. So let me just hammer this point a little bit, what we are trying to do here. So our goal is to encode the nodes so that the similarity is similarity goes to an embedding space, and then we can use this embedding space to be able to score the spectra. So what the idea is that we have an encoding function here that takes this spectrum and encodes it to this dimension, and then we have the peptides that also go and encode in the same dimension. And once this is the case, then we are able to see that if they are close to each other, right? If they are close to each other, then this is a specific match that needs to be done. But the problem is that we need to be able to define these encoding functions, right? And we also need to come up with the similarity, which is the goal of our original machine learning model. So how do we do that? So encoder, we have two components here. Encoder is a node in the data, and this is a d-dimensional embedding, right? And the similarity function is that how a specific relationship in the vector search space is going to allow us to have least amount of similarity between P and S of the original network, right? So, and this Speculate is the name of our model, and this is what the model looks like, right? So I'm going to try to explain a little bit of this model. So you can see that the spectra here, we can formulate that into dense array of 80K length, right? And then this is fair, and intensities are normalized between 1 and 0 just to make the process a little bit easier, right? And then this spectra is fed to a spectrum subnetwork, right? And then we have these peptides that are encoded by a unique integer, and these are then and the amino acids are embedded and learned using a embedding layer. So this embedding layer is by LSTM, and then that is fed to the vector encoding of the peptides, which allow a vector encoding of the peptide, which is a peptide subnetwork, right? And then this is then forwarded to the specific loss function that I'm going to show you. Now, remember that once the SSN processes the spectra, the floating point numbers, and PSN processes the peptide string using LSTM, we get to train both of these networks and then be able to predict the spectrum charge, predict the spectrum mass, predict the mass of the peptide, and be able to then have specific branches that allows us to do the matching of the spectra and the peptide. Right. So, assume, and I'm going to show you some of the results there. That assume that this is all scored. But the problem was that there were there was no specific loss function that allows us to do this specific calculation. So, in order to do that, we came up with our own loss function, which we call snap loss function, and this is how it works, right? So, this is the I still have time. Okay. So this is the spectra. So each of these spectra here is labeled Q1, Q2, Q3, and the peptides are labeled P1, P2, and P3 here. And remember that Q1 should match to P1, Q2 should match to P2, Q3 should match to P3, right? And we take these vectors and then embed them into the SSN and PSN, and then output is that both of the outputs, P and Q, are being embedded in a 256-dimensional space, right? And we do that for all of the peptides and for all of the spectra, right? So once we are done with this, then by the time that all of the spectra and the peptides are done, all of the spectra and peptide are being mapped here, and then we try to select the closest negative spectra. Now you see that the problem is this: that there are spectra that are embedded here. So Q1, Q2, and Q3, right? Now we want the function such that once we are done with that, once we are done with the complete training part, the Q1 part should be as close to P1 as possible, right? That is the first. That is the first objective. And the other objective is that Q2 and Q3 and all of the other these different colored balls are as away from them as possible, right? So only then we will be able to have a scoring function that would be accurate enough, right? So this was the so this is what the objective was. And once we are done with all of the scoring, you can see that we update the gradients as the training happens. And once we are done with that, we'll see that Q1 is very close to P1, P2 and P3. Q2 is going to be very close to P2, and Q3 is going to be very clear. Of course, there's going to be error in when we are trying to do that. And once we're done with that, we can use online negative mining to be able to have the updated gradients that will allow us to have this scoring function give us the matches that are gives us the lowest error rate, if you will. All right, so this was the story about the custom loss function, and it seems to work well. And once we are done with this, then we are able to show that when all of the mapping has been done, then we can just use nearest neighbor algorithm within a precursor mass filter that allows us to have the detection of the peptide from Q1 to P3, and of course we can score them in a way that that can be categorized in a list fashion, right? And then we can have have peptides that can be scored with different confidences. And you have to do it for each of the pairs. And once we are done with that, we have. So the results were so some of the training, validation, and testing. So we use very massive data sets. So we had 4.8 million sex tuples that we use for training, and for charge 2, 3, and 4, these were the different values. These are in millions, and we use all of this data set to be able to, and the split was 80-20, and we are able to show that with the accuracy with increasing time. So one of the, and you can see the loss function as well here, that since the amount of data that is available here is very large, the performance and parameter tuning took a lot of time. So for 100 models, this took approximately 83 days of training time for one of the models, and we had many models that we use. So I'm going to talk about some of the high performance computing techniques that we use. So ROC curves looks nice here. You can see that there's precision and recall functions here as well. But what I really want to show here is the visualization, which I really like, right? So here you can see that this is the UMAP visualization after all of the mapping has been done, right? So this is not before, this is after, right? And you can see that the peptide here is corresponds to red dot, and the spectra corresponds to blue dot. And the very interesting thing that you'll see here is that that each of the peptide is being clustered by spectra. That means that but after the training is done, we can take one of these peptide and just score all of the spectra that is in the vicinity, right? So this is the blown up part of this, and you can see that you can take this peptide and then you can just score it against this instead of scoring against all of them, right? So this is being done in the search engines now as well using a filtering technique, but that filtering technique is just based on the mass to charge ratio and not on the specific stochastic similarity that we are learning from this network. And that is why you will see that as a consequence of that, Speculate is able to produce peptide results that are much better in accuracy as compared to the other state of the art. So as compared to Crux and MS Trager, is able to produce data sets that are of much higher accuracy and much higher confidence. And we are able to show that for many data sets that are available to us, and for many different kind of modifications. And for each of the modification, the data gets more complex, and it seems that the Speculate is able to do that very nicely. Of course, we do not. So for all of the similarities and peptide detections that we have done here, we see that it is there's a lot of overlap, but there's a lot of known overlap as well, right? So known overlap in our case here is good as well, because that means that Speculate is not only able to deduce the peptide that conforms to other tools, but is also able to deduce peptides in a novel fashion. And we just published this study very recently in PLOS One, that came out in October, I think, right? It's in October, and we are able to show all of these. And I would so this is the research article. Please go on and read it online. All right, so I'm going to shift gears a little bit, so because I don't have a lot of time here. So one of the things that we have been developing now are some of the high performance computing strategies for this big data omics, right? And the reason that we want to do that is the database sizes is getting exponential when we increase the number of variants that are possible. So here, with number of post-translation modification in the database, you can see that the amount of data and devices is terabytes, and this is just the index of the data. So the index of the data can increase in can be as much as multiple terabytes, which is problematic for single desktops, even if they might be powerful. So we want to be able to use, and the other is of course the algorithmic part of that, right? The idea is that you want to be able to we want to be able to do all of these searches, and we show in our recent study that the performance saturates at a fraction of the CPU capabilities, and most of the cost that is incurred for these kind of tools are are communication costs that are problematic. So the related work that has been done in high performance computing in this domain has been very limited, right? And it has been mostly algorithms. Most of the algorithms that use distributed memory architectures or shared memory architectures are very much try to use the embedded signaling parallel technique, but the embedded signaling parallel technique, as I will show in one of the slides, is waste a lot of resources, right? So the idea is that they take a database, which is the database, and then they replicate the database, right? So you might say that, well, why is that problematic? This is problematic because remember that this is a terascale database, right? So if you're doing HPC work where you're replicating very large amounts of data over multiple nodes, then this is a waste of resources. And remember, these are expensive machines, so these are large supercomputers that we run. And if we are replicating that, and the idea is that they take the spectra and then partition the spectra into multiple chunks, and then take a chunk of that and try to deduce the peptides from the database, right? So, but the problem with this is that the replication of the database leads to a lot of resources that are wasted, right? And of course, it will have the same bottlenecks, because remember that the communication in the I/O we show it on our recent paper, is something that is problematic. So we want to be able to have a scalable database search algorithm that can run on supercomputers in a scalable fashion. So the significance, of course, is that we want to be able to do that for a precision medicine kind of way, and from the computational perspective, we are very excited to do that because it is something that is now used in cancer proteomics, where we have terabytes and terabytes of data, and the amount of time it will require is months to years, and we want to be able to do this in minutes. Right. So I'm going to skip some of the detail here, but there are different parallelization models that we went on and investigated. SPMD and BSP models were BSP models were used, and I'm just going to show the workflow right now. So this was a four super step workflow that's based on divide and conquer. The basic idea is So let me discuss the basic idea, and then we can go into detail if needed. So the basic idea is that we, instead of taking the database and replicating the whole database, what we do is that we have a clustering mechanism that that instead of replicating the whole database, we divide that database into smaller chunks. Okay. Now we take that smaller chunks, and each of the chunk on the node is then compared to the spectra, right? To all of the spectra. Here the assumption is that the database size is very large, right? And the amount of spectra that we have is not that large. Okay. Right. So once we do that, then you will see that a subset of the database has been searched with the spectra, right? For the other subsets, have also been scored, but they are scored on a different nodes, right? So then the idea is that how do we go on and combine that? So we came up with a strategy that allowed us to have a globalized score where the amount of communication that is happening between the different nodes is very, very minimal. Okay. And I can get into more detail. So we had this mathematical profiling of the database, and we were able to show that it was the I/O between different workloads that was the thing that had the most significant cost, and that is what we wanted to do. So just a little bit more detail that how the data is clustered, right? So once it is clustered, then it is partitioned across different nodes, right? And then we came up with a mechanism for clustering. So I'm not going to discuss that just because we don't have enough time, but just know that this allowed us to have, so we were able to show that using this clustering, which is not very compute intensive, we were able to come up with a technique that allowed distribution of the data in a fashion such that the computations that are happening on each of the node is very localized, if you will, right? And then we have a data parallel design. Here, the idea is that we take the raw spectra and then at each subsequent run, we are able to do that for all of the spectra that is available, and And then with this had a hybrid task of data parallel pipeline, where each of the spectra that has been computed on each of the node is kind of chunked together, and we had a technique that allowed us to do that. And I'm going to show you a cartoon diagram of that as well in a minute, right? So this was once we had each of the nodes had the results, then we were able to decode and assemble that in a global results. All right, so I'm going to skip because we are running out of time. So here is the partial none distributions of each of these. So you can see that each of the result here is on a specific node, and then we had a technique that allowed us to have this assembled in a global fashion. So we use some of the statistical techniques here to be able to come up with this. All right, so this is just, this is going to be good. So this is the database. So we divide it into multiple pieces. and then we do the peptide detection on each of the nodes. And then once we are able to do that, we take each of the results, right, and we accumulate it on specific nodes, right. And once we are able to do that, we take the global scoring function that we came up with to be able to come up with the peptide. So there are different optimizations that we used. I'm not going to get into those, but it was a very load balanced system. And it was a load balanced system that optimized balancing of the computational load as well as the communication load. And once we were able to do that, we were able to show that, so I'm not going to discuss these. We were able to show that so let's get to results. So we use a large supercomputing machine. This had like 1700 cores, 9 terabytes of RAM, and maximum we were allowed 72 nodes in these machines, and we used MPI to be able to progress that. And we were able to show that across all of the different high performance computing techniques, we always get approximately 10x speed up, right? So remember that all of these different techniques that have been used before are the techniques that behave in a embarrassingly parallel fashion, right? And we were able to show that since they were not optimizing the communication costs as part of their calculations. Once you do that, we are able to show that this is, and we are able to show that even for very, very large databases. So here the database size is very large. You can see that all of the existing techniques. MS-Fragger is a technique that is widely used, approximately 6 months to do that. We were able to do that in a few minutes on very large machines. So we also did experiments for different overheads between MS-Fragger, which is the computing technique, and ICOST. We call our technique ICOST. So we were able to show that the IO overhead is very, very low. And we were also able to show that the search quality does not decrease when we are well, it decreases, but it does not decrease to a significant fashion. So we are able to show that the results that we get are very, very close to the results that we would get when you are trying to do the calculations on a single machine, right? And then we had speedups for varying experiments that we had, right? And for some of them we had super linear speedups. For others, it was close to linear, and the efficiency was close to 80%. A strong scale efficiency for our. And then we did profiling of our code on these large machines, and we were able to show that we had significant improvement in the CPU utilization and the cache usage. And remember that the communication cost that we were discussing before, the communication cost is a combination of the cost that incurs when distributing across data across different nodes, as well as communicating between different hierarchies of memory as well. So I'm going to skip these now. So we were able to publish this in Nature Computational Science. So Nature Computational Science is Nature Computational Science is one of the major subsidiaries of Nature, and this took more than 2 years to publish, but we are able to do that now, and this is widely available now. We call our framework ICOST. And the code to this is available as open source. You can go and take a look at that if you like. So with that, I'm going to conclude my talk. Acknowledgements are many acknowledgements. Of course, 2 people that I would like to acknowledge here. So both of this work was done by my students. So as I mentioned before, Usman Tariq is my PhD student from UET, and he did this machine learning models for peptides. And Mohammad Hasib is also my PhD student, also from UET Lahore. And he's the one that he did a lot of high performance computing techniques for this large proteomic data sets. And then, of course, there are many people at FIU and National Institutes of Health that have and that have worked with me on many of these problems. All right. So with that, so we had the tradition of getting a picture of our group, and now our group has increased many folds now, of course. But since COVID, we have not been able to take these pictures. But our hope is that by next semester we will be able to do that, and once we do that, we will put that on our webpage. These are the acknowledgements for the funding agencies that have funded our work, primarily National Science Foundation and National Institutes of Health. And with that, I would like to thank all of you for coming and listening to me and listening to my talk. And I will be happy to share I will be happy to answer any questions if you have. Thank you.
Yeah, thank you, Fahad, for a very informative and nice talk. We have one or two questions. So for the sake of time, I will just ask one question. So one of the questions that somebody asked on the WebEx is that the main issue with large models and dataset is the prediction of required resources and time. So are there any guidelines or calculation to estimate the required resources for model training in fixed amount of time?
So if I understand the question correctly, how much time or resources would it take for the model to train? Is that what the question is?
Yes.
Right. I think that, yeah, that's a good question. I think that there's a way to profile that, provided that you have a specific model, right? So let's say that you have this specific model, then you can have a approximate time of how much time it would take to train or how much resources it would take. But this is something that machine learning is kind of problematic for machine learning models right now, because remember that all of the machine learning that we are doing is without a theoretical database, without a theoretical framework. So let me explain a little bit. So when I say that it is without a theoretical framework, I mean that there's no way for me to come up with a model and predict the results before training all of them, or before evaluating it, or before deducing all of the things that I'm trying to do. So so that is one thing that needs more work on, especially the explainable AI model or explainable machine learning model. So this is one thing that is problematic and something that needs to be done. But right, so that is my take on that.
Right. So thank you, Fahad. We have a virtual shield for you.
All right.
Okay. So and I hope that some of the labs at KICS which are working in the similar areas will contact you for the collaboration. And as a lot of your students are from UET, so we might send you more students.
Absolutely. I always look forward to students from UET because I'm from UET as well, and we always have more positions, especially for hardworking PhD students. We have a lot of funding, we have a lot of resources, and people who have worked in machine learning models, people who have worked with high performance computing techniques, FPGA techniques, SoC techniques, so as you can imagine, we work in all of these different domains, right? So we need people in all of the different domains. So I will be very happy. You can just send me an email. I had that. I can send it to you, and you can distribute it. It's just fsaid@fiu.edu, and I will be happy to communicate with you.
Right. So thank you.
Thank
so
you.
now
Thank you very much.
we switch from the medical data to the advertising data. So our next speaker is Dr. Ingmar Weber. Ingmar, I apologize for the delay. We are 10 minutes late in the program. So Dr. Ingmar Weber is the research director for social computing at Qatar Computing Research Institute, QCRI. His interdisciplinary research looks at what online user-generated data can tell us about the offline world and society at large. He's working closely with socialists and demographers, and he has pioneered the use of online advertising data for complementing official statistics on international migration, digital gender gaps, and poverty. So prior to joining QCRI, Dr. Weber was a researcher at Yahoo Research, Barcelona. He's a ACM, IEEE, and AAI senior member, and I have just seen that he is now ACM distinguished member. So, Dr. Weber, over to you.
Yeah, thank you very much for the introduction, and thanks for the invitation to speak. I believe I need permission to share my screen. So if I could, yeah, perfect. Thank you so much. This has just happened. 1 second. It's here, share. Second. Okay, so hopefully you can see my title slide now.
Yes, we can see your slides.
Perfect, excellent. Yeah, so I think my talk is a bit different in nature than the previous ones, and that is very much sort of data-centric. It looks at an underused data source that you might not be aware of and what can be done with this, in particular from a sort of like open source or open intelligence point of view, which I think is also the sort of the theme, or at least in the name of the conference. Yeah, so before I dive into the actual sort of talk, just let me start with acknowledging a large number of collaborators who've contributed to this line of work. So here at TCRI, in particular, Joao and Pasumali, and at the University of Oxford, it's in particular Ricky Kashia. But there are many, many others, both at academic institutions as well as at UN agencies. Okay, so probably you've heard this slogan before, right? That if you're not paying for the product, then you are the product, right? And this in particular applies to, sort of social media in general, and to Facebook in particular. Okay, so what does it look like in practice? So this means that, in particular, Facebook, right, is collecting a lot of information about you, right? Sort of what sort of pages you're interacting with, what sort of posts you're putting out, right? All these kind of things, right? And this is then sort of analyzed and used to build a user profile with certain attributes, right? So, oh, we think you're interested in computer science or maybe these other things. Since that you're using this particular device, you're mostly connecting from this location, etc., etc., sort of, right? And then advertisers can use these attributes to target their ads, right? So let me give you just one example, right? So I can go to Facebook's advertising platform, today or right now, and I can say, okay, I would like to show my advertisement only to female Facebook users living in Karachi, age 25 to 34, who used to live in the USA, and to have access to an Android device, right? So quite specific, and I could be even more specific, but let's say at sort of this level. And then the important thing is that before I actually launch my advertising campaign, and so before I have to pay anything, Facebook provides so-called audience estimates. Right? This is usually used for campaign planning, right? And so in this particular case, the Facebook advertising platform would tell me that there are 1,400 users matching these criteria. So this essentially is a sort of real-time, no-cost sort of count oracle, right? Where I can sort of ask Facebook, hey, Facebook, how many users match a certain set of attributes, right? And so you can do a lot with these with the answers that you get back from this oracle. And again, I should emphasize, this is accessible for free by you. Like after this talk or whenever you have time, just sort of Google how to set up a Facebook advertising campaign and go through all the steps, but don't actually launch the advertising campaign. And you'll see those audience estimates, and I'll show you in a second what that actually looks like, the interface, right? So again, so this gives you a sort of, no-cost real-time census over more than 2 billion Facebook users. And so in my work, so we use this for a number of different projects, broadly related to international development, right? So I'll explain the particular sort of projects in more depth. But here, just a sort of screenshot of Facebook's advertising manager. So this is what the platform actually looks like. And again, it's accessible to you for free. I don't have any privileged access here. You have just as much access as I do. And so here, I was targeting people who are living in Doha, so the capital of Qatar. Right? So this is even sub-city level. Here I was looking at men who used to live either in India or Nepal, and also are using Android devices to access Facebook. The reason that we're interested in the device type, as you'll see later, is that the device type is a proxy for disposable income. So put very simply, if you have access to an iOS device, then by and large, usually you have more disposable income than if you're using Android devices. Of course, it doesn't hold in every sort of individual case, but sort of at the group level, this generally holds true. And so here for this targeting, up here you see the so-called potential reach. So this is the audience estimate that I was referring to, right? So here in this part of Doha, there are 42,000 people matching this criteria, right? So most of my talk will be about Facebook, but hopefully towards the end, I will have time to also talk about LinkedIn, because LinkedIn or anything else, also Twitter, Snapchat, so all these platforms have an advertising interface that looks like this, right? So here, this is LinkedIn's advertising platform, which again, it's accessible for free, by you just as much as by me. Here, I targeted people in Germany, female who studied at the University of Cambridge and have a PhD. And again, sort of LinkedIn tells me how many people match my targeting criteria. So what can you do with this data? It's sort of just a sort of like a visualization level. So here's one of several data visualizations that we've created around this data. So this data that you see here is not live data. This is data from 4 years ago. So just sort of this sort of proof of concept, where in this particular data visualization, I've selected Facebook users who used to live in Nepal. And then the data visualization tells me first where the density is highest. So the density is highest in the so-called industrial area, which is true, I can tell you, living here in Doha. But it's interesting that there's no official data for this, right? So even though I know this as a sort of resident here, again, you find something out that, for which there's actually no data, which is interesting, right? They're almost all men, which again is true, I can tell you, because these are sort of mostly construction workers, and they don't make the minimum threshold to bring over their families, sort of or so. Talk about this education level in a second. They're fairly young, which is a blessing at the moment, right? Related to COVID-19, this part of town has basically achieved sort of herd, immunity. More than 60%, I believe, by now have been infected. But fortunately, there have been very, very few deaths because they are so young, right? And here you see that they're almost all Android device users, right? And there are only very, very few who can afford iOS devices. Now, if you contrast this with a different demographic group, people from Western Europe and North America, they live in a completely different part of town, right? So I live actually sort of right here, sort of, so it was quite typical. It's roughly gender balanced. I'm here with my wife and my family. A lot of university graduates, they are older people, right? These are the knowledge experts. I'm still on this side of this bar, but many of my colleagues are on this side. And you have more iOS device users and Android device users, right? Sort of indicating higher disposable income, right? And so again, this is just a sort of visualization, and this is public. You can go to this URL. I will also drop links later in the chat. But just to give you like a sense of what you can do with this type of data. In the spirit of sort of open source, again, a theme of this sort of conference, I'll also be sharing those links later in the chat. So Facebook itself has a very good and well-documented so-called graph API, sort of also that you can sort of, use to get these audience estimates, but we've written some sort of repro libraries on top that make it even easier to collect such data, also LinkedIn data. And one thing that I would suggest that you also do, so when you have a chance, that you go to Facebook and LinkedIn and maybe other platforms, and you download the data that they have about you. So in particular, things that they believe that you are interested in. So this in this case would be sort of under ad preferences on Facebook. Some of those things might be obvious or nothing sort of surprising. Some of those things might be true and surprising, but also there's noisy things, right? They're saying, oh yeah, maybe, I don't know, a year ago I liked a post about, I don't know, coffee or something or whatever, and now Facebook thinks I'm interested in coffee, but that was just something my friend posted, or I don't know, there'll be some sort of weird things as well, right? So these are not, sort of errorless magic, know-all machines, but it's still interesting to know what these platforms have belief about you. So now, what do we do with this data, right? So there's a lot about data on billions of users, right? So that are contributing. So we mostly try to fill data related to international development, right? And so what's wrong with existing data sources on international development? Well, so there are basically sort of three things that are wrong. So one relates sort of to the speed of traditional data. So traditional data is often linked to things such as censuses, right? And censuses are done once every 10 years. And once a census is done, it's great, right? That's the best possible data you could hope for. But just imagine running a company with data that's 10 years old, right? I mean, you can't really work with that, right? And so recency is definitely one big issue. Another relates to sort of geographical disaggregation. So, for example, in the case of India, certain data points are available at the level of states, but you have a state such as Uttar Pradesh that has 200 million people in it, right? I mean, that's more than twice the size of Germany. So what does that mean, right? If you have one data point for that, I mean, that doesn't tell you anything, sort of. So you need more spatially disaggregated things. And then also importantly, beyond sort of spatial disaggregation, traditional data is often not sufficiently demographically disaggregated, for example, by gender or whether somebody is a migrant or not, right? But again, maybe the poverty among migrants might be very different than among non-migrants, or the life experience of women might be very different from those of men. But if that's all sort of, washed out sort of on an average, then you lose a lot of insights into what's going on in society, right? And so in our work, we try to address those things. So we try to sort of use this type of advertising data to have more recent data. So that's one aspect. We try to have something that's more spatially granular, so where possible have sort of subnational data, and also something that's disaggregated, in particular by gender. So the rest of my talk, I will talk about particular applications of sort of where we use this data for these sort of purposes related to digital gender gaps, monitoring international migration, mapping poverty, and then hopefully if there's a time at the end, I'll talk about LinkedIn data also related to migration and social capital. Let me just check time. Okay, good. So the first example I want to talk about relates to monitoring digital gender gaps. So let me first try to motivate why we're interested in this. So as of now, about 60% of the world's population has internet, right? Which is huge, sort of, right? And the majority of the planet has internet access. So that's great. But internet access is not equally distributed. So for example, to give you some examples, in Niger, for every one woman with internet access, you have 3 men with internet access. Iraq is slightly better, sort of, so the ratio is 1 to 2, but still clearly there's inequality in terms of internet access, right? But both Niger and Iraq are positive cases because they sort of collect this data and report it to the UN, in this case to the International Telecommunication Union. Right? So at least we know that there is a problem, right? Also sort of gender equality is one of the so-called 17 Sustainable Development Goals. So it's something that all countries worldwide sort of agreed on, that we just sort of strive for, right? And so there's an issue, but there's lack of data. So let me show you this lack of data also visually in a second. So we created a platform together with the University of Oxford and a small NGO called Data2X to try to address this data gap. And so here, let me first show you the data gap sort of visually. So on this screen, I'm showing you data from the ITU, the International Telecommunication Union. So this is official data collected by the governments and reported to the UN body, right? And so, for example, here in Germany, if I was hovering over this in the sort of interface, it would show a value of 0.96 or something, which basically means that for every 1 man with internet access, you have 0.96 women with internet access, right? So it's not quite parity, but it's sort of approaching parity, right? But then you have a lot of you have Niger that I mentioned before, right? You have Iraq, sort of that I mentioned before, that are quite far from equality. But then there are a lot of countries that are not reporting this data, right? Like sort of not even Canada is reporting this data, India, many other countries, right? And so in our work, we are then using data from Facebook and other data sources to build a model. Right? So now what I'm showing you, these are model predictions, right? So this is just a regression model where we make a prediction for the sort of female to male ratio of internet users in India, for example, right? Or in most of sub-Saharan Africa, right? And so now we are filling very visually, sort of filling most of the gender gaps for this sort of indicator, right? And for example, the value in India is 0.631, which, just for information, is slightly better than in Pakistan. I think Pakistan is sort of 0.6 in official data, if I'm not mistaken. So how does this work, and also how well does this work? So here I'm showing a model evaluation for 3 different types of models. So let me try to walk you through the different models and what they are sort of using as features. So all of these are very, very simple linear models, right? There's no deep learning going on here, so partly because we just don't have a lot of data points, right? At least for this work, we have only ground truth at the sort of country level for like 80, 90 or so countries. And so on this model on the far left, there's only a single predictive variable. I mean, apart from a constant intercept or sort of offset or whatever you want to sort of call it, we're only looking at the gender gap. This is this GG on Facebook. So what is the female to male ratio of Facebook users? Right? That's the only thing we're looking. We're just looking, okay, in Pakistan, how many women, how many men? In India, how many women, how many men? Right? And then we sort of divide one by the other, correcting for offline imbalance. So for example, here in Qatar, more than 70% of the population is male, right? Just because there are a lot of construction workers, right? And so given that, you would expect to see more men than women on the internet or on Facebook. So we have to sort of correct for that, So this is the predictive variable here. So the female to male ratio of Facebook users. Using only this single variable, and the constant, we can explain almost 70% of the variance, right? So this is this R squared right? So this sort of spatial variation across the countries for which we have ground truth data, right? It was pretty good. Again, it uses a single variable. Now this needs to be sort of compared against sort of traditional approaches. So a traditional approach would use econometric variables, right? So this is things like GDP per capita, or these other variables come from the Global Gender Gap Report, GGGR, that looks at sort of gender differences in terms of education, literacy, economic participation, et cetera, et cetera. Right? And so if you use sort of these traditional indicators, you get a model that actually performs slightly worse. Right? It uses more variables, but actually is not as good in modeling the spatial variation. Plus, it cannot make quite as many predictions because this data is not as widely available as data from Facebook. Now, if you combine the two, then at least for the countries where there is ground truth data, the model fit goes up even more. It's now sort of close to sort of 80% of the variation, which is really, really high, right? I need to say. But now, of course, there's a sort of trade-off because now you're relying on sort of 2 data sets to be available, and so then you can't make quite as many predictions, right? But here, just again, the punchline, even using Facebook alone works already very, very well. And so at the moment, we are now extending this work to also model a sub-national internet access gender gaps for the continent of Africa, and again, where again the Facebook data turns out to be the single strongest predictor, like stronger than sort of poverty indicators or anything else that we look at. As much as possible in our work, we try to go beyond just publications, and so we publish this work, and get cited, and everything is fine. But it's also become part of what's called the SDGs Today portal. So SDGs stand for the Sustainable Development Goals, right? Where on this data hub, there are only 3 data sets for gender equality. 2 come directly from the United Nations and 1 comes from us. So we're quite pleased, that they sort of chose to include this data in this data hub. Okay, so this was the first of 3 examples that I wanted to show for this Facebook data, looking at gender inequality. The next looks at international migration in the context of Venezuela. So maybe you're aware of what's going on or what was mostly going on in Venezuela. I think it's slightly stabilized now, but if not, let me just quickly sort of remind you. So I think it started in sort of 2015, 2016, but the number here I'm showing is from 2019, where in the country of Venezuela, right, so Venezuela is in the north of South America, there was an annual inflation of 10 million %. It's not a typo. I don't mean 10,000 or 10%. This is 10 million %, right? So this is absolute enormous hyper inflation. At that point, according to estimates from the IMF, International Monetary Fund, unemployment was upwards of 40%. And also importantly, if you were earning minimum wage, and if you spent every single peso, like every single bit of money that you earned on food, you could only afford to buy for yourself 1,000 calories a day. I'm sure most of you are aware that, an adult male such as myself needs 2,500 calories just to stay alive, basically, right? And so many people were literally starving. This is what's called the Maduro diet, right? And of course, in response to this, enormous economic and also political crisis, many people have left Venezuela, so upwards of 10% of the total population, right? So this is like at least 4.5 million. By now, it's probably above this. Most of them fled into sort of neighboring countries, sort of Colombia in particular, and some who were fortunate enough, managed to sort of flee further away. Now, during this type of large migration crisis, sort of data on how many people exactly have left and what type of people and where they are is always inaccurate and outdated, right? It's just for a number of sort of different reasons. Right? And so we try to see, can we actually use advertising data to help have somewhat more accurate sort of data, on what's going on. And so what I'm showing you here is data that we were collecting, and actually still are collecting, from Facebook's advertising platform, right? And so let me try to explain what you're sort of seeing. So let's look at just the data in red. So the data in red is for the host country of Colombia. So we're always looking at people from Venezuela, but here we're looking at the host country, at the destination country of Colombia. The lower sort of dashed line of this bar is just the raw number of people who are Facebook users who used to live in Venezuela, but at that point in time were living in Colombia. Previously, I showed you like a screenshot where it says lived in India or lived in Nepal, right? That's basically what you would get at that point. When you went to the advertising platform and you sort of looked, living in Colombia but lived in Venezuela previously, right? So at that point in time was about 1 million Facebook users. That's the lower bar. Now, if we assume that Facebook doesn't make any false positives, right? So that everybody classified as having lived in Venezuela is actually, from Venezuela, then this would be a lower bound, right? Because of course not everybody is on Facebook, right? And so what we try to do here in this upper bar data points, we try to correct for the people who are not on Facebook, right? So for this, we need to know that Facebook penetration among Venezuelan migrants. Now, we don't know the Facebook penetration among Venezuelan migrants, but we assume, and this is a simplified assumption, that the Facebook penetration among the Venezuelan migrants in Colombia is the same as the Facebook penetration in the overall Colombian population. So basically, we look at, okay, what's the population in Colombia? Of those, how many are on Facebook? It's about 60%, if I'm not mistaken. So then we sort of assume, okay, so here, this value is sort of missing 40%. So we are sort of adding 40% on top, right? So this is just a very, very simple sort of bias correction or whatever sort of you want to sort of call it. Right? So most likely this upper value is sort of closer to the truth, although it's definitely not, precise, right? So now you can sort of see how it changes over time. Now, how good are these estimates, right? And so usually in machine learning, you would compare to some sort of ground truth sort of data And so we try to do this, but one difficulty is that the ground truth is bad to begin with, right? I mean, we're doing this work because the ground truth is bad. Because the ground truth is bad, it's hard for us to ultimately evaluate some of these predictions. Still, just to sort of show you that at least if you look at sort of official UN estimates that came out around the same time, and even UN estimates themselves, as you can see, are sort of inconsistent depending on which report you read. It's certainly in a sort of plausible range and so on. And typically these official numbers are underestimates. So certainly what you get from so Facebook, so it's certainly plausible to say the least. So let's look at this a bit more closely, So we were working with people in Colombia, actually during the response. So again, this was not just an academic exercise; there was a direct operational impact of this work. And so we, they also shared data from the Colombian government. And so here on the left, I'm showing you data on the number of Venezuelan migrants and refugees across Colombia. This is now subnationally, right? And so this data was collected through self-registration efforts. So basically, migrants and refugees were asked, please come and register yourself, to be counted, right? So this is where this data on the left comes from. The data on the right, collected at the same time, comes from this Facebook advertising platform. Now you see there are some similarities, right? So, for example, here in Norte de Santander on the border, right, they are pretty close, in close agreement. But then Facebook, estimates a larger number of Venezuelan migrants and refugees sort of further away from the border, right? So now again, who's right? Well, we don't know for sure, but again, because we were working with people in Colombia on this response, they actually told us that, this distribution is more plausible or is more in line with what they see on the ground than the data from the Colombian government. That's interesting, right? If you think about it, right? That like a big company such as Facebook might have better migration data than a company, right? Than a government, sort of, right? So this both interesting, scary, whatever, sort of, right? Again, ultimately we don't know for sure, but again, people on the ground tell us that this is probably closer to the truth than the data on the left. We also, obtained subnational estimates for other countries. For those countries, no ground truth subnationally exists, sort of, right? So again, here we don't have anything to compare against. And here, just to mention again, some of these findings had operational impact. So, for example, here, just knowing that there seem to be, Venezuelans further south in Brazil led to UNICEF adjusting anti-xenophobia campaign they were running in Brazil. So basically, there was a lot of hostility directed at Venezuelan migrants, and so they were trying to run a campaign to limit that. And initially, that campaign was only targeting the north, but then later they adjusted their targeting also to the south based on our findings. Last thing I want to show on this line of work is that you can go beyond just the sheer number of people. Just knowing how many people, that's definitely important. And again, even, just knowing that is a huge help. But ultimately, it depends on how vulnerable they are, right? Like, for example, here, I'm a migrant in Qatar. If tomorrow there's some whatever minor crisis or sort of so, you don't have to worry about me. I can take care of myself, right? I have, the appropriate sort of resources, right? But the same might not be true for a Nepali migrant worker, right? Sort of, right? So we are both migrants, but very, very different sort of situation, right? So how can we go beyond just sheer number? And again, I already mentioned before that we can look at the operating system of the mobile devices people use to connect to Facebook. So, okay, so let me try to explain what you're sort of seeing here. So in this sort of bar chart, every bar again corresponds to a host country or region. We're always looking at people from Venezuela, but this bar on the far right talks about people from Venezuela in the United States. Okay. Now this ordering from left to right is according to the percentage of these Venezuelans using iOS devices. So people who at that point in time were living in Roraima in Brazil, which is the jungle. Right on the border, most people were just walking across the border, right, from one jungle into the other sort of jungle. You had almost no iOS users among those, less than 3%, very, very low, right? At the other end of the extreme, people who make it all the way to the United States, they actually have a majority of Facebook users using iOS devices, 54% at that point in time, right? So this induces this order, right? So the order is according to percentage iOS. So now, what about the y-axis, right? The height of these bars, right? How can we map 3% to a value of, I don't know, $3,000 US, right? How does that work? So the way that this works is that we first try to predict country level GDP per capita. So basically we sort of we train a model that predicts the per capita GDP in Chile, in Argentina, in Curacao, in Aruba, etc. So according to official data, nothing related to migration, just overall per capita GDP, knowing only the percentage of Facebook users using iOS devices. Right? So if I tell you that in Chile, I don't know, 40% of Facebook users are using iOS devices, probably less, but let's stick to the number sort of. Then you can actually come up with a sort of mental, okay, 40% that maps to maybe, I don't know, $25,000 or something, right? And so this simple model using a single variable, it does a very, very good job at modeling per capita GDP across those countries. Now that model is then applied to the subset of Facebook users who used to live in Venezuela. right? So this is then where we get these estimates on the y-axis from, right? And again, we're not certain about the precise dollar number, right? And there's also obviously individual fluctuation, but in all of our work, we always find these three groups. Like also if we try other features or so there are always these three groups. So these are always sort of worst off. These are somewhere in the middle, and these are sort of least concern, right? So at least at that sort of level of granularity, we're quite confident that these findings are not just a fluke, but that they actually do reflect the reality on the ground. Versus precise ordering between these two countries or so that's that might be a fluke, or that might not be reliable. Again, as before, again there was operational impact of this work, and to this day it continues to be used through an NGO called IMAP that also works with USAID or USAID on the Venezuelan response in Colombia. The last example I want to show, at least on the Facebook side, okay, so have some time, relates to mapping poverty. And this is a joint work with UNICEF and a data science company called Thinking Machines based in the Philippines. So just one slide again for motivation. So as with gender equality, no poverty is one of these 17 sustainable development goals. How is poverty defined? There are many different definitions of sort of. So one definition that the World Bank uses looks at income and defines as extreme poverty as earning less than $1.25 per day. But again, there are other definitions, and we'll come to that later. If you look at the most recently available poverty data, it's often quite old. So again, this relates to sort of census and census data being available. So here are some sort of countries where the data is, 10 years or older. And apart from this being data outdated, so often it also lacks spatial granularity, right? This is something that I mentioned before, right? So if I tell you that like a whole region or sort of is poor, well, there's not much you can do about it, right? In terms of intervention, you need something more granular, right? Like ideally at the sort of sub-city level. So, okay, so how do we go about this, right? I mean, in essence, it's just another sort of regression task, but let me try to spell it out in a bit more detail. So for this particular project, we use data from USAID, who sponsors a so-called demographic and health survey. So this is a fairly large household survey where they would go from household to household. They would ask a bunch of questions, and some of these questions relate to asset ownership. So they would ask, do you have a fridge? Do you have a mobile phone? Do you have running water, et cetera, right? And so then all these sort of questions are sort of compiled into a so-called wealth index, like a single number done using a principal component analysis, where so this number basically sort of summarizes how much stuff somebody has. Like a large positive number means they have a lot of stuff. A large negative number means they have almost no stuff. So that's sort of the target variable that we would like to predict for sort of non-surveyed location, right? And then, okay, how would we like to predict this, right? What are the sort of the predicting features, right? And so one important feature is just the percentage of Facebook users of the total population. In other words, the Facebook penetration. Right? So we can estimate from the advertising platform how many Facebook users there are in a given location. And then there are other population estimates based mostly on satellite imagery that tell us, even at the sort of sub-city level, how many people live in a given neighborhood, right? And then we would sort of divide one by the other to have a sort of estimate of the local Facebook penetration rate, right? So this itself turns out to be like a strong predictor, just knowing the percentage of the population on Facebook. But then there are other features, right? I mean, I already mentioned the operating system being an important one, but there are also features related to the connectivity type. So what's the percentage of Facebook users connecting using 4G or Wi-Fi or 3G, et cetera, sort of. Right? And so all of those become sort of different features. And then once you have your sort of your target variable and your features, it's just a standard regression task. Again, you can sort of throw your sort of favorite regression model at it, and we've tried sort of different things, but that's usually not at least in our observation, so that's not where the biggest sort of differences sort of come from. Like most of these models perform more or less similarly on this sort of type of data, whereas the sort of the choice of features to consider mattered sort of more on the performance. So in this particular case, what worked best in the end were sort of gradient boosting machines. But again, you could have used other sort of models and you have more or less sort of similar results. So how well do these models work, or how well do these features rather work? Again, we're more interested in the data side, so in a sense, rather than sort of the particular model. So let me try to walk you through these results. So first we have to think, okay, what is the baseline, right? Like if I, you don't need Facebook to have some sort of intuition, about whether a neighborhood might be, sort of rich or poor, sort of and so on. So one, fairly strong baseline is derived from interpolating from neighbors, right? So maybe you don't have anything about this particular neighborhood, but you have data for nearby neighbors, right? So then you say, well, all your neighbors, all your neighborhoods rather, right, so are fairly poor. Therefore, well, probably you're poor, sort of, or your neighborhood is poor, right? So this is what this sort of feature, and this actually works already quite well, sort of. So in India, this already explains almost 2/3 of the spatial variation, and this is in a sort of cross-validated manner. And in the Philippines, not quite as well, but still closer to 50% of the sort of spatial variation in this wealth index is explained solely by looking at your sort of neighbors. Then, as a sort of second feature is now, okay, what happens if we use only these Facebook features, right? So they're sort of mentioned so nothing else, right? And again, this performs quite well. In the Philippines, it already beats this baseline. In India, it doesn't beat the baseline, but still, performing quite respectively, right? And then sort of can sort of combine everything together, including population density, that basically sort of rural versus urban, right? Might have sort of different dynamics. Also a regional indicator, right? Maybe the poverty dynamics in the northern part of Philippines is different from the sort of southern part. That sort of improves then the model performance further. One interesting aspect of this work that we did is so we also try to get a sense of the task difficulty. Right? We sort of try to find, okay, what's an upper bound, right? And why would there be an upper bound? Well, the reason that there is an upper bound, in this particular case, is again that the ground truth is not perfect. And so, okay, so why is, what's wrong with the ground truth? So, well, two things. So first is, of course, it's just a sample, right? It's not an exhaustive survey, right? And if I sample 10 households today, maybe, and I had sampled 10 households tomorrow, I'll get slightly different, results, right? And you can estimate that, sort of through things such as sort of bootstrap resampling, right? To get like some sort of, estimate of, how much is just their sort of sampling noise, right? So that's one source of uncertainty, right? So this is sort of usual sort of sampling noise. But then the other source of noise relates to the fact that DHS deliberately perturbs or spatially perturbs its data. It means it doesn't tell you the true location of a neighborhood, but it perturbs it up to even 10 kilometers, right? So in most cases between sort of 2 and 5 kilometers, right? They do this to protect privacy, right? So even though it's already aggregate, right? So that you don't know, have a sense of who might have contributed to the survey. But of course, that further lowers the quality of the ground truth data. And through simulations, we show that sort of these two things combined, the sampling noise and the spatial perturbation, mean that there's an upper bound where no method that does not just memorize the data, right? Of course, you can memorize the data, but that any method that does not just memorize the data can sort of beat an upper bound of an R squared of around sort of 85%, right? And so here, we're getting sort of 73 or 63%, but you sort of have to scale it up a bit, so whereas effectively this might already be sort of close to 70%. This is probably, well, not 80%, but it's sort of approaching 80% of the sort of explainable variance. Okay, so this is aggregate. This is overall just one value per neighborhood. That's nice, that's great, that's valuable, but we want to do more, right? So we want to disaggregate by different things. So starting with education level, right? So maybe well-educated people in a particular neighborhood are doing fine, right? It's only the uneducated, or maybe everybody is suffering, right? Sort of can we do this? And so for this, we looked at the self-declared education level on Facebook. So the model was trained without having ground truth on sort of education level disaggregated wealth index, right? It's just this area overall has a high wealth index alone. And so this model, but then we apply this model, which is trained, not disaggregated, just to sort of disaggregated subsets. And so that's sort of interesting, sort of. So now, you know, sort of, and so using this, we would apply it separately to Facebook users who have more than a high school degree or who have a high school degree or less, as self-declared as on sort of Facebook, right? And so every data point here is a location. I think of it as a sort of neighborhood, right? And so the locations above this identity line are the locations where the model would predict that well-educated people are better off, right? They have a higher wealth index than people without an education, without higher education, right? And so by and large, so most data points are, are above the identity line, right? And so that's sort of reassuring, right? That's sort of plausible. That makes that makes sense, right? So this is like a plausible. So I think it would be interesting to do some on-the-ground validation for some of these outliers where it's interestingly sort of below the equality. So okay, so this is looking promising. Okay, interesting. But then we were also interested in looking at gender disaggregated poverty predictions, right? So maybe the household's doing fine, but it's only the male head of the household that's in control of all the resources, right? So again, for this same approach, right, we have this sort of non-disaggregated model, and we apply it separately to women and men, right? Then we're getting this picture, right, where again here it's the area where women are predicted to do better. Here's the area of where men are predicted to do better, right? And there's like, that looks pretty close to equality. Well, that sounds great, but that's actually not plausible, at least not for India, So if you look at offline data from the Global Gender Gap Report, it would typically rank India and sadly also Pakistan, I should add, towards the bottom in terms of gender equality, right? So here, if we claim gender equality here, there's something wrong, So how can this be? So what's going on? Why is our model giving something that's not even plausible at face value? And so what's going on here is the so-called Jackie Robinson effect. So it's a particular type of survivorship bias. So Jackie Robinson was the first African-American Major League Baseball player, right? I think he started in the 40s or 50s, right? And for him to make it in the major leagues, right, despite all the racism, right, like as an African-American, he had to be exceptional, right? If he had been just as good as another white guy, no coach would have selected him, right? And so now, if you look at his record, right, you see, wow, that was really, really good, And then if you extrapolate out to everybody, you would say, all African Americans must be amazing, baseball players because those are the only ones I see, right? But of course, again, this is due to the survivorship bias, right? Like he had to be exceptional to make it that far. And so something similar happens here in India and in Pakistan and many other countries where there are relatively few women on Facebook, but those women who are on Facebook are exceptional. They are more likely than an average man to have the latest iPhone. They're more likely than the average man to have university education, et cetera, right? And so now if you then extrapolate out from this set of women you see to the all womanhood, you think all women must be doing well, where in fact actually it's the opposite, right? So this is now one of the challenges in dealing with this type of data, right? And so one way to address this is that you use other features that you don't look, for example, at the operating system as a feature, but you only look at the Facebook penetration as a single predictive feature. That still gives you a model that performs okay, but not as good as the more complex model previously. But this model seems to be less biased or more plausible, at least in terms of gender disaggregated predictions. So now you see that in every single location, because the Facebook penetration for men is higher than the Facebook penetration for women, we will predict that the wealth index for men is higher than the wealth index for women. Again, also here, this went beyond just a paper and because we worked with this company Thinking Machines, they integrated this feature set together with other features in work that they did for UNDP for mapping poverty in the Philippines. It's not the only feature. They also used other sort of satellite-based features and OpenStreetMap features, but this is one of the most strongly predictive features that they continue to use in their models. Okay, so I think I'll have time to also talk about sort of LinkedIn at least a bit. Yeah, so this was on Facebook, but also what about sort of LinkedIn, right? I'll just quickly show you sort of what you can potentially do with LinkedIn. So LinkedIn does not let you target people based on sort of country of origin directly, but you can target LinkedIn users for advertising based on where they studied, right? Like in the opening, one of the opening slides, I had this example of somebody who studied at the University of Cambridge. So you can basically, you know, collect all the universities in Pakistan, let's say, right? And then sort of say, okay, somebody who studied at any of these universities and is now working in Qatar. Now, the person might not have a Pakistani passport, but at least somebody studied in Pakistan, now working in Qatar, for example, right? So this is what we sort of did here, sort of, right? And so here we looked at sort of people who, yeah, for example, so what is this sort of, you know, maybe we've seen sort of diagrams before. They're quite common in sort of migration studies. So this blue arrow here means 110,000 LinkedIn users studied in the UK. This is a sort of, you know, origin, and worked in Germany, right, in 2018 when we collected this data. So what can you read from this sort of a diagram, So first you read that the UK is a sort of education source, right? So the sort of the outgoing bit is bigger than the incoming bit, right? So there are more people that sort of study in the UK and then work abroad than there are people who sort of study abroad and then work in the UK, right? And that, you know, makes sense, sort of. So that's sort of plausible. Where sort of Germany is sort of it's the other way around, sort of. Right? So Germany is an education sink, right? There are more people who study abroad than sort of the other way around. And it's sort of interesting that you're going to do this. Just sort of like a sort of proof of concept or sort of. And another bit of work that we are doing looks at social capital, so it's sort of social networks in particular, right? So you know, let's look at sort of 2 LinkedIn users in the US working in IT, but not at the big 5, right? So not at Amazon, Facebook, Microsoft, I forget, Netflix, and Apple, sort of, right? And so let's imagine that maybe the female IT worker knows people at Amazon and Facebook, but the male IT worker is better socially connected and knows people at all the big companies, right? So what does it mean for sort of long-term career progression, right? So maybe they're equally good, but because of sort of social capital, right? Like the male IT worker is more likely to learn about job offers or is being contacted by recruiters, etc. Like sort of this, right? And so we look at this by through the LinkedIn advertising data. But first we look at the sort of seniority of people in IT in the US, right? Where we sort of see that, so this is entry level and then becomes gradually more senior, that the percentage of female LinkedIn users declines as you go up the ranks. That's known, right? Whereas the percentage of male users goes up. It doesn't add up to 100 because LinkedIn tries to infer the gender based on your name and other things, and it does not always you know, sort of make a judgment, sort of, right? So this is known, right? So that you go up the career ladder, sadly, there are fewer and fewer women remaining in IT, right? That's not news. But this thing on the right is new, sort of, right? So now we're looking at the percentage of those women, in this case at the entry level, who have social connections to the big 5. Right? So in this case, it's sort of 13% of women as opposed to almost 20% of men. Right? And now, as you go up the career, and this is the ratio of, so there's a gap at the entry level, right? And so as you go up the career level, both men and women are better and better sort of connected, but also the gap sort of seems to become smaller and smaller, right? Sort of. So at the VP level, the few women who are remaining are just as socially, you know, well connected as the men at that level, or almost, sort of, right? And so that's now interesting, right? So what is the sort of the source and effect, sort of this reverse causality, but also the thing that we are sort of currently sort of exploring using LinkedIn data. Okay, so then to wrap up and hopefully then have a tiny bit of time for questions. So so what I showed you, you know, was for sort of Facebook and LinkedIn, but again, I could have shown you Twitter, Weibo, sort of Google. They all have an advertising platform like this, right? Sort of, right? And so I just want to make this sort of clear. And all of those are accessible for free Again, I don't have any private privileged access to this data. You have just as much access as I do. The data is easy to collect programmatically through APIs. Again, I will share some links in the chat later, or reach out to me if you know, in case I forget or you can't access the chat. So, these estimates are near real time. I mean, not really real time as of sort of today, right? But typically like maybe plus minus, a week or so, right? Which for international development is super real time, right? Sort of 10 years compared to 1 week. I mean, that's real time, right? It's anonymous and aggregate sort of. So we don't have individual level data, right? I can't do sentiment analysis. I don't know who these users are, which generally is a plus, right? Like at least because I don't care. I don't want to know who these users are, right? I just want to know how many. And there's a very large number of sort of attributes I can use, right? Gender, age, location, country of origin, and many, many other things that I did not show. So that's all great and paints a very rosy picture. But there are also sort of some downsides, right? So first, of course, we're sitting on top of a black box, right? If you ask me, how does Facebook exactly know that somebody used to live in Venezuela? I don't know, right? Like I have some ideas we can discuss sort of, but ultimately it's a black box. I don't know how exactly it works, right? Empirically, they seem to do a good job, but I don't know how exactly they're doing it, right? There's a lot of bias in this, right? So I mean, both in terms of, I showed this sort of Jackie Robinson effect sort of also, right? Or I showed this problem of sort of undercounting people, right? Without, who are not on Facebook, right? So you need to think about how to deal with these sort of things, right? You can't just sort of take the raw number and, off you go. Users patterns also change over time, right? So, if you have a model that works today, 10 years from now, it's definitely not going to work, right? But maybe even 2 years from now, you'll probably need to sort of, readjust and fine tune, because how people engage with these platforms and who's on the platforms, of course, also changes over time, right? Another limitation is that there's no historic data available, right? If you know something, oh, this looks great. I would like to have this sort of data for Facebook in 2017. I say, sorry, I don't have that sort of, right? Like Facebook, it's only if you launch an advertising campaign today, right? So you have to build your own data set sort of, starting today going forward. We have some national level data that we've been collecting for a while, right? So if you just want some sort of national level estimate, come talk to me. But again, otherwise you have to sort of build up your own data set. And last and not least, there's a risk of misuse of this sort of data, right? So it's quite powerful. So I showed you that you can identify migrant groups, right? And we work with you at agencies who hopefully will try to support and help those people, right? That's our motivation, right? But migrants are not everybody we're welcome, right? So for example, if you think about the sort of, or even before there are migrants, right? So if you think about the Rohingya in Myanmar, the question is, well, could we identify vulnerable groups sort of, right? Now, in the case of the Rohingya, we cannot, because they are so disenfranchised that by and large, they don't even have internet access, let alone Facebook. But there are other groups, right? For example, I can draw a map of where in Germany people are interested in Jewish holidays or in kosher food, right? Sort of. So right now, being German, knowing about German history and the Holocaust, that gives me pause, right? That I can sort of, basically map, religious minorities in the country, right? Now, I might not find anything surprising, right? Probably they're mostly in, Hamburg, Berlin, Munich, the big cities, right? Where you have a lot of everything, right? But maybe there's something surprising there, right? And you could imagine that, another government might actually abuse this, right? So I definitely don't want to hide this. So this data set can definitely potentially be abused for evil. And then the last thing is sort of to mention sort of also is everything I showed so far is sort of passive, right? We just collect data about how many people, without the Facebook users actually being aware, sort of, right? But you can also use these advertising platforms actively, right? You can actually launch an ad campaign. So here on the left, I'm showing an ad, for example, that we were running in India to recruit people into a survey. So we had an online survey where we asked about PTM usage, and we were sort of targeting it to women in different parts of India that were sort of small business owners, right? Sort of. So and so on. This is a very sort of targeted survey recruitment you can do, right? Or at the moment, another example is at the moment here in Qatar, we're working on precision public health campaigns, where rather than having a sort of public health campaign that's one size fits all, right? Like, okay, breast cancer, okay? You can say, well, maybe I have to, adjust my message based on who I'm talking to, right? Maybe some, if I want to motivate people to sort of get screened for breast cancer, maybe some women are more individualistic, others are more family oriented. and maybe I can sort of target those differently, and I can identify those relevant subgroups on Facebook, right? I mean, that's just marketing 101, but in the sort of public health domain, that's not really done. And then the final slide. Again, this work is usually motivated by, we just need better data, and then the world will be a better place, right? The decision makers will know what to do, right? I mean, it's a data problem, right? That's why we have poverty, right? That's why we have gender equality. We just don't have enough data. But of course, that's a bit. I mean, that's ultimately a bit naive, right? I mean, when it comes to things like global warming, we've had good data on global warming for decades, and still, decision makers are not acting, right? So, in all this line of work, but you have to be sort of humble as in sort of how much it's really a data problem or how much sort of other things that need to change, right? But hopefully still better data can at least help to highlight sort of these issues. But again, just having better data itself will not fix those issues. So thank you very much. I will drop some links later in the chat, but feel free to take a screenshot of this if you want to have my email address and website with more publications. And hopefully, I know we started a bit late, but maybe we have time for one or two questions at least. So,
yeah. So thank you, Ingmar, for a very informative talks. So I have a couple of questions. I think most of you have highlighted in the last slide with the plus and the minuses. But the question is that how the fake and spam accounts can be adjusted in equation when you calculate the digital gender gaps?
Sure. Yeah, very good question. So yeah. Okay. Yeah. Usually they estimate that about 10% of users are fake users, or sort of, right? And so now, okay, how does this affect our estimates? So it depends on whether there's sort of spatial heterogeneity in how many fake users there are. So let's assume that it's just sort of globally 10%, right? It's just a global concept. Just 10% everywhere are fake users. So even if we assume that, it's 10% of men and 20% of women are fake accounts everywhere. In that case, it's not a problem because it kind of gets absorbed in the regression task, right? The regression model sort of learns to adjust for this sort of bias or the data quality issue. Now, what is a problem or potentially a problem is if there's like one country, let's say, in Zambia, it's making this up, right? So suppose in Zambia, all the female accounts we see are fake, or most of them, whatever sort of, right? But not in other countries, right? So then we would have trained a model that's sort of trained on other countries where the bias is sort of different, and then applied in this context, right? And then, of course, our model would be, off the mark. We haven't seen these sort of things, or at least at least in our evaluation, we have not come across this, whereas we believe that our model is off because of sort of fake accounts, but it's certainly something to keep in mind, right? And one more thing, so again, if we have sort of ground truth data, then usually the sort of regression / calibration absorbs this noise. If we don't have ground truth data, then hopefully the relative trends are still true, right? Like there's more here than there, or the numbers is going up or down, right? So hopefully that's more stable, even when faced with data quality issues. Now, again, that might not always be true. If tomorrow there's a campaign for young men to create fake accounts, whatever, then we might see some spike or something that's due to something that's not real. But again, we have not really seen that on sort of large scale so far.
Right. So the next question is that you mentioned that there's no historic data available. If you want to go back and then see, okay, what happened in, let's say, in 2019 or something like that. With your research, the data you have already collected, is it available for other researchers?
Yeah, definitely sort of contact me, but it's very sort of coarse. So it's like sort of country level in 2018, how many women were on Facebook in Pakistan, right? If that number is of interest to you, get in touch. So some data is also available through this digitalgendergaps.org sort of platform directly. So contact me directly if you want this. But again, it's fairly coarse grained. So if you want, for most projects, it might not be enough. But if just country level data is enough, definitely get in touch.
Right. And the final question is, can we also use some data fusion from different social media platforms to estimate gender gaps instead of just one?
Yeah, absolutely. So we've tried this in particular using sort of Google data, and the model improved a tiny bit, but not much. So by and large, using just Facebook alone was sort of almost as good as sort of bringing in data from Google's advertising platform. But there might be other contexts where there's more value. In our work, I think there's more value of fusing it with other data, such as satellite imagery. So, for example, just to mention, when it comes to mapping poverty, we've done some work where we combine it with high-resolution data from imagery, and there seems to be some nice complementarities in the sense that in urban areas, Facebook data seems to be more informative than satellite imagery. But in rural areas where there's lower Facebook penetration, satellite imagery seems to be more, discriminative than sort of Facebook data, right? So this sort of data fusion is definitely well worth looking into.
Right. So thank you, Dr. Weber. Now we have a virtual sheet for you.
Oh, thank you so much. And I will drop the links here, or again, if somebody doesn't see a link, please reach out to me by email or Twitter or sort of so on. I will share the slides and everything, but I will also be dropping links here soon.
Right, good. So my group will be contacting you in this kind of a work. So we are doing the similar work. So hopefully we'll contact you. Okay.
Excellent.
Thank you. Thank you very much. So with this, I announce the closure of this session. So we will rejoin the session at 2 p.m. local time, and then we will have some 2 industry talks. Okay, then see you at 2 p.m.
Assalamu alaikum. Dr. Amir Saab, thank you for your staying with us as a session chair. We will have also a virtual shield for you as well. Thank you very much.
Thank you. Thank you.
Welcome.
Al-Khwarizmi Institute of Computer Science, KICS, today stands along with the advanced technology centers of the country. According to the Joint Survey of Knowledge Platform Singapore and British Council, KICS was highlighted as the pioneer initiative among the research organizations in Pakistan. The institute is geared up to provide the country with trained resources and research staff for development of high-tech products and services, to exercise commercialization through incubation of high-tech companies, and to promote R&D culture in the country through technology innovation and industrial collaborations. More than 250 individuals, including PhDs, MPhils, master degrees, and administrative staff, are well-focused and passionate about their jobs. Currently, 26 labs are operating at the institute, which are working on various research areas, including artificial intelligence, communication technologies, software development, power systems, industrial automation, language engineering, technology incubation, and media studies.
Activites Institute of Computer Science has provided a platform in the education sector in Pakistan, where we have developed solutions not only for the industrial sector in our nation, but also for the private sector and public sector.
More than 100 projects funded by local and international entities so far have been successfully completed. Notable projects that are being worked on presently at KICS include Urdu Search Engine, Brain Informatics, Classification. high-tech companies and to promote R&D culture in the country through technology innovation and industrial collaborations. Established in August 2002 with an intention of conducting research and development activities in the areas of information technology and computer science. Al-Khwarizmi Institute of Computer Science, KICS, today stands along with the advanced technology centers of the country. According to the Joint Survey of Knowledge Platform Singapore and British Council, KICS was highlighted as the pioneer initiative among the research organizations in Pakistan. The institute is geared up to provide the country with trained resources and research staff for development of high-tech products and services, to exercise commercialization through incubation of high-tech companies, and to promote R&D culture in the country through technology innovation and industrial collaboration. More than 250 individuals, including PhDs, MPhils, master degrees, and administrative staff, are well focused and passionate about their jobs. Currently, 26 labs are operating at the institute, which are working on various research areas including artificial intelligence, communication technologies, software development, power systems, industrial automation, language engineering, technology incubation, and media studies.
Activites Institute of Computer Science has provided a platform in the education sector in Pakistan, where we have developed solutions not only for the industrial sector in our nation, but also for the private sector and public sector.
More than 100 projects funded by local and international entities so far have been successfully completed. Notable projects that are being worked on presently at KICS include Urdu Search Engine, Brain Informatics, classification and modeling of brain data,
I am Muzammil Hassan, working as a manager research in Software System Research Lab. Software System Research Lab is one of the most pioneer lab of Al-Khwarizmi Institute of Computer Science, UET Lahore. Our main purpose, I am Muzammil Hassan, working as a manager research in Software System Research Lab. Software System Research Lab is one of the most pioneer lab of Al-Khwarizmi Institute of Computer Science, UET Lahore. Our main purpose is to deliver high quality open source system technologies softwares. We have delivered so many projects in open source system and technologies to serve the university and for public and private sectors. Our main agenda is to deliver not only the quality assurance services, including trainings, software development, and mobile application development or web development. Recently we have launched a good platform for one of the universities, one of the best general management system, which was launched back 5 years ago, named as Pakistan Journal of Engineering and Applied Sciences, UET Lahore. Pakistan Journal of Engineering and Applied Sciences, UET Lahore is actually a publishing system delivered back 5 years ago under the editorial board of UET Lahore. Basically, this publishing system was recognized by HSE X category journal. This journal includes more than 2,000 users, including 1,300 authors, 700 reviewers, and 40 section editors and 5 journal managers. So, being a huge crowd on this journal system, university needs an automated system. So, we have decided to study in thoroughly and decided to launch this system using open source journal management system named as OJS. OJS is basically the open source developed software for the solution of providing the publishing system and providing the reviewing process for the different journal management system. So we have decided to launch in back 2015, and that was, I remember that it was the 2.0.4 version, which was currently outdated, and the users really facing difficulties, so that we have to rethink about this to upgrade this system. And now this is upgraded to the latest version, that is 3.0.8. But during this journey, by transformation from oldest from the old version of the journal system towards the new journal of OJS, we have faced so many difficulties, because new general management system requires latest hosting services, latest machines, and latest platforms for hosting and deployment. So without any downtime, we have not only upgraded all these softwares, but also we have upgraded the open source towards this new version. Now it has been successfully launched, and the users are using very satisfactorily, and we have launched this system recently, and we have no more facing any difficulties, and users are not facing any difficulties by keeping this latest version on our system. Many customers, many other institutes have also contacted us to adopt this general system, and we are happily open for all those institutes which want to transform or digitalize their online journal system towards this publishing system. We have experience for in this service, in this area. We are available, and to contact me, you can view my contact number on the screen. My email address is also given on the screen, and about what the milestones we have achieved in our labs is also you can visit our website, and our screen is showing you the latest contact numbers. Thank you so much.
Assalamu alaikum. My name is Mehwish Nadeem. I'm working as an assistant manager research in Power System Lab at Al-Khwarizmi Institute of Computer Science. The project I'm going to present is Unmanned Remote Grid Control and Monitoring System. The system comprises of mainly two parts. The first one is the hardware device that work as a data acquisition and control system, whereas the second part is the remote grid control monitoring web portal. A web portal basically provides the comprehensive dashboard that helps to identify the different faults such as instantaneous trip, earth fault trip, overcurrent trip, and DC unhealthy. These faults occur in the transmission lines that are connected with the grid stations, as well as it controls the load shedding remotely. There are two types of devices. The first type is deployed on 11 kV feeder panel, whereas the second type is deployed on the power transformer panels of 132/66 kV at the unmanned grid station. The hardware devices detect the different faults and send the information via GPRS GSM medium to the concerning control room. The interactive dashboard installed in the control room receive the information from the hardware devices and show the current status of the system. Additionally, the operators can operate remotely, switch on or off the circuit breakers from the incoming and outgoing feeder panels at grid station. The key features of the projects are the remote grid control functionality, the auto detect faults and alarms, the authorized access of devices, the interactive dashboard, event loggings, and the remote load shedding management. Thank you. Data communicator for grid control system. Earlier, UET Lahore has developed a system for unmanned remote grid control and monitoring system designed for 220, 132/66 kV grid stations. An improved variant of the remote grid control system with the data communicator and sensory circuit integration over the Wi-Fi equipment has been developed. The system comprises of the data communicator that collect the grid indications and fault monitoring data from the sensory circuits via Wi-Fi devices and communicate to the central data acquisition server through the GSM medium. The hardware device provide the more reliable data acquisition and grid operations, sufficient network connectivity, and the second part is the web portal that provide the comprehensive dashboard to identify the various faults that occur on the transmission lines at the grid stations. This project is an indigenous effort to provide the cost-effective solution and remote control of feeders of 11 kV and transformers and line base. The key features of the project are the improved grid performance, the authorized access of devices, interactive dashboard, the data collection via data communicator, the Wi-Fi based communication, and the load shedding management remotely. Thank you.
Assalamu alaikum. My name is Hamad Hassan. I am working as a manager research and development in Al-Khwarizmi Institute of Computer Science, UET Lahore. Our group is being led by Professor Dr. Muhammad Tahir, and we are actively working in development of real-time autonomous solutions for various kind of applications. Security and surveillance is one of the applications we are working with, and thus we have developed a complete solution named AUDIRE, Audio Vigilance Solution. Our solution is capable of performing real-time acoustic detection, localization, and can generate a response in no time for any incident that has occurred. In our solution, we can sense any acoustic sound. For example, we have a gunshot and we have a screaming, we have another sound of interest. But specifically for the gunshot, we can sense and detect the exact location and the coordinates of the gunshot, and we transfer it to the command and control center so that a location and information and alert notification may get displayed at the command and control application. A prominent feature of our solution is that it can work well when the source or shooter is hidden or behind any occlusion. It can detect the exact coordinates and the location of the shooter and can send the alert and the location information at the command and control center. Not only this, but our solution can work well in night. It can determine the location and the coordinates of the shooter with the same accuracy, even there is a pitch dark and there is no visibility. 360 degree of coverage and kilometer of range and 24/7 vigilance. These are the main prominent features of our solution. We had a stream of commercialization as well, and we have sold out 300 units to Punjab Safe Cities Authority and have deployed the gunshot detection in Lahore. The functionality testing of gunshot detection has been performed in real time with Punjab Safe City Authority and Punjab Police, where we have achieved 97% of accuracy, and we have also made it possible to send the alert in command and control center with less than 1 second. This solution is viable and can be deployed at various locations such as public areas, and even this is more effective for any border surveillance or for airport surveillance. Thank you.
Assalamu alaikum. My name is Ahmad Hussain Safdar and I am working as a research officer and team lead at NWN Lab at Al-Khwarizmi Institute of Computer Science, UET Lahore. And currently I am leading a team on a research project named as the Life Locator Radar. This radar is mainly working on a Doppler's principle. The target detection process consists of 3 steps. The first step is data capturing. The second step is data processing with a well-defined algorithm, and the third one is the classification, which tells that either the captured result is a concerned movement or not. The prototype of this radar was tested at the control environment, which was the collapse building rubble at Rescue 1122 vicinity, and the results were quite encouraging. The Rescue 1122 showed their support and the appreciation. The field testing of this prototype is ongoing, which will be concluded in a month or 2. The NCOC and the rescue department are potential customers for this project, but this prototype can be extended for a pre-raid operations in scanning buildings or for other military operations. Thank you very much.
Assalamu alaikum. My name is Bilal Tahir and I am a team lead at High Performance Computer Networking Lab, Al-Khwarizmi Institute of Computer Science, University of Engineering and Technology, Lahore. And I am going to present my project, Epidemic Surveillance System. The Epidemic Surveillance System collects the tweets to monitor the epidemic diseases. The system collects English and Urdu language tweets in real time and processes the data using artificial intelligence based models to monitor diseases. In particular, our system examines 5 types of diseases: COVID-19, malaria, HIV, AIDS, hepatitis, and dengue. As you can see, our system has already collected 111 billion tweets. It further classifies either tweet is providing information about the patient or it is discussing the general information about the disease. For instance, as you can see, 85% tweets related to COVID-19 discuss the general information about the disease, while only 15% tweets provide information about the patients. Furthermore, we identify location of tweets as well to map the intensity of disease into different regions. As you can see in our location map here. Our system also provides the option to examine the data in particular date range. The detailed analysis of each disease is also available in different tabs. Our system is publicly available at humkana.pk/ess. Thank you. Another project is News-Based Epidemic Surveillance System. News-Based Epidemic Surveillance System collects news articles in real time and aggregates the information related to different diseases. In particular, our system collects the information related to 5 diseases of COVID-19, hepatitis, malaria, dengue, and HIV/AIDS. As we can see, our system has already collected around 37,000 news articles. Moreover, we identify the location that are discussed in the news articles. We use this information to map the intensity of different diseases into different regions. As we can see, Lahore and Karachi are the most discussed locations in the news articles. Moreover, the Sankey chart shows the intensity of different diseases into 5 provinces of Pakistan. This information is also presented as a location map. Our system also provides the option to filter the data based on desired date range. Our system is publicly available at humkanar.pk/ness. Thank you. Another project developed by HPC in our lab is Humkanar. Humkanar is Urdu language search engine which crawls the Urdu content from all over the web. Specifically, it uses the tools that are developed for Urdu language content only. In addition, the homepage of Humkanar shows the latest content that is published on different websites to provide the updated information. Also, latest columns and blogs are shown on the homepage for the Urdu speaking community. In addition, Humkanar provides access to the content in a searchable format. User can provide queries using voice commands or keyboard. In addition, user can search into different tabs such as news, books, religious content, poetry, Wikipedia and navigational pages. In addition, we categorize all the crawled content into 5 categories of business, sports, health, science and entertainment. Currently, Humkanar has the index of 10 million high quality Urdu web pages and our system is publicly available at humkanar.pk. Thank you.
I'm Zubaira Naz, working as a research officer in Bioinformatics Research Lab. In our lab, we have developed neurofeedback-based AI robot which will provide speech therapy for autistic children to improve and enhance their social interaction. First of all, the robot will instruct the child to repeat a specific word. And during this time, the attention level of children is calculated using NeuroSky headset. When the child repeats that specific word, the robot will respond to the children in a very encouraging manners. After that, the spoken word is analyzed and calculated using deep learning models. Finally, the score for listening and attention is calculated and the child is being informed how accurately he spoke. In Bioinformatics Research Lab, we have established virtual reality training room to provide engaging experiences for different VR-based experiments. Our developed virtual reality labs include virtual chemistry labs, virtual electronics lab, virtual physics lab, neurogaming for ADHD patients, and VR-based phobia therapies which include claustrophobia, dark phobia. Various schools from Lahore have visited our VR zone and performed different virtual reality experiments. In future, we are targeting to bring this innovative technology in school and colleges that will improve the education standard of Pakistan.
My name is Ali Al-Layth. I am a research associate at Center for Language Engineering. I'm introducing Barakh, which is an online system for checking plagiarism in Urdu documents. So the system intends to facilitate academia, industries, and publishers as well in Pakistan and across the globe to improve the publications or the quality of research and publications in Urdu language. So the user can create an account in Barakh and log into their dashboards. They can also upload Urdu documents to check the plagiarism. The system generates reports which show the plagiarized content, similarity report also, and the source of plagiarized content.
My name is Sana Shaukat and I'm working as a Business Development Officer at Center for Language Engineering. I am leading the project Tehqiqat. Tehqiqat is an online research indexing platform funded by Higher Education Commission of Pakistan, which is dedicated to online visibility and promotion of HEC recognized research journals and articles from various academic disciplines and languages. Tehqiqat intends to provide an easy access to researchers and academics to search their relevant research from this platform. For example, if we search a keyword Allama Iqbal, we can see the result from various articles containing the keyword searched from across various academic disciplines and languages. Currently, there are many barriers faced by Pakistani research journals in terms of their accessibility. Tehqiqat accommodates this issue by providing easy-to-use platform. Publishers can also access a customized publisher dashboard account to manage the uploading of their journals at this platform directly. In future, Tehqiqat intends to index conference proceedings of various conferences across Pakistan.
I am Muzammil Hassan, working as a manager research in Software System Research Lab. Software System Research Lab is one of the most pioneer lab of Al-Khwarizmi Institute of Computer Science, UET Lahore. Our main purpose is to deliver high quality open source system technologies softwares. We have delivered so many projects in open source system and technologies to serve the university and for public and private sectors. Our main agenda is to deliver not only the quality assurance services including trainings, software development and mobile application development or web development. Recently we have launched a good platform for one of the universities, one of the best general management system which was launched back 5 years ago, named as Pakistan Journal of Engineering and Applied Sciences, UET Lahore. Pakistan Journal of Engineering and Applied Sciences, UET Lahore is actually a publishing system delivered back 5 years ago under the editorial board of UET Lahore. Basically this publishing system was recognized by HSE X category journal. This journal includes more than 2,000 users, including 1,300 authors, 700 reviewers and 40 section editors and 5 journal managers. So being a huge crowd on this journal system, university needs an automated system, so we have decided to study in thoroughly and decided to launch this system using open source journal management system named as OJS. OJS is basically the open source developed software for the solution of providing the publishing system and providing the reviewing process for the different general management system. So we have decided to launch in back 2015, and that was, I remember that it was the 2.0.4 version which was currently outdated, and the users really facing difficulties, so that we have to rethink about this to upgrade this system. And now this is upgraded to the latest version, that is 3.0.8. But during this journey, by transformation from oldest from the old version of the journal system towards the new journal of OJS, we have faced so many difficulties, because new journal management system requires latest hosting services, latest machines and latest platforms for hosting and deployment. So without any downtime, we have not only upgraded all these softwares, but also we have upgraded the open source towards this new version. Now it has been successfully launched and the users are using very satisfactorily, and we have launched this system recently, and we have no more facing any difficulties, and users are not facing any difficulties. By keeping this latest version on our system, many customers, many other institutes have also contacted us to adopt this journal system, and we are happily open for all those institutes which want to transform or digitalize their online journal system towards this publishing system. We have experience for in this service, in this area. We are available, and to contact me, you can view my contact number on the screen. My email address is also given on the screen, and about what the milestones we have achieved in our labs is also you can visit our website, and our screen is showing you the latest contact numbers. Thank you so much.
Assalamu alaikum, my name is Mahwish Nadeem. I'm working as an assistant manager research in Power System Lab at Al-Khwarizmi Institute of Computer Science. The project I'm going to present is Unmanned Remote Grid Control and Monitoring System. The system comprises of mainly two parts. The first one is the hardware device that work as a data acquisition and control system, whereas the second part is the remote grid control monitoring web portal. A web portal basically provides a comprehensive dashboard that helps to identify the different faults such as instantaneous trip, earth fault trip, overcurrent trip and DC unhealthy. These faults occur in the transmission lines that are connected with the grid stations, as well as it controls the load shedding remotely. There are two types of devices. The first type is deployed on 11 kV feeder panel, whereas the second type is deployed on the power transformer panels of 132 66 kV at the unmanned grid station. The hardware devices detect the different faults and send the information via GPRS GSM medium to the concerning control room. The interactive dashboard installed in the control room receive the information from the hardware devices and show the current status of the system. Additionally, the operators can operate remotely, switch on or off the circuit breakers from the incoming and outgoing feeder panels at grid station. The key features of the projects are the remote grid control functionality, the auto detect faults and alarms, the authorized access of devices, the interactive dashboard, event loggings, and the remote load shedding management. Thank you. Data communicator for grid control system. Earlier, KICS UET Lahore has developed a system for unmanned remote grid control and monitoring system designed for 220, 132, 66 kV grid stations. An improved variant of the remote grid control system with the data communicator and sensory circuit integration over the Wi-Fi equipment has been developed. The system comprises of the data communicator that collect the grid indications and fault monitoring data from the sensory circuits via Wi-Fi devices and communicate to the central data acquisition server through the GSM medium. The hardware device provides the more reliable data acquisition and grid operations, sufficient network connectivity, and the second part is the web portal that provides the comprehensive dashboard to identify the various faults that occur on the transmission lines at the grid stations. This project is an indigenous effort to provide the cost-effective solution and remote control of feeders of 11 kV and transformers and line base. The key features of the project are the improved grid performance, the authorized access of devices, interactive dashboard, the data collection via data communicator, the Wi-Fi based communication, and the load shedding management remotely. Thank you.
Assalamu alaikum. My name is Hamad Hassan. I am working as a manager research and development in Al-Khwarizmi Institute of Computer Science, UET Lahore. Our group is being led by Professor Dr. Muhammad Tahir, and we are actively working in development of real-time autonomous solutions for various kind of applications. Security and surveillance is one of the applications we are working with, and thus we have developed a complete solution named AUDIRE, Audio Vigilance Solution. Our solution is capable of performing real-time acoustic detection, localization, and can generate a response in no time for any incident that has occurred. In our solution, we can sense any acoustic sound. For example, we have a gunshot and we have a screaming, we have another sound of interest. But specifically for the gunshot, we can sense and detect the exact location and the coordinates of the gunshot, and we transfer it to the command and control center so that a location and information and alert notification may get displayed at the command and control application. A prominent feature of our solution is that it can work well when the source or shooter is hidden or behind any occlusion. It can detect the exact coordinates and the location of the shooter and can send the alert and the location information at the command and control center. Not only this, but our solution can work well in night. It can determine the location and the coordinates of the shooter with the same accuracy even there is a pitch dark and there is no visibility. 360 degree of coverage and kilometer of range and 24/7 vigilance. These are the main prominent features of our solution. We had a stream of commercialization as well, and we have sold out 300 units to Punjab Safe Cities Authority and have deployed the gunshot detection in Lahore. The functionality testing of gunshot detection has been performed in real time with Punjab Safe City Authority and Punjab Police, where we have achieved 97% of accuracy, and we have also made it possible to send the alert in command and control center with less than 1 second. This solution is viable and can be deployed at various locations such as public areas, and even this is more effective for any border surveillance or for airport surveillance. Thank you.
Assalamu alaikum. My name is Ahmad Hussain Safdar and I am working as a research officer and team lead at NWN Lab at Al-Khwarizmi Institute of Computer Science, UET Lahore. And currently I am leading a team on a research project named as the Life Locator Radar. This radar is mainly working on a Doppler's principle, The target detection process consists of 3 steps. The first step is data capturing, the second step is data processing with a well-defined algorithm, and the third one is the classification, which tells that either the captured result is a concerned movement or not. The prototype of this radar was tested at the control environment, which was the collapse building rubble at Rescue 1122 vicinity, and the results were quite encouraging. The Rescue 1122 showed their support and the appreciation. The field testing of this prototype is ongoing, which will be concluded in a month or two. The NCOC and the rescue department are potential customers for this project, but this prototype can be extended for a pre-raid operations in scanning buildings or for other military operations. Thank you very much.
Assalamu alaikum. My name is Bilal Tahir and I am a team lead at High Performance Computer Networking Lab, Al-Khwarizmi Institute of Computer Science, University of Engineering and Technology, Lahore. And I am going to present my project, Epidemic Surveillance System. The Epidemic Surveillance System collects the tweets to monitor the epidemic diseases. The system collects English and Urdu language tweets in real time and processes the data using artificial intelligence based models to monitor diseases. In particular, our system examines 5 types of diseases: COVID-19, malaria, HIV/AIDS, hepatitis and dengue. As you can see, our system has already collected 111 billion tweets. It further classifies either tweet is providing information about the patient or it is discussing the general information about the disease. For instance, as you can see, 85% tweets related to COVID-19 discuss the general information about the disease, while only 15% tweets provide information about the patients. Furthermore, we identify location of tweets as well to map the intensity of disease into different regions. As you can see in our location map here. Our system also provides the option to examine the data in particular date range. The detailed analysis of each disease is also available in different tabs. Our system is publicly available at humkana.pk/ess. Thank you. Another project is News-Based Epidemic Surveillance System. News-Based Epidemic Surveillance System collects news articles in real time and aggregates the information related to different diseases. In particular, our system collects the information related to 5 diseases of COVID-19, hepatitis, malaria, dengue and HIV/AIDS. As we can see, our system has already collected around 37,000 news articles. Moreover, we identify the location that are discussed in the news articles. We use this information to map the intensity of different diseases into different regions. As we can see, Lahore and Karachi are the most discussed locations in the news articles. Moreover, the Sankey chart shows the intensity of different diseases into 5 provinces of Pakistan. This information is also presented as a location map. Our system also provides the option to filter the data based on desired date range. Our system is publicly available at humkana.pk/ness. Thank you. Another project developed by HPC in our lab is Humkanar. Humkanar is Urdu language search engine which crawls the Urdu content from all over the web. Specifically, it uses the tools that are developed for Urdu language content only. In addition, the homepage of Humkanar shows the latest content that is published on different websites to provide the updated information. Also, latest columns and blogs are shown on the homepage for the Urdu speaking community. In addition, Humkanar provides access to the content in a searchable format. User can provide queries using voice commands or keyboard. In addition, user can search into different tabs such as news, books, religious content, poetry, Wikipedia and navigational pages. In addition, we categorize all the crawled content into 5 categories of business, sports, health, science and entertainment. Currently, Humkanar has the index of 10 million high quality Urdu web pages and our system is publicly available at humkanar.pk. Thank you.
I'm Zubaira Naz, working as a research officer in Bioinformatics Research Lab. In our lab, we have developed neurofeedback-based AI robot which will provide speech therapy for autistic children to improve and enhance their social interaction. First of all, the robot will instruct the child to repeat a specific word. And during this time, the attention level of children is calculated using NeuroSky headset. When the child repeats that specific word, The robot will respond the children in a very encouraging manners. After that, the spoken word is analyzed and calculated using deep learning models. Finally, the score for listening and attention is calculated and the child is being informed how accurately he spoke. In Bioinformatics Research Lab, we have established virtual reality training room to provide engaging experiences for different VR-based experiments. Our developed virtual reality labs include virtual chemistry labs, virtual electronics lab, virtual physics lab, neurogaming for ADHD patients, and VR-based phobia therapies, which include claustrophobia, dark phobia. Various schools from Lahore have visited our VR zone and performed different virtual reality experiments. In future, we are targeting to bring this innovative technology in school and colleges that will improve the education standard of Pakistan.
My name is Ali Al-Layth. I am a research associate at Center for Language Engineering. I'm introducing Barakh, which is an online system for checking plagiarism in Urdu documents. So the system intends to facilitate academia, industries, and publishers as well in Pakistan and across the globe to improve the publications or the quality of research and publications in Urdu language. So the user can create an account in Barakh and log into their dashboards. They can also upload Urdu documents to check the plagiarism. The system generates reports which show the plagiarized content, similarity report also, and the source of plagiarized content.
My name is Sana Shaukat and I'm working as a Business Development Officer at Center for Language Engineering. I am leading the project Tehqiqat. Tehqiqat is an online research indexing platform funded by Higher Education Commission of Pakistan, which is dedicated to online visibility and promotion of HEC recognized research journals and articles from various academic disciplines and languages. Tehqiqat intends to provide an easy access to researchers and academics to search their relevant research from this platform. For example, if we search a keyword Allama Iqbal, we can see the result from various articles containing the keyword searched from across various academic disciplines and languages. Currently, there are many barriers faced by Pakistani research journals in terms of their accessibility. Tehqiqat accommodates this issue by providing easy-to-use platform. Publishers can also access a customized publisher dashboard account to manage the uploading of their journals at this platform directly. In future, Tehqiqat intends to index conference proceedings of various conferences across Pakistan.
I am Muzammil Hassan, working as a manager research in Software System Research Lab. Software System Research Lab is one of the most pioneer lab of Al-Khwarizmi Institute of Computer Science, UET Lahore. Our main purpose is to deliver high quality open source system technologies softwares. We have delivered so many projects in open source system and technologies to serve the university and for public and private sectors. Our main agenda is to deliver not only the quality assurance services including trainings, software development and mobile application development or web development. Recently we have launched a good platform for one of the universities, one of the best journal management system which was launched back 5 years ago, named as Pakistan Journal of Engineering and Applied Sciences, UET Lahore. Pakistan Journal of Engineering and Applied Sciences, UET Lahore is actually a publishing system delivered back 5 years ago under the editorial board of UET Lahore. Basically, this publishing system was recognized by HEC X category journal. This journal includes more than 2,000 users, including 1,300 authors, 700 reviewers, and 40 section editors and 5 journal managers. So, being a huge crowd on this journal system, university needs an automated system. So, we have decided to study in thoroughly and decided to launch this system using open source journal management system named as OJS. OJS is basically the open source developed software for the solution of providing the publishing system and providing the reviewing process for the different journal management system. So we have decided to launch in back 2015 and that was, I remember that it was the 2.0.4 version, which was currently outdated, and the users really facing difficulties, so that we have to rethink about this to upgrade this system. And now this is upgraded to the latest version, that is 3.0.8. But during this journey, by transformation from oldest from the old version of the general system towards the new general of OJS, we have faced so many difficulties, because new general management system requires latest hosting services, latest machines, and latest platforms for hosting and deployment. So without any downtime, we have not only upgraded all these softwares, but also we have upgraded the open source towards this new version. Now it has been successfully launched, and the users are using very satisfactorily, and we have launched this system recently, and we have no more facing any difficulties, and users are not facing any difficulties by keeping this latest version on our system. Many customers, many other institutes have also contacted us to adopt this general system, and we are happily open for all those institutes which want to transform or digitalize their online general system. Experience for in this service, in this area. We are available, and to contact me, you can view my contact number on the screen. My email address is also given on the screen, and about what the milestones we have achieved in our labs is also, you can visit our website, and our screen is showing you the latest contact numbers. Thank you so much.
Assalamu alaikum, my name is Mahwish Nadeem. I'm working as an assistant manager research in Power System Lab at Al-Khwarizmi Institute of Computer Science. The project I'm going to present is Unmanned Remote Grid Control and Monitoring System. The system comprises of mainly two parts. The first one is the hardware device that work as a data acquisition and control system, whereas the second part is the remote grid control monitoring web portal. A web portal basically provides the comprehensive dashboard that helps to identify the different faults such as instantaneous trip, earth fault trip, overcurrent trip, and DC unhealthy. These faults occur in the transmission lines that are connected with the grid stations, as well as it controls the load shedding remotely. There are two types of devices. The first type is deployed on 11 kV feeder panel, whereas the second type is deployed on the power transformer panels of 132/66 kV at the unmanned grid station. The hardware devices detect the different faults and send the information via GPRS GSM medium to the concerning control room. The interactive dashboard installed in the control room receive the information from the hardware devices and show the current status of the system. Additionally, the operators can operate remotely, switch on or off the circuit breakers from the incoming and outgoing feeder panels at grid station. The key features of the projects are the remote grid control functionality, the auto detect faults and alarms, the authorized access of devices, the interactive dashboard, event loggings, and the remote load shedding management. Thank you. Data communicator for grid control system. Earlier, UET Lahore has developed a system for unmanned remote grid control and monitoring system designed for 220, 132/66 kV grid stations. An improved variant of the remote grid control system with the data communicator and sensory circuit integration over the Wi-Fi equipment has been developed. The system comprises of the data communicator that collect the grid indications and fault monitoring data from the sensory circuits via Wi-Fi devices and communicate to the central data acquisition server through the GSM medium. The hardware device provides the more reliable data acquisition and grid operations, efficient network connectivity, and the second part is the web portal that provides the comprehensive dashboard to identify the various faults that occur on the transmission lines at the grid stations. This project is an indigenous effort to provide the cost-effective solution and remote control of feeders of 11 kV and transformers and line base. The key features of the project are the improved grid performance, the authorized access of devices, interactive dashboard, the data collection via data communicator, the Wi-Fi based communication, and the load shedding management remotely. Thank you.
Assalamu alaikum. My name is Hamad Hassan. I am working as a manager research and development in Al-Khwarizmi Institute of Computer Science, UET Lahore. Our group is being led by Professor Dr. Muhammad Tahir, and we are actively working in development of real-time autonomous solutions for various kind of applications. Security and surveillance is one of the application we are working with, and thus we have developed a complete solution named ODIRE, Audio Vigilance Solution. Our solution is capable of performing real-time acoustic detection, localization, and can generate a response in no time for any incident that has occurred. In our solution, we can sense any acoustic sound. For example, we have a gunshot and we have a screaming, we have another sound of interest. But specifically for the gunshot, we can sense and detect the exact location and the coordinates of the gunshot, and we transfer it to the command and control center so that a location and information and alert notification may get displayed at the command and control application. A prominent feature of our solution is that it can work well when the source or shooter is hidden or behind any occlusion. It can detect the exact coordinates and the location of the shooter and can send the alert and the location information at the command and control center. Not only this, but our solution can work well in night. It can determine the location and the coordinates of the shooter with the same accuracy, even there is a pitch dark and there is no visibility. 360 degree of coverage and kilometer of range and 24/7 vigilance. These are the main prominent features of our solution. We had a stream of commercialization as well, and we have sold out 300 units to Punjab Safe Cities Authority and have deployed the gunshot detection in Lahore. The functionality testing of gunshot detection has been performed in real time with Punjab Safe City Authority and Punjab Police, where we have achieved 97% of accuracy, and we have also made it possible to send the alert in command and control center with less than 1 second. This solution is viable and can be deployed at various locations such as public areas, and even this is more effective for any border surveillance or for airport surveillance. Thank you.
Assalamu alaikum. My name is Ahmad Hussain Safdar and I am working as a research officer and team lead at NWN Lab at Al-Khwarizmi Institute of Computer Science, UET Lahore. And currently I am leading a team on a research project named as the Life Locator Radar. This radar is mainly working on a Doppler's principle. The target detection process consists of 3 steps. The first step is data capturing, the second step is data processing with a well-defined algorithm, and the third one is the classification, which tells that either the captured result is a concerned movement or not. The prototype of this radar was tested at the control environment, which was the collapse building rubble at Rescue 1122 vicinity, and the results were quite encouraging. The Rescue 1122 showed their support and the appreciation. The field testing of this prototype is ongoing, which will be concluded in a month or 2. The NCOC and the rescue department are potential customers for this project, but this prototype can be extended for a pre-raid operations in scanning buildings or for other military operations. Thank you very much.
Assalamu alaikum. My name is Bilal Tahir and I am a team lead at High Performance Computer Networking Lab, Al-Khwarizmi Institute of Computer Science, University of Engineering and Technology, Lahore. And I am going to present my project, Epidemic Surveillance System. The Epidemic Surveillance System collects the tweets to monitor the epidemic diseases. The system collects English and Urdu language tweets in real time and processes the data using artificial intelligence based models to monitor diseases. In particular, our system examines 5 types of diseases: COVID-19, malaria, HIV/AIDS, hepatitis and dengue. As you can see, our system has already collected 111 billion tweets. It further classifies either tweet is providing information about the patient or it is discussing the general information about the disease. For instance, as you can see, 85% tweets related to COVID-19 discuss the general information about the disease, while only 15% tweets provide information about the patients. Furthermore, we identify location of tweets as well to map the intensity of disease into different regions. As you can see in our location map here. Our system also provides the option to examine the data in particular date range. The detailed analysis of each disease is also available in different tabs. Our system is publicly available at humkana.pk/ess. Thank you. Our another project is news-based epidemic surveillance system. News-based epidemic real time and aggregate the information related to different diseases. In particular, our system collects the information related to 5 diseases of COVID-19, hepatitis, malaria, dengue, and HIV/AIDS. As we can see, our system has already collected around 37,000 news articles. Moreover, we identify the location that are discussed in the news articles. We use this information to map the intensity of different diseases into different regions. As we can see, Lahore and Karachi are the most discussed locations in the news articles. Moreover, the Sankey chart shows the intensity of different diseases into 5 provinces of Pakistan. This information is also presented as a location map. Our system also provides the option to filter the data based on desired date range. Our system is publicly available at humkana.pk/ness. Thank you. Another project developed by HPC in our lab is Humkanar. Humkanar is Urdu language search engine which crawls the Urdu content from all over the web. Specifically, it uses the tools that are developed for Urdu language content only. In addition, the home page of Humkanar shows the latest content that is published on different websites to provide the updated information. Also, latest columns and blogs are shown on the home page for the Urdu speaking community. In addition, Humkanar provides access to the content in a searchable format. User can provide queries using voice commands or keyboard. In addition, user can search into different tabs such as news, books, religious content, poetry, Wikipedia, and navigational pages. In addition, we categorize all the crawled content into 5 categories of business, sports, health, science, and entertainment. Currently, Humkanar has the index of 10 million high quality Urdu web pages, and our system is publicly available at humkanar.pk. Thank you.
I'm Zubaira Naz, working as a research officer in Bioinformatics Research Lab. In our lab, we have developed neurofeedback-based AI robot which will provide speech therapy for autistic children to improve and enhance their social interaction. First of all, the robot will instruct the child to repeat a specific word. And during this time, the attention level of children is calculated using NeuroSky headset. When the child repeats that specific word, the robot will respond the children in a very encouraging manners. After that, the spoken word is analyzed and calculated using deep learning models. Finally, the score for listening and attention is calculated and the child is being informed how accurately he spoke. In Bioinformatics Research Lab, we have established virtual reality training room to provide engaging experiences for different VR-based experiments. Our developed virtual reality labs include virtual chemistry labs, virtual electronics lab, virtual physics lab, neurogaming for ADHD patients, and VR-based phobia therapies which include claustrophobia, dark phobia. Various schools from Lahore have visited our VR zone and performed different virtual reality experiments. In future, we are targeting to bring this innovative technology in school and colleges that will improve the education standard of Pakistan.
My name is Ali Al-Layth. I am a research associate at Center for Language Engineering. I'm introducing Barakh, which is an online system for checking
from Dr. Mosam Khan. He is currently working as a software engineer at IBM in the area of threat intelligence. His team is building a next generation security platform for integration of security tools and data. He has been involved in development of QRadar based user behavior analytics application for detecting insider threats. Before joining the development role, Mozam was involved with the Watson for cybersecurity group as a researcher for another QRadar-based application called Watson Advisor. He holds a doctorate from Georgia Institute of Technology in Electrical and Computer Engineering. He's also an adjunct faculty at Kansas State University. Sir, you can start your talk.
So thanks, Dr.
You can now share your slides.
So unfortunately, I am not on how I think it's shared.
Dr. Mozam, can you unmute?
Can you hear me? Hello, can you hear me? And can you hear me? Dr. Amir, can you please confirm if you hear me?
Dr. Mozam, we cannot hear you. We can see your slides.
Can you hear me now? Hello?
We are waiting for Dr. Mozam to join and share his slides.
Do you guys hear me? Do you guys hear me?
Hamza, can you hear Dr. Mozam's voice?
Oh, I just got a confirmation that some people can hear me. But
yes,
if
we can hear you. Okay.
Oh, you can hear me. Okay, I never got a confirmation before. Okay, that's good then. I have the slides, and you can see my slides.
Yes, we can see your slide.
Awesome, awesome. Everything good then. Thanks, Dr. Amir, for the introduction. It's good to see you again. So today I'm going to talk about is machine learning a silver bullet for all security issues? I raised it as a question, and I'm not going to answer it, and I will leave the audience to make their own decision. I selected this topic because while working in this domain, I feel like machine learning is still a buzzword in cybersecurity. It has done wonders in other fields like image processing and video processing, natural language processing. But in security, at least in my personal opinion, is that there is still a lot of work needs to be done. Because when you apply these solutions, you have low performance, you have high false positives, and because of those, these solutions are not reliable. But let's see what are the security problems in the first place. What does the landscape look like, and what are the traditional ways we use to solve these problems? And then we can see how we can apply machine learning to those problems, and what are the strengths and weaknesses of those problems. So this is the agenda for our talk. As I said, I'm going to first discuss what does the security landscape look like. We are going to discuss how does the network look like now with the inclusion of work from home and adoption of cloud. The network looks way different than it used to before. So we will see that, and then we will look into the problems and some of the threats that are out there, and the weaknesses and shortcomings of the traditional solutions that are applied to machine learning. And then we will see what are the problems in those approaches. And in the end, we will conclude our discussion with some points. So, as I was saying, that the security landscape has changed quite a lot with the adoption of cloud and work from home. The network looked a lot different than the traditional network. What used to happen before, you had one network and all your apps would reside in that network. So if the users are accessing it, they have to go through your firewall and all the security controls that you had in your network. Now, your applications could reside in your network or on the cloud. It could be a private cloud or a public cloud like Google Cloud or AWS or Microsoft Cloud. So the landscape has become complex, and then the data that resides on your network has been siloed. For example, it might be located in the cloud, or it might be located in some department, like accounting might contain their own data, engineering might contain their own data. So all of these things have resulted in not only the complication in the security, but also in the machine learning solutions that we can produce. And thus, there are issues that result in the reliability and performance of those solutions. We will see all of them later. And to continue what I was explaining in the previous slide, you can see that this layer explains that there are so many networks. There are cloud, there are network 1 and network 2. Like this could be equal to your accounting or engineering network. That has bring in complexity. Then you have multiple security consoles because you are using multiple security vendors. For example, for your endpoint solutions, you might be using Carbon Black from VMware. For your firewall, you might be using Cisco solution. For your SIEM solution, you might be using Splunk. For security orchestration, you might be using Resilient. The point is there are so many security vendors and security tools that somebody who is doing the analysis get lost. And that obviously results in a very complex landscape for security. So understanding that, let's see what are some of the common threats. We see that malware is on the rise in the form of ransomware attacks. Then phishing, you get your credentials stolen through phishing emails. Then you have password attacks that can compromise your accounts. Denial of service attacks can bring down your availability of your site. Man-in-the-middle attacks could result in stealing your confidential information. Drive-by download results in downloading malicious software on your machine, malicious advertisement, and rogue software. Some of the threats that we saw last year, most of them we have already seen in previous slide, but there are web-based attacks like SQL injections, cross-site scripting attacks. Then we have data breaches that happens all the time. We have identity theft. Insider threat is one of the biggest ones. Then we have seen the rise of cryptojacking because of the increase in cryptocurrencies. The ransomware, of course. This is what the landscape in cybersecurity look like. Now, why and who are those people who are doing these malicious activities? Well, those people are called actors, and they have certain motivation. So let's see what are those actors. So nation states, of course, they have their political reasons or geographical reasons. For example, in the recent years, we have seen nation states like China and Russia manipulate US elections. For Pakistan, we have seen attacks from Indian side. So all these nation states are up against each other. Then we have cyber criminals. Their motivation is to gain profit. They might compromise your machine to basically use the CPU cycles to mine cryptocurrency or send spam. And then there are hacktivists, and they have some motivation because their ideology lines them towards that. Then we have terrorist group. They are also ideological, but they involve violence in their acts. Thrill seeker, they do it just because they can do it and they get thrill out of it. Insider threat are the users that are not happy with the organization and they want to either steal some information or do some damage because they are just not happy. So this now having understood what does the security look like in the modern day world, we can see how we can apply machine learning to solve security problems. This diagram breaks down the security problem into 3 dimensions. And it's a very logical way to break down not only the security problem, but also the machine learning problem. So first is, what is your goal that you're trying to solve? For example, you're trying to predict the attack, you are trying to prevent the attack, you're trying to detect the attack, or do any response once the attack has happened, or you're monitoring while the attacks are going on. So based on your objective or goal, you can define or classify all the machine learning security into these categories. Then there is this second domain, which is based on what you can monitor. So we call it technical dimension. So you can either monitor the entire network, like what kind of traffic is going on, what kind of attacks are going on in your network, or you can monitor the endpoints. Endpoints are the machines where the actual software is run. For example, your desktop, your laptop, your servers, your VMware machines, anything that can run an application on the endpoint is called endpoint. So basically, this is another dimension, or you can monitor your application for attacks on it. For example, your database application, and you can monitor for SQL injection. Your web application, you can look for cross-site scripting vulnerabilities. Then you have user, because user are also very key, and you need to monitor them because they might turn into insider threat, either knowingly or unknowingly. So you need to be monitoring their activities. And then the process. Process is a streamlined way of doing things. For example, there are certain ways a credit card transaction is authenticated. So that is followed by a process, and you can monitor all the processes. So, and the final last one is how you are monitoring or how you are evaluating the security. Either you are looking at it or monitoring it at the runtime, like on the wire, or you are looking at the data at the rest, or you're looking at the historical data. So this is another way you can classify it. The most interesting one to study is this middle one, or the second dimension. So we are going to look into this. We will look into each of these dimensions and see how we can apply machine learning to solve security problem for them. So let's look into the first one, which is the network protection. So traditionally, the machine learning, before machine learning, the network protection was done either through firewall or intrusion prevention or detection system, which would use rule-based or signature-based approaches. So you had a rule, for example, if the traffic is coming from an IP, just block it or mark it as malicious. These techniques are easy to circumvent. Bad guys could easily change their tactics so that will defeat the rules. So that's why machine learning approaches are more feasible in that scenario. And what can we do in this domain? We can either use regression to predict network traffic attacks, or we can use classification to classify network attacks into different categories. For example, we could classify them into spoofing, denial of service attack, or advanced persistent threat. So you will see this theme across each of these dimensions, here. For network, for endpoint, I will be talking in terms of regression and get a classification and clustering. So if you're not familiar with these terms, I will just briefly introduce. Regression is basically the machine learning technique that predicts things. For example, or an example would be predicting house prices based on the historical data. Classification is classifying things into categories. For example, cat and dog. And clustering is defining groups or peers based on the similarities. So each of the dimensions that we will discuss will be defined in terms of, or will have these machine learning solutions. And what I will do, I will pick one example and go deeper. For example, in this one, I use a classification technique to classify network attacks using SVM, support vector machine. The idea of support vector machine is very straightforward. You try to find a hyperplane between your data set that clearly distinguish your data set, and in doing so, classify them into two categories or more. For example, in this one, you have two data sets, and you can see that there is a clear boundary between these two classes. And our objective is to create a hyperplane that has the maximum margin. What does it mean? This diagram would, this next one, diagram would make it more clear. You can create any number of hyperplanes that separate your data from the other class. For example, these two classes here are separated by each of these hyperplane, and they are all doing fine. But the objective of SVM is to find one that creates this maximum margin. You can see that there is a maximum margin between the two classes. This circle and square are separated by this margin. So that's the main objective. And once we have this hyperplane, anything that resides on one side of the hyperplane belongs to one class, and the other side belongs to the other class. And the next dimension that we have is the endpoint detection. And endpoints, as I explained earlier, are the endpoints where the application is running. And the examples are containers, VMware, virtual machines, workstations, servers, parts, IoT devices. And again, similarly as before, we have regression to predict the next system calls that will be executed and compare it with the real ones. If the prediction differs from the real ones, that means there is something anomalous going on. And that way we can predict, okay, this is a malicious system call. Or we can classify programs into malicious or non-malicious categories, or we can cluster them and separate malicious attachments that are in an email. So an example, before we jump into an example, a traditional way of detecting malware are static analysis or dynamic analysis. So for example, you get a binary that you suspect is a malware. What you do, you disassemble it, you get the code, the assembly code, and you look into certain pattern in it. For example, a simple example of such pattern would be a URL or an IP address that this malware tries to connect. And then you see if this malware is a command and control center or anything that is associated with malicious entities. And that way you can tell, okay, this is a malicious software and it belongs to this family. The other technique is dynamic analysis, where you actually run the code. In the static analysis, you are simply looking at the code and trying to figure out, okay, if it is calling any malicious system call or anything suspicious. But in the dynamic analysis, you actually try to run that code, of course, in an isolated environment so that you don't impact your machines, and see what the malware or the suspected software is actually doing. These traditional techniques have some limitation. Of course, there is a large number of binaries that you typically have to analyze, and you cannot do it manually, or you cannot run static analysis on each and single one of them. And the attackers are also changing their tactics. So every time you have to use a new technique to detect it. And then there are anti-analysis tricks that will fail, for example, dynamic analysis. For example, these anti-analysis tricks can detect if you're running something in a sandbox environment or in a virtual machine. If they detect that, they don't display their malicious behavior. So that means that you will fail into detecting and classifying them. Whereas machine learning techniques can overcome all of these issues because they are looking at the patterns in the past data and deriving their conclusions from that. So one example of an algorithm that will detect malware for you is logistic regression. The idea is simple. You have this linear equation where your features are summed with their weights, and the result, we're calling it Z. The problem here is this could be an infinitely large number. And since you're trying to classify, we only need two numbers, for example, 0 and 1. So we can limit this equation into these two classification or categories by using a sigmoid function. So what we will do, we will use this function and apply it here, and this will result in this graph. You can see that it asymptotes here, meaning that it won't be anything larger than 1, and it won't go anything below 0. So what it will do, we can set up a threshold here. This means that anything that is higher than this would be considered as malware. Anything below this would be non-malware or non-malicious. So this is the simplest way you could use ML to detect your malicious or non-malicious software. And then we have this third category of the second dimension, which is the application security. There are so many different kinds of application. You could have web apps, you could have mobile apps, databases. And again, we use one of the three techniques to detect any threats to application security. We could use the regression to detect anomalies in the network protocols. For example, HTTP might have some malformated header, we can detect that, or we can classify attacks into either SQL injection, cross-site scripting, or we can in the email solution or email application, we can identify spam or ham. We could use clustering to detect attacks. So let's see an example of application attacks, and it's for spam detection, which is very common, and it has been very reliable and something where machine learning has excelled is the application of detecting spam versus ham. So the idea is, or in the traditional techniques, we would use regular expression to identify words that are most commonly found in spam email. For example, if it is related to illegal drugs, you will find certain keyword, and using those regular expression, you can identify those keywords, and if you find a certain number of them, you can say that, okay, this is a spam. Again, this trick or this technique could easily be avoided by the hackers. They could simply change their the word that you use, and you won't be able to detect it. And another reason you would want to use machine learning is just because the number of emails you have to monitor. So machine learning is good for scaling reason, and that's why it's a good solution. So there are a number of techniques. You could use linear classifier, Bayesian filter, decision trees, logistic regression. Let's see how we can apply linear classifier to detect spam to get an idea. So the idea is the same. You are trying to find weighted factor that you could use to predict your future emails reliably. What does it mean? It means you have a linear equation where you identify certain features. Certain features could be, let's say, a simple example that you're counting words, and a certain word has a weight. You also assign a weight, and you assign different weights to different words in your email, and based on your sum, you set a threshold that if this sum is above a certain threshold, where theta is the threshold here, you identify it as spam. Otherwise, if it is less than that threshold, then it will be a ham. So this is another way of classifying data. This is just the explanation of what I just explained. Now, the user behavior, this is the fourth point of the second dimension. And as we have seen before, earlier in the threat landscape, that inside the threat is one of the bigger or one of the biggest threat that organizations face, because they can steal information. The user, either intentionally or unintentionally, can do a lot of damage to their reputation. So it's very important that we detect it. Typically or traditionally, user behavior or insider threat were detected using the rule-based techniques, and we have seen that rule-based techniques are easy to be circumvented by bad guys. So we need a machine learning-based solution that learns from data. So again, we can use either regression to detect anomalies, classification to group them into different peers, or clustering to separate them and detect outliers. So examples of this are k-mean clustering algorithm, where basically you are finding cluster of similar peers or similar groups, and anything that is left would be the outlier, or in other words, it would be the anomaly. Another good example of detecting anomalies is isolation forest. which is basically a decision tree, which we will see in another example. But let's try to understand it here. We have this data set, and in order to make it simpler, I have divided into grids, which is nothing but creating boundaries between X and Y values. For example, here, anything that is on the right side would be greater than X. Anything less than 100 would be on the left-hand side. And similarly for Y values, anything that is below 50 would be here, this one, and anything higher than 50 would be these values. So now let's create a decision tree. The isolation forest will basically be the sum of all of these, the forest. But let's see how one tree is developed. So this is the data set that we have. The first decision that we take is if X is greater than 100, we go and check here. Okay, this point is greater than 100, so this will go on the right-hand side because this branch is checking if it is true. So since it is true, this goes here. If not, then all of these values are right here. So we will cover them here. Then we cover if Y is greater than 50, which means all of those values in this region. So if the answer is no, that means this value here, because this one is Y is less than 50. And if it is yes, then all of these values here. Then we check if X is greater than 50, which is this value. If the answer is yes, then this point gets here. If no, then these two values. And now we only have to check if the Y value is greater than 75 or less than 75. So we check that and we plot it here. The main point here is that it is called isolation forest because it isolates the outlier. This one is right here is the outlier, and you can see that it is by itself. And that's the whole idea of detecting anomaly. It is anomalous because it is different from this, and that's what the isolation forest does. Now, final point of the the second dimension is the process behavior. So processes are a good way to help us detect anomalies because anything that deviates from the process is basically an outlier and an anomaly. So we again use machine learning techniques to either do a regression to predict our next user action and detect outliers such as credit card fraud, or do classification to do detection of different type of fraud. Clustering to compare business processes and detect outlier. Again, that's the whole idea of the clustering. So let's look at an example of fraud detection. Credit card fraud is the most common fraud that is going on in the cybersecurity area. So let's look into that. Credit card fraud could be very complex because it could be coming from different geographies. The attackers might be residing in a different country, so they might have different rules and regulations and laws. So identifying and detecting them is a bit complicated. And then we have traditionally credit card are detected using two-factor authentication or rule-based techniques, or putting some limits on the credit card, or account blockage based on unusual activities. And if we apply machine learning, we can do some smart aspects to it. For example, here this is an example of a complete transaction. You swipe your card, you check certain parameters. If those checks are met, your transaction is fine. Otherwise, it is rejected. And then you can use a predictive model, like one of the regression model, to detect the fraud score. And if the fraud score is higher, you pass it to investigator, and they provide some feedback if it is really a false positive or a true positive. And based on that, you provide this feedback to the system. This feedback is very important because later on we will see that these machine learning models degrade over time because of certain reasons. And this feedback is important to keep them correct. An example of machine learning algorithm to do fraud detection is decision tree. We have seen one example in the isolation forest. The idea is the same. You are using to build a tree and making a decision at each node based on the data. For example, I have this example here, and this is an example of a user trying to log in. We first check if the user is coming over the VPN. If he is coming over the VPN, it's normal traffic. It basically is not fraud. If it is coming, if it is not using VPN, then we further check if the user is in the access control list. If not, then this is a normal user login. If yes, then it is normal. It's a very simple example, but the idea is to explain decision tree. And this is how it works. The problem with decision tree is that if there are a lot of features, then the algorithm tends to overfit, which will result in inaccuracies when you test it with the new data. Decision trees are also very sensitive, even if a small variation in the sample data happens, and that results in inaccuracies. So these were all the areas, or at least all the areas in one dimension of security where you can apply machine learning. Now let's look into some of the factors which are the cause of issues in machine learning solutions. So first one is data quality. Of course, machine learning is all about data, and if the data is not of high quality, you will not get a good result. As simple as that, garbage in, garbage out. For example, if you are training your spam filter from a particular domain which only have data from illegal drugs emails, then it will fail to detect any other spam which contains, for example, contents from weapon cell. Similarly, we have other issues with data sets. We have biases. These biases come from the person who is collecting the data or the time it is collected. For example, during the holiday season, if you are collecting traffic, it might show you different patterns, whereas during the summer season, when people are off, the traffic will give you different patterns. So biases is inherent, and that is the main cause of issues in the machine learning output. Then you have label inaccuracies, which is very important for supervised learning. If you're telling the machine wrong information, of course it will give you wrong result. It's a challenge because labeling is a very cumbersome process. Somebody has to sit and basically do the labeling. For example, in this example, which we saw earlier, an investigator has to look at each transaction to classify it as fraud or not. That's really cumbersome. That's why this is one of the biggest issues. Then missing data. Missing data happens because we are collecting data from different sensors. For example, network data coming from firewalls, IDSs, and they may not be collecting all the fields that are needed by machine learning algorithm. For example, some firewalls might be missing, let's say, URL, and the other might not have total bytes or the IP address. So this results in gaps in the columns, and some machine learning algorithms would simply ignore those rows or fill them in with some default values, which will introduce inaccurate results. Model quality is another important one because if the model is not accurate, then it will produce inaccurate results. The reasons for those inaccuracies are number one, hyperparameters, because these hyperparameters are things that you have to set as a machine learning engineer, and typically the machine learning tools come with some default values, and most of the people just select those and not try to optimize these other parameters. Of course, that's going to result in inaccuracies. And then we, as I was explaining earlier, that we need to have feedback loop in order to correct the degradation in the model performance, which happens over time. Repeatable results, because of these degradations, when your feedback correction, the system is changing or adapting continuously, and that may result in results not repeatable over time. That again introduces some inaccuracies, because you will have two different results, let's say over a different period of time. Explainability is a very important aspect, because so far machine learning has been considered as a black box. Whatever it tells you, you have to accept. If it is telling you that binary is a malicious one, how could you be so sure? That's why explainability is the aspect that if the machine learning tells me if it is malicious, it has to also explain to me why it is malicious, not act as a black box. Performance, again, very important, because machine learning is always sitting in a mission critical system, and any delay could be very, very critical. For example, in fraud detection or intrusion detection system, if your detection is late, then the damage has been done. High scalability is also important, because machine learning is presented with a lot of data, and sometimes the number of users on a system could be very high, so it should be able to scale in those scenarios. Maintainability, a system which is not maintained drains resources and produces inaccuracies. So there are techniques that you can use. For example, you could use the same checkpointing and versioning techniques that you use for a code. So for example, you could check out a previous version of the model and compare your results with the current version. If the model is degrading, it should degrade gracefully. We should define that if it is going to fail close or fail open. For example, an authentication system should always fail close, because if it is fail open, it will result in anybody getting into the system. Whereas fail close will ensure that even if the system fails, nobody is allowed to get in. It should also be easily tunable and configurable, which means that anybody who is not really expert or a software engineer could still manage and tune that model to get a more accurate result. Robustness, the bad guys are trying to bring your system down, so it should be very robust in such attempts. And data privacy is another very important one, because machine learning require data, and people are worried about their privacy, so they tend not to share their information. And if the machine learning solution is not providing a guarantee that their data is safe, they would not be providing that data. So that's why it's very important for a reliable and accurate machine learning solution. Monitoring and alerting, any system that is out in the open is bound to failure or slow down. But we need to be alerted when such things happen. So our machine learning solution should also have these features in there. So these were the main issues that we have in machine learning solution. Having discussed all of these issues and machine learning solutions and the security landscape, we can conclude a few things. we have seen that every year we are consistently seeing a lot of attacks. So that means that not only humans, but also the solution, including machine learning ones, are not doing a good job. And the machine learning is still very much a research field, and it needs some improvement because it can be reliable to prevent all kind of attacks. And machine learning has also shown some promise in certain areas like automating things and doing things that a new employee may not have a lot of skills. You could have that programmed, and machine learning can do that for you, and it scales well as well. And then finally, my observation or my conclusion is that since security is such a different problem, because there are two, it's like a cat and mouse game between bad guys and the good guys. So no matter how much improvement we make in terms of technology, bad guys would also have access to it and would know how to circumvent it. So I feel like that it would never be as good as we have seen in other disciplines like video processing and image processing or natural language processing. So that's my conclusion. I'm now open to question and answers.
Thank you, Dr. Mazan, for a very wonderful, informative talk. So I have a couple of questions. The first question is related to the first part of your talk when you mentioned that we might have some label inaccuracies or we might have some data biases. So the question is that once the model is running and people get affected due to biases. So for example, the famous example is that the black people in US jails, they have some, the models actually classify them differently when the jury has to decide that whether they should be given less sentence or the long sentence. So in those critical models, how important is the role of this data bias?
Yes, of course. I think you answered this question yourself. It's very, very important. And we hear these biases not only in security, but all different domains. Like you gave a very good example. Other example that you have been hearing is, hiring people. People are not relying on these solutions because sometimes they make really biased decision. For example, one of the recent case was where these models were only presented male data. So what these hiring solution was doing, they would simply not select any female. So that's really, that's not really good thing. So of course, these inaccuracies are really critical, and we need to get rid of these data biases. Now, how we can overcome this, I think that's the most interesting part. There are solutions. IBM has one that tries to get rid of biases, but honestly speaking, there are so many different areas that these biases come from that it would not be possible to have a zero bias system, because even if we get rid of human bias, we all have biases, and let's say we can get rid of it. There are other biases, like you may not have access to like all the sample set on the planet. So definitely you will collect your data from a certain area which you have access to that is causing you geographical bias. So other times you have only certain limited time frame in which you need to collect data that will result in time bias. So my point is that even though it is very critical, it's a very hard problem.
Right. So another question is regarding the second part of your talk is that this cybersecurity or the security in general is always a work in progress. So we cannot have like a perfect solution. So which areas do you think that the students who are in the university right now and who want to pursue research in this area, they should, which area they should focus?
Very good question. Very good. I have always thought about that. I don't think I can give you a perfect answer, but being in the industry, I observe few things, and what the companies are trying to do, and which space they are trying to work in. So one area that that I feel like is XDR, extended response solution, which is basically a solution to one of the problem I described earlier. Remember, I mentioned that there are so many vendors in the security space that that it's very difficult for analysts to follow what is going on. So the efforts are in a direction where they provide one window shop for all problems, meaning all your vendors will get integrated to this solution, and you will have a complete picture of your security. For example, I will give you more like detailed example. Like if something happens, you will get the alert in terms of where it is coming from, what were the signatures that triggered it, what parties are involved, where exactly in your organization that threat is, and then it will notify the higher management. They will escalate it to the right people. The right people would get engaged and have access to the machines that were infected. They could do their triage there, like do deeper analysis, and from there, whatever results they find, they can update. So everything is happening under one window. Before, there were like tens of different tools that they have to do. So that's one direction I'm seeing industry go. Others are definitely improving the reliability of these machine learning tools in the malware domain. I forgot to mention that there are certain areas where machine learning has been quite reliable, and spam detection and malware detection and classification is one such category. So one could focus in that area. And of course, the cloud security is totally new scenario. So container security, Kubernetes security, that I think would be on the top of the list that new students should focus on. These are the few that comes to my mind. I'm sure that I might be missing. It's already 4 or 5 a.m. here.
Right. So thank you, Dr. Muazzam, for your talk, and especially thank you because we in US it's quite early morning, I think.
Oh, no problem.
So yeah. So we have a virtual sheet for you.
Oh, awesome! Thanks. I really appreciate it.
Yeah. Thank you. Now our second speaker of this session is from Huawei. Is Mr. Patrick Lowe. He will be talking on inspired digital future with cloud and AI. He's currently based in Singapore, an industry and healthcare segment. He has 17 years of ICT experiences with strong background in data center, cloud computing, and artificial intelligence. Before joining Huawei, Patrick worked with major IT technology providers, including Microsoft, IBM, and HP. He successfully led several high-profile cloud data center and application transformation projects for various industries. Some are beyond Singapore. You can start your presentation.
Thank you for the invitation.
Now?
Yeah, you can hear me. Are you able to see my screen?
Yes, we can see your screen, please.
Sure. So thank you for having me. So my name is Patrick. I think that was a very brief introduction. Just to extend a little bit more. My specialty in cloud and AI space. And basically, I work, some key projects, and I'm basically I'm certified in a certain space.
Patrick, there is a
Yes.
pop-up on your screen. Can you please minimize that one? The WebEx meeting reminder.
No, is this the one?
Okay. Yeah. Thank you.
All right, sure, no problem. So I'll just go through very briefly, right? You don't need me to show all the slides, right?
Yeah, sure. You have half an hour.
Right. So generally the main thing that we are going to talk about today includes the technology that is very hot, and we tend to classify this strategy as ABC, which stands for AI, big data, and cloud. So this kind of transformation technology will basically be a mainstay, and it will basically be the important for us to be able to perform our digital transformation of organization and make them a lot more efficient. So what are the three key components here? One would be data, right? So data, as we described, is the new oil. So why data important is because basically data will allow us to be able to understand what is happening around us. And with this data itself, there is also an opportunity for us to monitorize, right? And the data that we have into services that are, basically unique and, insightful for our customer to be able to take with that. So when we deal with data itself, the data governance is also a important factor here, because data that we have, I think generally can reveal a lot about person. So the ability to ensure privacy, integrity, the availability of the data, all this very key aspect, right, of us managing it. And when we talk about the data itself, we have to be able to find them very quickly. So we have to have a data architecture in place on, managing the entire data life cycle. So what is, the main use of the data? So I would like to take you through this concept of, extracting value from data using, automated machine learning aspect of it. So we can just basically look at data on the left-hand side as input, right? If you are going to basically be able to do some prediction of the data, right, then there must be a model in place for you to put this all data into something that makes sense, right? And you whenever you do this prediction itself, some of them could be good, some may not be so good. So we may have to basically have a feedback loop, right, to know whether what kind of prediction is basically good for us, right? And this will go into a cycle where the entire model become more and more accurate. So technically, what you are doing is like this diagram, right? You started off with the red line. That is basically the state where you are not sure, right? The truth is in the green line, right? So when you go through your iterations of learning, right, you can see that the red line slowly forms, right, into the truth. So in this way, the machine will be able to basically predict cases, predict scenarios that is likely to be, the outcome, and that itself is the what we call the machine learning, right, through data to be able to understand what is happening in the real world, right? So from that perspective, the big data architecture that you are seeing here is a solution where we basically make use of data in the different stage or different form, right? The world would like to basically define this as unstructured, structured data, all right? And to support AI itself, basically, the data goes through this journey. So at the bottom right-hand corner with the red triangle, you will see the Hadoop, all right, where we are able to put all your data together in one space so they can be analyzed together. This is very good because you can put all kind of data together, all right, and it becomes convenient. But to really read from it, all right, it may take too long, right? So because if your database is big, to search for something, it will be a long process. So what we would like to do here, right, from this state itself, is to have a post process data. So we call this the structured data, and we have a solution in the market called MPP, multi-parallel processing, right? So act as this host for the structured data, all right? So this two data set itself, one for you to put all the data. The second one is to sieve and structure valuable data for searching in the future. So this whole thing will support the end state that we want, which is to have an intelligent machine that can make decision, right, on behalf, right, of humans. So they can take over some cognitive capability, meaning that they can think like a human being, act like a human being, and that itself is artificial intelligence. So these are the three stages of big data architecture that we vision is required to support what is the next topic here, the artificial intelligence of AI. So in this, AI, I think it's not something that is new in the market, or it's something that just happened recently. We have already a long history of trying to create a machine that can think like a human being, right, all the way back from 1950s. The challenges there, right, was that we do not have the right condition, meaning that our processing capability is not so powerful, and we are not able to keep up with a big amount of data and process them quick enough. So these initial challenges are slowly, being overcome with development in the technology space, where we have ability now to be able to process data quickly, so that machines can respond quick and responds very well, right? So we'd like to quote the example of the development stage of artificial using the concept of chess game. All right, we have tried to let computer play this game for us for a long time ago. I think the big original way of doing this, right, is not a very smart chess machine. I think at the time they are not basically very good at it, but along the way, right, you can see that the computer become better and better, and we are able to basically overcome the human in chessboard, right? When IBM came out with this machine called Deep Blue, right? So this is the machine that can beat the chess world player, right? For default. What we do here is basically make use of the concept of artificial intelligence using rules based. So we set rules, and then we teach computers to follow a certain rule. All right. That itself is one breakthrough, but along the way, that still is restricted to 8x8 chessboard set, right, which are very confined from a perspective of calculation. Right? So today, we have a breakthrough by development of our new concept called deep learning. So deep learning itself doesn't require rule-based kind of condition input. What we are doing now is basically let the machine learn by itself, because we kind of want to know that machine basically how they make decisions may not as structured as how humans learn. Right. So by using deep learning, we are able in 2016 develop a computer machine that can beat human being in the game of Go. Right. So this is a lot more complex. Itself create that condition for us to push artificial intelligence into something, very advanced, right? So I mentioned a couple of technology here, artificial intelligence, which is the overarching, machine learning, all right, and then deep learning. So the relationship between the three, right, I have drawn in this diagram here to show you, all right, that they are related in a way that, the deep learning, all right, today that we are working with is basically a big breakthrough, all right, and driving the AI. The other technologies are basically a uploading for where we are today. So from our concept of AI, right? So we have broken down AI solution into multiple layers. At the bottom is the infrastructure required, which comprises of compute, network, and storage component to support the AI workload. And then another important concept here is the software, the algorithm, the way we basically process data, right, to arrive at the object. So this basically algorithm has a different direction. So I named 5 key directions as the primary area of development: computer vision, speech processing, natural language, planning and decision system, as well as big data statistical analysis system. So this direction itself create helpful solution for us in the different form of technology, including things like image recognition, voice recognition, as well as going into the area of understanding sentiments, right? And basically we can synthesize and speak and make meaning out of a certain position that you are in. So today, this area that we are talking about area that AI has surpassed human, right? In terms of the capability, right? So the image recognition, speech recognition, semantic, these are the 3 areas that based on the development itself, machines are able to do better than humans. Right? So our solution that we have in the market should go down to taking advantage of all these things that machine can do. So the products that we kind of be able to productize in the area of artificial intelligence, right? Are listed here. So we have 2 directions. One is AI as a service. The second one is a development kit. From the diagram itself, if you look at the bottom, right, this is where all the data are basically stored and analyzed. The second layer are the AI services that we provide. Right? So AI as services on the left-hand side, right, where we are talking about using computer to do things like natural language processing, content, video content analysis, right, and behavior analytics, and so on and so forth. On the right-hand side, there's another area where we are using the capabilities to develop new AI capabilities. So we call that the training and inference toolkit, right, for us to be able to basically use to develop solutions for the different industries. So this become the base technology, first principles for us to develop solutions into different verticals like smart city, finance, right, gaming, advertisement, and so on and so forth. So what exactly are we, offering, right, from this perspective is that from the cloud itself, we will have different, modules for people to use to develop AI. So we call this model app. The model app itself, the software development kit is able to help us do a few development. All right, we make use of machine learning, all right, to do things like voice recognition. So one typical example here is that we have basically go to the forest, right, and then let the machine learn how to interpret things like the sound of the saw chain or the firearm, right, and use those voice to train a model. So once you have this model using techniques like deep learning, right, the model itself will transfer to a device that we can deploy in the forest. So in this case, we hang it onto a mobile phone, right? And we put the algorithm in there and then place it onto different part of the forest by hanging it on the tree. So whenever a sound like a sword chain or firearm occur, they will be able to, identify them and alert rangers to respond. Area that we talk about that is useful is object recognition. So you see two projects here. One is to use, the ability to identify objects that are basically recyclable, and then have a robotic arm to sort them. I think another good project that we have done will be recognition on the bottom right diagram here. All right, so this is a real project that we work with a supermarket chain, where they use machine image recognition to identify the fruits, right, and multiply the unit price of the fruit with the weight to basically automatically have consumer price the product they are. So this kind of solution, all right, basically uses object recognition with this part of artificial intelligence. Right? On the right hand side, you see two other projects under the category of behavior recognition. So on the same platform, right, we can actually train the machine to identify videos, right? So the top video here shows basically, the machine able to identify when object is being tossed around. So if you throw something, they basically will be picked up and basically will alert to monitoring center that objects are being thrown if cause damages to buffers, right? One at the bottom where I'm clicking right now, okay, is an algorithm that we train to identify people fighting versus people playing. So they will be able to identify when people can fight very accurately. And these are solutions that are deployable into the real world. So we have deployed this into different parts of our customers' environment to identify situations that need intervention. So these are some of the key process that we go through. So we talk about model arts as a development tool in the cloud, in the Huawei cloud, right? So that's provide. So the rainforests are kind of like a project, AI project for sound classification. What we do is we collect sound waves that could be from endangered animals, right? We can kind of like put those voices through a deep training in the model arts in the cloud, right? So we just provide those basically inputs, get the training done by computer, and the output will be a model, right? So this model is something that we can deploy, right? And basically we are able to achieve very high accuracy in the prediction, right, of this object that we want to identify. Okay. This is a clearest sample of this through recognition, right? Using object recognition technique, right? We let computers identify the type of food. So in this case, the supermarket chain was trying to identify what kind of apple. So we have apples from different part of the world that are priced at different unit price. Right, so we are basically able to have object recognition, identify the source of the products accurately, right, and price them accordingly. Right? So this is the bigger example of the behavior analytics, and you can see that somebody is throwing a parcel, and the model is able to predict quite accurately whether it is throwing or not. So in this case, you can see it's a 99% certainty that a throwing action are all projects that we have done. Right? You can even go down to things like facial recognition. So this is a gate, right? Access system where they will basically, instead of accessing through what we have, they are able to use our biometric like facial as a point of identification for admission into a restricted. So this solution itself, right? We have basically deployed into a lot of our campus, Huawei campus, and I know their trading is quite significant. The facial recognition program is also able to perform pretty, at a high level. So we are able to pass a person within 1.5 seconds. So there are many other projects that we have done, right, using this methodology of artificial intelligence deep learning, right, on the cloud, and then deploying the outcome this model to detect different situations, including illegal dumping, including intrusion detection for people moving into a restricted area, so on and so forth. So let's look at this model arts training and inference, how we can do that, right? So the technique is very easy, right? Basically, in the conventional way, right? The training is going to be quite tedious, but within the model arts, all right, the XML itself, all you need to do is to provide the object that you want to identify. For example, a flat water bottle. If you provide enough sample, so in this case just 10 photos, we will be able to develop a model, right, using the XML to basically generate the model. So when we deploy the model into cameras, right, you will be able to detect the object that become present, right? So we have done some of this testing very easily, 10 photos and so it makes AI training something accessible to the masses. This is exactly what we go through, right? We just need a set of photos, label them, right? And then in the system itself, there will be a place for you to start training. The training will take place to analyze the objects, right? And then once it's done, right, you will create a model. So this is done, right? You can see your model now being output here as a good accuracy. The next thing you need to do is just to deploy this model. So we have a real-time analysis platform on the platform for you to basically be able to do appearance on the same this is done using Huawei Cloud. So Huawei Cloud is equipped with a very good processor unit. So in this case, we are using what we call the Huawei AI chipset, which is a factory design chipset for AI, and are able to cut down training time and inference time significantly. So these are all basically proven to the Bench, which is a benchmarking organization, a particularly benchmarking organization. So just to expand a little bit more to how for us to understand this whole scenario here, how do we deploy it? For example, our this AI development kit, right? Model app, right? They are able to be used to do training, right? If you want to do training, right? The cloud services becomes a good place for you to do. So if you are running an organization like an education institution with your own infrastructure, right? With your own training system and all that, you can easily extend to the cloud to do AI capabilities development, right? So that's API based. So you just need internet connectivity and just make use of the resources, right? In the public domain to use your family. Same time, this model arts, once you create your algorithm, right, you can transfer them back into your on-premise, or any end devices, right, that will be able to do the matching, right, to basically build this AI capability. So we also have a web of open labs, which are our customer joint development center, right, to develop this together. Right? And once they are done, this basically outcome can be packaged and released, right, to the public consumption. So Huawei also, in our cloud, develop a marketplace. So this is called the AI marketplace, where anybody who has an AI model can post them to the cloud platform, right? And we will be able to monitor later by access, right? API access to this model. So what that means is that, if you put your AI model that you develop onto the AI marketplace, right, Huawei will be able to give you the statistics of how many API calls this make to it. And that information can be used by customers to do things like, charging, right, for using their model. So it becomes something like a tax that is basically, commercial. So this is basically Huawei Cloud and AI in essence. All right. So we use couple of key components here. Right. One is your big data AI platform. So this is in the cloud, right? So for us, we are basically able to use techniques for data processing, including Hadoop that I mentioned, and deep multi-processing. Right. So all these are provided to you, right, at the cloud. So you harvest the ability to do unified data in one place, analyze them together, right? Use that to basically place for you to do your AI. So with that, I think I cover the portion that I have. I think probably going forward, we'll be able to take on some questions if there's any from the audience.
Thank you, Patrick, for a very informative and nice talk. So we have a couple of questions. So you mentioned that Huawei is working very closely with other stakeholders to develop AI technologies and big data and cloud computing. So one of the questions is that lots of our participants are students. So how students can take advantage of the technology which is being developed by Huawei?
Sure. So we have put this AI development platform onto our Huawei public cloud. And as you know, public cloud is something that is openly accessible. So if you are a student, all you need to do is to go to Huawei Cloud, sign up an account. You will have access to this software development kit on the cloud, right? So what you can then do here is to very quickly build an AI project for any things that you want, like image recognition, behavior analysis, as well as voice recognition. So this become very easy and accessible methods for people to start the AI project. So that is what this capability is providing students very easy access and quick ability, quickly able to build an AI project. I think that the key benefits that we are providing from Huawei's perspective. Hope I answer your question.
Yep. The second thing is that since you are mostly working in industry, so what is your perspective from the industry point of view, that which problems students should focus on to from the research point of view?
Okay, so I think that question is pretty broad, and I think what is essence you are asking is that what is the hot area, or what is the area with a lot of potential. So as I basically have mentioned, there are certain things that machine AI, right, can outperform human beings, especially in the area of image recognition, in the area of language, thematic recognition, right? So I would say, if you are really interested to, venture into artificial intelligence, all right, these are the three key areas that you should focus on. Build a machine that is able to outperform human being in tasks like object recognition, language processing, as well as context, thematic and context recognition. So if you have a good product from that perspective, they will definitely be able to find demand, right, for this type of service in the industry. Hopefully that answers your question completely.
Yeah. So the last question is that you mentioned your product Hisense.
Right.
Right. So is this also some part is available for students?
Answer is yes. So this is a part of the platform. So once you have an account to the Huawei public cloud platform, we have this Hisense, which is an AI marketplace. And there are many developers and industry players that have developed model. They are posting there as a trained model for people to consume, right? So some of these are free. So we encourage people to go explore the Hisense AI marketplace and make use of what are the projects that has already been developed, right? And that will probably help you to do some of the tasks very quickly and very efficiently. Some of the example we have in Hisense are algorithm that can identify fire. Right? So if you have a video, you have a camera monitoring a space, right? Just by using the algorithm that we have in Hisense, you will be able to identify whenever a fire starts. Right? Second part here, it could be algorithm that can identify baby in distress. So if you have those kind of AI enabled device like a voice box in your home, right? You can install this type of algorithm to detect when a baby is in distress, they are crying, and so on and so forth. So all these are basically things that can help us, live our life more efficiently. So I think all this becomes very good use case for the product. Thank you for the question. Yes.
Good. So thank you, Patrick, for the talk. And now we have a virtual shield for you.
That looks great. Thank you so much.
Thank you. So next we have a panel discussion. The title of the panel is Future of Knowledge-Based Economy in Pakistan, Strategies and Challenges. This will be moderated by Dr. Ali Hamad. So we will start this panel discussion shortly.
I am Muzammil Hassan, working as a manager research in Software System Research Lab. Software System Research Lab is one of the most pioneer lab of Al-Khwarizmi Institute of Computer Science. I am Muzammil Hassan, working as a manager research in Software System Research Lab. Software System Research Lab is one of the most pioneer lab of Al-Khwarizmi Institute of Computer Science, UET Lahore. Our main purpose is to deliver high quality open source system technologies, softwares. We have delivered so many projects in open source system and technologies to serve the university and for public and private sectors. Our main agenda is to deliver not only the quality assurance services, including trainings, software development and mobile application development or web development. Recently we have launched a good platform for one of the universities, one of the best general management system which was launched back 5 years ago, named as Pakistan Journal of Engineering and Applied Sciences, UET Lahore. Pakistan Journal of Engineering and Applied Sciences, UET Lahore is actually a publishing system delivered back 5 years ago under the editorial board of UET Lahore. Basically, this publishing system was recognized by HEC X category journal. This journal includes more than 2,000 users, including 1,300 authors, 700 reviewers, and 40 section editors, and 5 journal managers. So being a huge crowd on this general system, university needs an automated system. So we have decided to study in thoroughly and decided to launch this system using open source general management system named as OJS. OJS is basically the open source developed software for the solution of providing the publishing system and providing the reviewing process for the different general management system. So we have decided to launch in back 2015, and that was, I remember that it was the 2.0.4 version, which was currently outdated, and the users really facing difficulties, so that we have to rethink about this to upgrade this system. And now this is upgraded to the latest version, that is 3.0.8. But during this journey, by transformation from oldest from the old version of the general system towards the new general OJS, we have faced so many difficulties, because new general management system requires latest hosting services, latest machines, and latest platforms for hosting and deployment. So without any downtime, we have not only upgraded all these softwares, but also we have upgraded the open source towards this new version. Now it has been successfully launched, and the users are using very satisfactorily, and we have launched this system recently, and we have no more facing any difficulties, and users are not facing any difficulties by keeping this latest version on our system. Many customers, many other institutes have also contacted us to adopt this general system, and we are happily open for all those institutes which want to transform or digitalize their online general system towards this publishing system. We have experience for in this service, in this area. We are available, and to contact me, you can view my contact number on the screen. My email address is also given on the screen, and about what the milestones we have achieved in our labs is also, you can visit our website, and our screen is showing you the latest contact numbers. Thank you so much.
Assalamu alaikum. My name is Mahwish Nadeem. I'm working as an assistant manager research in Power System Lab at Al-Khwarizmi Institute of Computer Science. The project I'm going to present is Unmanned Remote Grid Control and Monitoring System. The system comprises of mainly two parts. The first one is the hardware device that work as a data acquisition and control system, whereas the second part is the remote grid control monitoring web portal. A web portal basically provides a comprehensive dashboard that helps to identify the different faults such as instantaneous trip, earth fault trip, overcurrent trip, and DC unhealthy. These faults occur in the transmission lines that are connected with the grid stations, as well as it controls the load shedding remotely. There are two types of devices. The first type is deployed on 11 kV feeder panel, whereas the second type is deployed on the power transformer panels of 132 66 kV at the unmanned grid station. The hardware devices detect the different faults and send the information via GPRS GSM medium to the concerning control room. The interactive dashboard installed in the control room receive the information from the hardware devices and show the current status of the system. Additionally, the operators can operate remotely, switch on or off the circuit breakers from the incoming and outgoing feeder panels at grid station. The key features of the projects are the remote grid control functionality, the auto detect faults and alarms, the authorized access of devices, the interactive dashboard, event loggings, and the remote load shedding management. Thank you. Data communicator for grid control system. Earlier, UET Lahore has developed a system for unmanned remote grid control and monitoring system designed for 220, 132, 66 kV grid stations. An improved version of the remote grid control system with the data communicator and sensory circuit integration over the Wi-Fi equipment has been developed. The system comprises of the data communicator that collect the grid indications and fault monitoring data from the sensory circuits via Wi-Fi devices and communicate to the central data acquisition server through the GSM medium. The hardware device provides the more reliable data acquisition and grid operations, efficient network connectivity, and the second part is the web portal that provides the comprehensive dashboard to identify the various faults that occur on the transmission lines at the grid stations. This project is an indigenous effort to provide the cost-effective solution and remote control of feeders of 11 kV and transformers and line base The key features of the project are the improved grid performance, the authorized access of devices, interactive dashboard, the data collection via data communicator, the Wi-Fi based communication, and the load shedding management remotely. Thank you.
Assalamu alaikum. My name is Hamad Hassan. I am working as a manager research and development in Al-Khwarizmi Institute of Computer Science, UET Lahore. Our group is being led by Professor Dr. Muhammad Tahir, and we are actively working in development of real-time autonomous solutions for various kind of applications. Security and surveillance is one of the applications we are working with, and thus we have developed a complete solution named AUDIRE, Audio Vigilance Solution. Our solution is capable of performing real-time acoustic detection, localization, and can generate a response in no time for any incident that has occurred. In our solution, we can sense any acoustic sound. For example, we have a gunshot and we have a screaming, we have another sound of interest. But specifically for the gunshot, we can sense and detect the exact location and the coordinates of the gunshot, and we transfer it to the command and control center so that a location and information and alert notification may get displayed at the command and control application. A prominent feature of our solution is that it can work well when the source or shooter is hidden or behind any occlusion. It can detect the exact coordinates and the location of the shooter and can send the alert and the location information at the command and control center. Not only this, but our solution can work well in night. It can determine the location and the coordinates of the shooter with the same accuracy, even there is a pitch dark and there is no visibility. 360 degree of coverage and kilometer of range and 24/7 vigilance. These are the main prominent features of our solution. We had a stream of commercialization as well, and we have sold out 300 units to Punjab Safe Cities Authority and have deployed the gunshot detection in Lahore. The functionality testing of gunshot detection has been performed in real time with Punjab Safe City Authority and Punjab Police, where we have achieved 97% of accuracy, and we have also made it possible to send the alert in command and control center with less than 1 second. This solution is viable and can be deployed at various locations such as public areas, and even this is more effective for any border surveillance or for airport surveillance. Thank you.
Assalamu alaikum. My name is Ahmad Hussain Safdar, and I am working as a research officer and team lead at NWN Lab at Al-Khwarizmi Institute of Computer Science, UET Lahore. And currently I am leading a team on a research project named as the Life Locator Radar. This radar is mainly working on a Doppler's principle. The target detection process consists of 3 steps. The first step is data capturing. The second step is data processing with a well-defined algorithm, and the third one is the classification, which tells that either the captured result is a concerned movement or not. The prototype of this radar was tested at the control environment, which was the collapse building rubble at Rescue 1122 vicinity, and the results were quite encouraging. The Rescue 1122 showed their support and the appreciation. The field testing of this prototype is ongoing, which will be concluded in a month or 2. The NCOC and the rescue department are potential customers for this project, but this prototype can be extended for a pre-raid operations in scanning buildings or for other military operations. Thank you very much.
Assalamu alaikum. My name is Bilal Tahir, and I am a team lead at High Performance Computer Networking Lab, Al-Khwarizmi Institute of Computer Science, University of Engineering and Technology, Lahore. And I am going to present my project, Epidemic Surveillance System. The epidemic surveillance system collects the tweets to monitor the epidemic diseases. The system collects English and Urdu language tweets in real time and processes the data using artificial intelligence based models to monitor diseases. In particular, our system examines 5 types of diseases: COVID-19, malaria, HIV/AIDS, hepatitis, and dengue. As you can see, our system has already collected 111 billion tweets. It further classifies either tweet is providing information about the patient or it is discussing the general information about the disease. For instance, as you can see, 85% tweets related to COVID-19 discuss the general information about the disease, while only 15% tweets provide information about the patients. Furthermore, we identify location of tweets as well to map the intensity of disease into different regions. As you can see in our location map here. Our system also provides the option to examine the data in particular date range. The detailed analysis of each disease is also available in different tabs. Our system is publicly available at humkana.pk/ess. Thank you. Our another project is news-based epidemic surveillance system. News-based epidemic surveillance system collects news articles in real time and aggregate the information related to different diseases. In particular, our system collects the information related to 5 diseases of COVID-19, hepatitis, malaria, dengue, and HIV/AIDS. As we can see, our system has already collected around 37,000 news articles. Moreover, we identify the location that are discussed in the news articles. We use this information to map the intensity of different diseases into different regions. As we can see, Lahore and Karachi are the most discussed locations in the news articles. Moreover, the Sankey chart shows the intensity of different diseases into 5 provinces of Pakistan. This information is also presented as a location map. Our system also provides the option to filter the data based on desired date range. Our system is publicly available at humkana.pk/ness. Thank you. Another project developed by HPC in our lab is Humkanar. Humkanar is Urdu language search engine which crawls the Urdu content from all over the web. Specifically, it uses the tools that are developed for Urdu language content only. In addition, the home page of Humkanar shows the latest content that is published on different websites to provide the updated information. Also, latest columns and blogs are shown on the home page for the Urdu speaking community. In addition, Humkanar provides access to the content in a searchable format. User can provide queries using voice commands or keyboard. In addition, user can search into different tabs such as news, books, religious content, poetry, Wikipedia, and navigational pages. In addition, we categorize all the crawled content into 5 categories of business, sports, health, science, and entertainment. Currently, Humkanar has the index of 10 million high quality Urdu web pages, and our system is publicly available at humkanar.pk. Thank you.
I'm Zubaira Naz, working as a research officer in Bioinformatics Research Lab. In our lab, we have developed neurofeedback-based AI robot which will provide speech therapy for autistic children to improve and enhance their social interaction. First of all, the robot will instruct the child to repeat a specific word. And during this time, the attention level of children is calculated using NeuroSky headset. When the child repeats that specific word, the robot will respond the children in a very encouraging manners. After that, the spoken word is analyzed and calculated using deep learning models. Finally, the score for listening and attention is calculated and the child is being informed how accurately he spoke. In Bioinformatics Research Lab, we have established virtual reality training room to provide engaging experiences for different VR-based experiments. Our developed virtual reality labs include virtual chemistry labs, virtual electronics lab, virtual physics lab, neurogaming for ADHD patients, and VR-based phobia therapies which include claustrophobia, dark phobia. Various schools from Lahore have visited our VR zone and performed different virtual reality experiments. In future, we are targeting to bring this innovative technology in school and colleges that will improve the education standard of Pakistan.
My name is Ali Al-Layth. I am a research associate at Center for Language Engineering. I'm introducing Barakh, which is an online system for checking plagiarism in Urdu documents. So the system intends to facilitate academia, industries, and publishers as well in Pakistan and across the globe to improve the publications or the quality of research and publications in Urdu language. So the user can create an account in Barakh and log into their dashboards. They can also upload Urdu documents to check the plagiarism. The system generates reports which show the plagiarized content, similarity report also, and the source of plagiarized content.
My name is Ana Shokat
and I'm working as a Business Development Officer at Center for Language Engineering. I am leading the project Tehqiqat. Tehqiqat is an online research indexing platform funded by Higher Education Commission of Pakistan, which is dedicated to online visibility and promotion of HEC recognized research journals and articles from various academic disciplines and languages. Tehqiqat intends to provide an easy access to researchers and academics to search their relevant research from this platform. For example, if we search a keyword Allama Iqbal, we can see the result from various articles containing the keyword searched from across various academic disciplines and languages. Currently, there are many barriers faced by Pakistani research journal in terms of their accessibility. Tehqiqat accommodate this issue by providing easy to use platform. Publishers can also access a customized publisher dashboard account to manage the uploading of their journals at this platform directly. In future, Tehqiqat intends to index conference proceedings of various conferences across Pakistan.
I am Muzammil Hassan, working as a manager research in Software System Research Lab. Software System Research Lab is one of the most pioneer lab of Al-Khwarizmi Institute of Computer Science, UET Lahore. Our main purpose is to deliver high quality open source system technologies softwares. We have delivered so many projects in open source system and technologies to serve the university and for public and private sectors. Our main agenda is to deliver not only the quality assurance services including trainings, software development and mobile application development or web development. Recently we have launched a good platform for one of the universities, one of the best general management system which was launched back 5 years ago, named as Pakistan Journal of Engineering Applied Sciences, UET Lahore. Pakistan Journal of Engineering Applied Sciences, UET Lahore is actually a publishing system delivered back 5 years ago under the editorial board of UET Lahore. Basically, this publishing system was recognized by HEC X category journal. This journal includes more than 2,000 users, including 1,300 authors, 700 reviewers, and 40 section editors, and 5 journal managers. So, being a huge crowd on this journal system, university needs an automated system. So, we have decided to study in thoroughly and decided to launch this system using open source journal management system named as OJS. OJS is basically the open source developed software for the solution of providing the publishing system and providing the reviewing process for the different general management system. So we have decided to launch in back 2015, and that was, I remember that it was the 2.0.4 version, which was currently outdated, and the users really facing difficulties, so that we have to rethink about this to upgrade this system. And now this is upgraded to the latest version, that is 3.0.8. But during this journey, by transformation from oldest from the old version of the journal system towards the new journal of OJS, we have faced so many difficulties, because new journal management system requires latest hosting services, latest machines, and latest platforms for hosting and deployment. So without any downtime, we have not only upgraded all these softwares, but also we have upgraded the open source towards this new version. Now it has been successfully launched, and the users are using very satisfactorily, and we have launched this system recently, and we have no more facing any difficulties, and users are not facing any difficulties. By keeping this latest version on our system, many customers, many other institutes have also contacted us to adopt this journal system, and we are happily open for all those institutes which want to transform or digitalize their online journal system towards this publishing system. We have experience for in this service, in this area. We are available, and to contact me, you can view my contact number on the screen. My email address is also given on the screen, and about what the milestones we have achieved in our labs is also you can visit our website, and our screen is showing you the latest contact numbers. Thank you so much.
Assalamu alaikum. My name is Mahwish Nadeem. I'm working as an assistant manager research in Power System Lab at Al-Khwarizmi Institute of Computer Science. The project I'm going to present is Unmanned Remote Grid Control and Monitoring System. The system comprises of mainly two parts. The first one is the hardware device that work as a data acquisition and control system, whereas the second part is the remote grid control monitoring web portal. A web portal basically provides a comprehensive dashboard that helps to identify the different faults such as instantaneous trip, earth fault trip, overcurrent trip, and DC unhealthy. These faults occur in the transmission lines that are connected with the grid stations, as well as it controls the load shedding remotely. There are two types of devices. The first type is deployed on 11 kV feeder panel, whereas the second type is deployed on the power transformer panels of 132/66 kV at the unmanned grid station. The hardware devices detect the different faults and send the information via GPRS GSM medium to the concerning control room. The interactive dashboard installed in the control room receive the information from the hardware devices and show the current status of the system. Additionally, the operators can operate remotely, switch on or off the circuit breakers from the incoming and outgoing feeder panels at grid station. The key features of the projects are the remote grid control functionality, the auto detect faults and alarms, the authorized access of devices, the interactive dashboard, event loggings, and the remote load shedding management. Thank you. Data communicator for grid control system. IEEE UET Lahore has developed a system for unmanned remote grid control and monitoring system designed for 220, 132/66 kV grid stations. An improved version of the remote grid control system with the data communicator and sensory circuit integration over the Wi-Fi equipment has been developed. The system comprises of the data communicator that collect the grid indications and fault monitoring data from the sensory circuits via Wi-Fi devices and communicate to the central data acquisition server through the GSM medium. The hardware device provides the more reliable data acquisition and grid operations, sufficient network connectivity, and the second part is the web portal that provides the comprehensive dashboard to identify the various faults that occur on the transmission lines at the grid stations. This project is an indigenous effort to provide the cost-effective solution and remote control of feeders of 11 kV and transformers and line base. The key features of the project are the improved grid performance, the authorized access of devices, interactive dashboard, the data collection via data communicator, the Wi-Fi based communication, and the load shedding management remotely. Thank you.
Assalamu alaikum. My name is Hamad Hassan. I am working as a manager research and development in Al-Khwarizmi Institute of Computer Science UET Lahore. Our group is being led by Professor Dr. Muhammad Tahir, and we are actively working in development of real-time autonomous solutions for various kind of applications. Security and surveillance is one of the applications we are working with, and thus we have developed a complete solution named AUDIRE, Audio Vigilance Solution. Our solution is capable of performing real-time acoustic detection, localization, and can generate a response in no time for any incident that has occurred. In our solution, we can sense any acoustic sound. For example, we have a gunshot and we have a screaming, we have another sound of interest. But specifically for the gunshot, we can sense and detect the exact location and the coordinates of the gunshot, and we transfer it to the command and control center so that a location and information and alert notification may get displayed at the command and control application. A prominent feature of our solution is that it can work well when the source or shooter is hidden or behind any occlusion. It can detect the exact coordinates and the location of the shooter and can send the alert and the location information at the command and control center. Not only this, but our solution can work well in night. It can determine the location and the coordinates of the shooter with the same accuracy even there is a pitch dark and there is no visibility. 360-degree of coverage and kilometer of range and 24/7 vigilance. These are the main prominent features of our solution. We had a stream of commercialization as well, and we have sold out 300 units to Punjab Safe Cities Authority and have deployed the gunshot detection in Lahore. The functionality testing of gunshot detection has been performed in real time with Punjab Safe City Authority and Punjab Police, where we have achieved 97% of accuracy, and we have also made it possible to send the alert in command and control center with less than 1 second. This solution is viable and can be deployed at various locations such as public areas, and even this is more effective for any border surveillance or for airport surveillance. Thank you.
Assalamu alaikum. My name is Ahmad Hussain Safdar and I am working as a research officer and team lead at NWN Lab at Al-Khwarizmi Institute of Computer Science, UET Lahore, and currently I am leading a team on a research project named as the Life Locator Radar. This radar is mainly working on a Doppler's principle. The target detection process consists of 3 steps. The first step is data capturing, the second step is data processing with a well-defined algorithm, and the third one is the classification, which tells that either the captured result is a concerned movement or not. The prototype of this radar was tested at the control environment, which was the collapse building rubble at Rescue 1122 vicinity, and the results were quite encouraging. The Rescue 1122 showed their support and the appreciation. The field testing of this prototype is ongoing, which will be concluded in a month or 2. The NCOC and the rescue department are potential customers for this project, but this prototype can be extended for a pre-raid operations in scanning buildings or for other military operations. Thank you very much.
Assalamu alaikum. My name is Bilal Tahir and I am a team lead at High Performance Computer Networking Lab, Al-Khwarizmi Institute of Computer Science, University of Engineering and Technology, Lahore, and I am going to present my project Epidemic Surveillance System. The epidemic surveillance system collects the tweets to monitor the epidemic diseases. The system collects English and Urdu language tweets in real time and processes the data using artificial intelligence based models to monitor diseases. In particular, our system examines 5 types of diseases: COVID-19, malaria, HIV/AIDS, hepatitis, and dengue. As you can see, our system has already collected 111 billion tweets. It further classifies either tweet is providing information about the patient or it is discussing the general information about the disease. For instance, as you can see, 85% tweets related to COVID-19 discuss the general information about the disease, while only 15% tweets provide information about the patients. Furthermore, we identify location of tweets as well to map the intensity of disease into different regions. As you can see in our location map here. Our system also provides the option to examine the data in particular date range. The detailed analysis of each disease is also available in different tabs. Our system is publicly available at humkana.pk/ess. Thank you. Our another project is news-based epidemic surveillance system. News-based epidemic surveillance system collects news articles in real time and aggregate the information related to different diseases. In particular, our system collects the information related to 5 diseases of COVID-19, hepatitis, malaria, dengue, and HIV/AIDS. As we can see, our system has already collected around 37,000 news articles. Moreover, we identify the location that are discussed in the news articles. We use this information to map the intensity of different diseases into different regions. As we can see, Lahore and Karachi are the most discussed locations in the news articles. Moreover, the Sankey chart shows the intensity of different diseases into 5 provinces of Pakistan. This information is also presented as a location map. Our system also provides the option to filter the data based on desired date range. Our system is publicly available at humkana.pk/ness. Thank you. Another project developed by HPC in our lab is Humkanar. Humkanar is Urdu language search engine which crawls the Urdu content from all over the web. Specifically, it uses the tools that are developed for Urdu language content only. In addition, the home page of Humkanar shows the latest content that is published on different websites to provide the updated information. Also, latest columns and blogs are shown on the home page for the Urdu speaking community. In addition, Humkanar provides access to the content in a searchable format. User can provide queries using voice commands or keyboard. In addition, user can search into different tabs such as as news, books, religious content, poetry, Wikipedia, and navigational pages. In addition, we categorize all the crawled content into 5 categories of business, sports, health, science, and entertainment. Currently, HumConnect has the index of 10 million high quality Urdu web pages, and our system is publicly available at humconnect.pk. Thank you.
I'm Zubaira Naz, working as a research officer in Bioinformatics Research Lab. In our lab, we have developed neurofeedback-based AI robot which will provide speech therapy for autistic children to improve and enhance their social interaction. First of all, the robot will instruct the child to repeat a specific word. And during this time, the attention level of children is calculated using NeuroSky headset. When the child repeats that specific word, the robot will respond the children in a very encouraging manners. After that, the spoken word is analyzed and calculated using deep learning models. Finally, the score for listening and attention is calculated, and the child is being informed how accurately he spoke. In Bioinformatics Research Lab, we have established virtual reality training room to provide engaging experiences for different VR-based experiments. Our developed virtual reality labs include
Bismillahirrahmanirrahim. Allahumma salli ala Muhammadin wa ala ali Muhammadin wa barik wa sallam alayhi. Rabbi zidni ilma. Allahumma inni as'aluka ilman nafi'an wa rizqan tayyiban wa amalan mutaqabbala. Allahumma inni a'udhu bika min ilmin la yanfa'u. Sadaqallahu al-azim. First of all, I would like to welcome our distinguished guests from the industry and our very dear and very respected fraternity from UET and from other universities. We are here to conduct a panel discussion on one of the most eminent areas that's everyone's concern, which is the future of knowledge-based economy in Pakistan. What strategies to adopt in order to mitigate certain challenges and problems. My name is Dr. Ali. I'm from UET Lahore. This panel discussion is planned with a certain theme and spirit. In fact, without much ado, I would like to start. We have a format, and I would like to apprise the respected audience about the format. Next slide, please. First of all, I would like to start with a beautiful verse in Persian that says, Qalam goyat ki man shahe jahanam. That is, the pen says that I rule the world. It is knowledge and knowledge alone which determines the fate of nations. Having said that, we also know from Game of Thrones, Queen Cersei Lannister, when she says, power is power. So essentially, knowledge with power is what makes a winning combination. So knowledge-based economy is a very formal definition that is quoted quite often. So you can just look at some of the keywords. We have an economic system that believes in production of goods and services, and it utilizes extensively knowledge-based activities which are used in innovation. So the societies are based on innovation. The first 2 prayers which I made, the supplication which I made, had 2 keywords, that is ilm and nafa. So whatever knowledge we get, unless it is for the betterment of the human civilization at large, it's of no use. So keeping that in mind, I think the notion of knowledge in knowledge-based economy and the Islamic fundamentals, which are definitely quite different from the Western economic system, are essentially based on the same spirit. Next slide, please. These are some terms. I'm just going to enlist these terms and read them aloud for everyone's consumption. So we have the political economy. It is basically a confluence of the economic system and the implementation of law, governance, and the customs. And political economy is not in isolation. It is always seen in relationship to the international economy vis-a-vis the nation-state economy. So the knowledge-based economy is different from the traditional neoclassic form of economy in which we just had labor and capital. Now we also now have information, knowledge, and its dissemination. Read a paper, very interesting. It actually formulated a mathematical relationship between these variables to generate knowledge that is of good use. Then we have intellectual capital. It's a very interesting concept involving intellectual property right, the concept of patenting. Then information and communication technology that involves the operational technology. So unless and until a country is well equipped with operational technology, it cannot make effective use of the information technology. Can I just see something at the bottom as well? इसको escape करके दिखा दीजिए क्योंकि नीचे कुछ important concepts हैं. Escape करके अगर आप नीचे वाली कुछ टर्म्स दिखा दीजिए, वो मेरे पास इस वक्त हार्ड फॉर्म में है नहीं. Because once we are looking at a formal जी PDF या PowerPoint स्मॉल स्क्रीन कर देंगे तो उसमें नजर आ जाएगा. ये नीचे जो दी हुई है
स्क्रीन बोर्ड में मैसेज आप इस प्रेजेंटेशन बोर्ड से निकल जाओ.
यस, ये भी ठीक है.
Now you can reduce the zoom को थोड़ा सा
सेकंड स्लाइड जी. इसके अंदर ना इसका फॉन्ट साइज छोटा कर दीजिए एक्चुअली. यस, ओके. देन वी हैव then we had mobility, including immigration, and repatriation. Then we have global north, global south. These are well-known terminologies in economics. Then we have international bodies and the public policy framework, including foreign direct investment, the hot money, and certain international organizations which are key players such as FATF, IMF, the World Bank. Then we have the isms, which are very important because these days there's a rise of far-right democracies like regionalism, protectionism, etc., etc. Then we talk about production, trade, and the role of governance ensured through triple helix. Next slide, please. Now, let's look at some facts and numbers. We always have long desired to be amongst the Asian tigers. For instance, we've seen Singapore, Hong Kong, Taiwan, even Vietnam, South Korea, now China, the Chinese dragon. And we also have the Wirtschaftswunder, that is the German miracle of the Rhine. So what is Pakistan doing exactly? So we have some statistics. I got these latest just before coming into the presentation. We have some statistics in agriculture. You can just have a look amongst the top 10 countries of the world. Fourth in milk production, our GDP per capita, GDP as such. Software exports. In fact, I'm grateful to Hamad Saab for Ahmed Saab to have corrected me. The total exports which were quoted by the State Bank of Pakistan around 2.3 billion in 2020, expected to be going up by another $500 million. Then we have a trade, still we have a trade deficit. This is the trade deficit that we have. In terms of our competency and readiness to embrace the knowledge-based economy, we have the Global ICT Index, Global Governance Index, aka Prosperity Index, Global Innovation Index, and Global ICT Enablement Index. So we are quite low in those. That's a worrisome situation, but what can we do about it? That is exactly the mandate of today's panel discussion. Next slide, please. Now, these are some challenges which slide show kar dijiye ji. Ugly slide. These are some challenges and constraints which were identified and enlisted by some papers which I skimmed through. Just have a look. I'm just going to flash it. There's no point in reading through all these. In no particular order. Next slide, please. All right. So what can we benchmark ourselves? Where do we stand now? So this is a current standing from Pakistan being a nation state. We are not part of any economic alliance as such, which is quite vibrant. So we are part of the Shanghai Cooperation Organization, SCO, and we are part of ASEAN. We are part of the SAARC countries, but we have a functional government. We have a Ministry of Commerce and Trade. We have the Economic Cooperation Committee. We have Export Promotion, Export Board. Then we have universities which are churning out intellectual capital actually for the whole world, less Pakistan. Then we have a vibrant telecommunication infrastructure. We have investments from all over. We have HECs and PECs. Then we have the capitalists, which are either investors or they are just managing money. Then we have a vibrant banking sector, and we have a lot of touch labor. How can we capitalize that in knowledge-based economy? We need to look at that. Next slide, please. Now, this is actually a framework which I wanted the respected panelists to adhere to. You are at liberty to answer these questions in no particular order at will. So we'll take notes or whatever you suggest, whatever you comment. So these questions and issues are, what is your perspective? How do you look at knowledge-based economy, being from academia or from industry, being from the government? And how do you think the world looks at us as being one of the countries in a knowledge-based global economy and as a global citizen? And then what are the perspectives on our current standing? Where do we stand? Are we that bad, or we are good? We are just ready to be catapulted? What is your opinion? And then how can Pakistan transform into a knowledge society through the incorporation of ICT? Can we do it? And then what are the national policies and regulations and regulatory authorities which actually, instead of facilitating, are impeding the realization of a true knowledge-based economy? If you have some comments, we look forward to hearing from you. And then challenges for Pakistani business sector, not the international conglomerates, but for small and medium enterprises, which are highly local and represent indigenous efforts. So what are the challenges from the government perspective, from societal perspective, from SMEs themselves? I think एक point रहता है SMEs के नीचे वाला, एक point रहता है, वो अगर खाली दिखा दीजिए. बस यही था. Yes, then academia, that we coming from the university certainly would like to have our opinion in the panel registered from the university side. Now these are the questions. If आप full screen पे चले जाइए. Now with your kind permission, we toggle between one comment on either of these, from the industry first, then from the academia, then we'll go off and on. We'll switch between the two. So I'll request first of all the panelists to introduce themselves and then your comments, please. Sir, Bismillah करते हैं आपसे.
It specializes in encryption and communication and data, secure communication and data technology. And I'm thankful to Allah for giving us abilities and putting us these innovative ideas in our mind. That if you have heard about AES, have you heard about Advanced Encryption Standard from US? So we have come up with 2 equivalent encryption algorithms which have been, alhamdulillah, approved by NTISB. Do you understand what NTISB is? It's a bureau which tests your security equipment, and if you have any indigenous equipment, they also rigorously test it, and they rigorously tested our algorithms, and alhamdulillah, they approved it. They were not copied from anywhere, and our customers are using those. And this is actually, we have three. The first one was called FKG. Second one is called Stealth, and third one is Jibrail. So it's a small company, but we have done, alhamdulillah, some contribution to defense of this great nation. Thank you.
Please.
Yeah. Hi, I am Muhammad Adil Irfan. I am currently CTO Arhamsoft. Basically, our company is service-based, and we have around 180 to 200 resources in-house. And we are working on multiple technologies like .NET, C#, and PHP, blockchain also. So yeah, that's from us. Thank you.
Assalamu alaikum everyone. My name is Muhammad Irfan Zafar. I am CEO of Arhamsoft, CEO of Data on Matrix, and formerly have about 12 years experience of academia in UMT and UCP as an assistant professor. So, and currently we are working on different technologies as Mr. Adil has explained, and the most popular and mostly used at the moment is the blockchain, which we are working aggressively on, and almost all of the latest technologies we are working. Thank you.
Assalamu alaikum ji, this is Ahmed Muzammil. I'm in the technology sector for the last 15 years, since 2006, been working in the software and technology industry. Have served in Pakistan, have done projects in UK, Europe, US as well. Right now, like over the last 5 years, I've been associated with multiple companies, multiple startups, I should say. So one of the companies I'm part of works in medical tech, which does medical devices. We are building dialysis machines in Pakistan. That will be the first dialysis machine done outside the first world if it comes to the commercial market, hopefully next year. And then we do most of the time I spend with Caper, which is a marketplace for engineers. We build remote teams for companies in US. And then we also do trainings in Pakistan, which is very close to my own heart. We do it as a CSR. We run boot camps across Pakistan on technology trainings. So again, technology trainings, youth, and knowledge-based economy are pretty close to my heart. Thank you.
I'm so grateful. Jazakallah. I'll request Dr. Mohammad Tahir sir. Assalamu alaikum, Doctor. Please introduce yourself as the first person from the academia. Then we'll move on to this particular portion.
Bismillah ar-Rahman ar-Rahim. My name is Muhammad Tahir. I am currently serving in Department of Electrical Engineering, and I'm with the university for the last 20 years or so. And in parallel, I have worked on certain projects. Did my PhD. During that, I also worked in Motorola research labs for around 1.5 years, 2 years on research projects of Motorola. So I have quite a bit of background from industrial perspective as well, but primarily attached to academia.
Sir, please.
Bismillahirrahmanirrahim. I'm Dr. Waqar Mahmood. I'm looking after Al-Qarzmi Institute of Computer Sciences. This is now considered as one of the largest and high-ranking ICT research institute in the country. We have about 240 plus researchers focused on a number of ICT areas in different labs. We have almost 250 million rupees of research budget that we generate from different projects in research grants that we receive through competitive biddings, locally and nationally, internationally as well. Thanks.
So my name is Dr. Amir Mahmood. I am the head of the High Performance Computing and Networking Lab here. So in the past, I have worked with the telecommunication industry in Pakistan Telecom and in Deutsche Telekom in Germany. So I have 10-year experience of industry and 15-year experience of academia. So I know the both world and I have both perspective from both sides.
It's Dr. Ali Prasadullah. I'm a director of cybersecurity lab and IoT lab. So I'm working on different IoT projects and cybersecurity projects. We are indigenously developing some cybersecurity projects in our lab. And before starting my academic background, I have been working in software houses for a couple of years, and then I moved on to the academics part. Thank you.
Thank you very much. Sir, we'll like to start formally. Sir, आपसे शुरू करें. Kindly, any particular question or issue that you would like to comment on?
Yeah, basically, there are a lot of things to say about knowledge.
Sorry, मैं ना एक साइड से शुरू करना चाह रहा हूँ.
Thank you. There are a lot of things to say about the knowledge economy and where Pakistan stands and what we can do. So it is, I think that's a long debate, but I will start that the knowledge economy is the one and only option of survival for Pakistan, in my point of view. Because if we analyze very shortly that Saudi Arab has about $115 billion exports yearly in terms of oil, while Indian only IT exports are 150 billion. If we compare with the population of 1.4 trillion and as compared to Pakistan, so we should be at $25 billion per year, while we are still standing on $2.3 billion. So there is a huge gap. And this gap is due to education, because if we want to achieve something in knowledge economy, we need to invest on education. So there are a lot of opportunities. If we will not enhance our education system, we will not open more universities, more colleges, then the progress on the knowledge economy would be very difficult. A simple example is that Denmark, which population is 58 lakh at the moment, which is lesser than Lahore, and it has the largest knowledge-driven economy. And their literacy rate is about 100%, 98%. So if we want to do something in knowledge economy, we need heavy investments on education sector and innovation and ICT. Then we would be able to do something. I would really appreciate Mr. Farhan, who has collaborated with us last year. And we have also signed an MOU to exchange our expertise to collaborate with them so we can accommodate UET graduates with us. But unfortunately, I have passed on 2 opportunities in which we were requiring expertise of UET lab, but we were not able to collaborate due to unavailability of resources or due to unavailability of proper infrastructure to collaborate with software houses. But we will still keep trying it. Another recent example I would like to quote is we advertised the training program of Leading to Job, and 500 plus participants has applied, and only 8 graduates from UET had applied on that program. And finally, we have selected 2 out of a batch of 44. So I'm not sure what are the reason, but I should mention over here, because last year I have attended the same conference and we have discussed these things. And if we want to proceed and we want to do something, so relation and coordination between academia and industry is vital. A lot of organizations are working at the moment in which PSEB has recently started internship program, which is
actually now we have paucity of time.
Yeah.
So I would request you to please identify a certain question that you would like to give, or an issue that you would like to give an answer to. Your comments are very valuable to us, but we would specifically request you to comment and identify a certain question or issue under which your comment should be registered. क्योंकि हमने ना सबको थोड़ा थोड़ा टाइम देना है, और मेरी ख्वाहिश है कि हम ना स्पेसिफिक फोकस्ड रहें to these questions.
Yes, of course, and I'm also very specific to these questions, and I'm almost covering all these questions, summarizing all that. But sorry to say that, but academics, that is one question, and I have mentioned that academics need to collaborate with the industry to generate the skilled resources. If I go to the slide, so then next is industry. Next is, yeah. जी बिल्कुल. Because I would again like to mention that I am associated with academia for 12 years with the industry. So I am related to both of the segments significantly. And I feel the pain of the students which they are having and what academia should do and what industry should do. So my comments are all related to this, that knowledge, which is the topic of the day, that if knowledge economy we need to do something practical, very practical. Government has every department has to do something. Government definitely has to do. PSEB has started internship program. They are doing, Pasha doing very well. Our own industry is doing to generate some skilled resources. That is ultimate objective and only solution for success of Pakistan in the knowledge economy. So until we will not focus on, until the academia and industry will not collaborate, we are not going to achieve this outcome. So this is, and I really appreciate all the efforts which UET doing and every year conducting these seminars and that. So these are my some of the comments. Thank you.
I'm grateful. Thank you very much. So, sir, before we move, we'll come to you. We'll request someone from academia to come. Assalamu alaikum. We have guests here. So before we move on, we'll request them to introduce themselves so that we welcome them.
Assalamu alaikum. Thank you very much. This is Suhail Qadri. I'm Director of Policy with Punjab Board of Investment and Trade.
Thank you very much. I'm Afaz Hassan from Punjab Board of Investment Trade, and we are grateful to Ransa for inviting us. Suhail Qadri sir will formally share his comments once the proceedings proceed.
Thank you very much. In fact, of the three strands, in fact, two strands were present. In triple helix, we had the industry, we've got the academia, but the government component was missing. So alhamdulillah, better late than never. Thank you very much. Sir.
Great, thank you very much. I would like to quickly comment on a few things that you have covered, I think, very in a very precise manner, exactly where the knowledge economy can come from. You mentioned that there are several indexes where Pakistan is lagging, even though we have very good ICT infrastructure. You mentioned those two things. The ICT infrastructure is good. We have 90% plus coverage of services in GSM. I think penetration is also quite high. More than 100 million individuals are using broadband. But the issue is that the individuals that they are using these ICTs, they are not really knowledge seekers, or they are not having the right knowledge, or they are not using those services for generating any specific information or commercial activity that really improves the economy. So the reason is that we do not have good numbers as far as the education is concerned. So we are quite behind. We have about half of our school-going children which are out of school, and then the ratio remained very little, especially when it comes to university and higher-level education. We have only 2% of university-going age individuals who really get admission into university. So the requirement is to really increase the education starting from the primary level to these the higher levels. Then you talked about the trade deficit that Pakistan has. The industry has just mentioned it. Just comparing with India, Pakistan is quite behind. Even in the ratios of population, we are about maybe 1/7 of India. So we should be having at least 25 billion of software exports, which India has 150 billion. It's very rightly put forward. But the problem here is that we in Pakistan have not really created a real value in our universities, where we have not generated individuals who can become right away useful in industry. What I have heard from industry many times is that the individuals which are coming out of industry require at least 6 months to 9 months level of training before they can be put to use. So this is where academia is lagging, where we are not giving them the industry-based skill. So this is one part which is missing. I'm fortunate to work with the knowledge economy, which task force has been put forward by Prime Minister of Pakistan. Dr. Rahman is the chair, vice chair of the knowledge economy task force, and Prime Minister himself is the chair. So I work with while working in that task force, we have put together in the last 2 years a number of projects to address this issue of creating knowledge users and knowledge generators can definitely contribute towards economic growth of the country.
So some of those initiatives include, and I'll just mention, I think very quickly, very few. One challenge that they are contemplating is that Pakistan is 3 billion, as you mentioned, 2.3 billion last year, and this year it's expected the 3 billion of software exports are expected in Pakistan. So what we can do, and industry will definitely I think, address it better, to increase it to 30 billion in the next 5 to 7 years. In the normal figures that they say is that about 100,000 individuals are right now employed in software industry. And every year we have about 20,000 to 25,000 getting out. But the issue is that those 25,000 are not employable. They say that 4,000 are directly employable. The rest, they need to have some training. So if we need to increase our exports, we need to improve these 100,000 individuals to that many number in order to increase the number from 3B to 30B, which is like 10 times. So the idea is to increase these number of trained resources at the level of education that is at the university level available, but also increase those individuals which are in fact not able to get admission in university. So one project that we are working on is to have opportunity to give admission to students in a associate degree program, which is about 2 years of duration, and individuals which are FSC, they have done FSC or they have done a diploma or they have done ICS, they can get admission for a 2-year associate degree maybe in a college, community college. And in industry should come back and teach for 1 year, and 1 year is their basic fundamental study that they can get from the faculty of that college or which is associated with the university. So this is how you can expand at least the number of ICT experts or producers which can really work with industry right away. This is where we can expand rather quickly the number of graduates which are coming out in the ICT industry, and ICT industry is looking for. And then the higher end is of course required. Pakistan has not been able to have an ICT industry which has large number of employees, or it has grown to a point where it can compete with any of the Indian industry. For example, Infosys is 50,000 plus employees. Pakistan, we do not have ICT companies which have more than 2,000 employees, for example. So this is where we need to also train individuals to work in a team and get together. Generally, ICT industry, once they start to grow, they start to then split into different groups, and then they remain small, agile, but the large size industry is not there in Pakistan, which can really take up very high return projects from abroad. At this time, there's a lot of focus on e-services, e-rozgar service kind of services, the freelancing. Where the students are, of course, they are earning, but they are earning at a very low level, $5, $10, $20, $50 an hour. But the larger level projects where we have strong background of individuals who can really do the architecture kind of work. They can really handle software systems and solutions that can run the Fortune 500 type companies. So this is where Pakistan does not have the expertise. And that needs to be developed with the help of industry and academia. And this is where we are at this time.
So thank you very much.
Much lagging.
Sir, I'm so grateful. In fact, आपने जो बात की थी, Dr. Waqar, you being from academia once upon in time, so your ideas and Dr. Waqar's ideas actually corroborate each other. So, sir, before coming to you, in fact, we have guests. तो मैं इनको खाली इतना बता दूं कि पहले हम आपसे कमेंट्स लेंगे सर, उसके बाद हम इनके पास जाएंगे, then we'll come back to the academia. उसकी वजह ये है कि they are short on time. तो सर, over to you.
जी, सबसे पहले तो हमारे मुल्क में जो इंटेलेक्चुअल प्रॉपर्टी है उसके जो राइट्स हैं और उसकी जो प्रोटेक्शन है उसका कोई खास सिस्टम नहीं. Suppose I invent something, my company works maybe for 10 years, and then someone can copy it right away, and there is no protection. I went to patent office, and to my surprise, पहले मैं उर्दू में बात करूँ, पेटेंट ऑफिस को तो पता ही नहीं था कि इंटेलेक्चुअल प्रॉपर्टी होती क्या है. कल के जी हाँ वो लाएं, वो लोगो दें जिसको हम रजिस्टर कर दें, या वो नाम बताएं जैसा कंपनीज के नाम होते हैं, या कोई आप अपना ट्रेडमार्क रखते हैं. तो एब्सोल्युटली जो है इसके अंदर सबसे पहले तो अगर हमने नॉलेज बेस्ड इकोनॉमी में एक्सेल करना है, आगे जाना है, तो बहुत ज़रूरी है कि जो इंटेलेक्चुअल प्रॉपर्टी है उसकी प्रोटेक्शन होनी चाहिए। और जो लॉज हैं अगर बनाने मुश्किल हैं तो सरे दस्त अगर अमेरिकन लॉज आप देख लें, उनको कॉपी कर लें, उस तरह के लॉज नहीं हैं, तो मेरा ख्याल है कि फिर लोगों को रिसर्च करने में, मेहनत करने में और उसके कोई एक इंसेंटिव तो मिलेगा। दूसरी बात यह है कि हम लोगों को मुख्तलिफ अगर आप पेटेंट लॉज के ऊपर जाएं, वेरी इंटरेस्टिंग थिंग, यू सी a company suppose in America is developing something and they have spent millions and millions of dollars and they have evolved something and they have taken a patent from America. ठीक है, वहाँ पेटेंट लॉयर्स आर वेरी एक्सपेंसिव और अगर मैं पाकिस्तान में बैठा हुआ, इफ आई कैन कॉपी इट एंड सेल इट इन पाकिस्तान, दे कैन नॉट कम बैक एंड से दैट देखें जी हमारे पास इस चीज का पेटेंट अमेरिका में है। हर मुल्क के अपने पेटेंट लॉज हैं, ठीक है। तो उसके अंदर ये है कि हमें मे बी नेगोशिएट विद डिफरेंट कंट्रीज, ताकि अगर उनके पेटेंट लॉज की हम रिस्पेक्ट करें और हमारे पेटेंट लॉज की पेटेंट जो इंटेलेक्चुअल प्रॉपर्टी है उसको अगर करें, इट विल बी डिफिकल्ट, लेकिन ये किया जा सकता है। दूसरा, जो गवर्नमेंट के एंड पे सम सर्विस शुड बी प्रोवाइडेड, कि अगर एक पाकिस्तानी कंपनी जो है दे हैव सम इनोवेटिव प्रोडक्ट और समथिंग एंड दे वांट टू गेट इट रजिस्टर्ड इन यूएसए, तो दे कैन नॉट पे, मतलब $20,000 या $30,000 किसी लॉयर को फी नहीं पे कर सकते। तो जिस तरह इनका पेटेंट ऑफिस इधर है, उस तरह कोई एक थोड़ा सा पहले ऑफिस बताएं जो लोगों को गाइड करे, एंड प्लीज ट्रेन सम लोकल लॉयर्स जो कि फिर उन लोगों को उधर से लेकर दें। इट्स नॉट वेरी डिफिकल्ट, मतलब एनीथिंग, एनीवन इंटरनेट पे बैठे हैं, आप उनके पेटेंट सर्च कर सकते हैं, वो चीज है कि नहीं है। वो इंटरेस्टिंगली पता नहीं है जो भी यहाँ आई थिंक अभी एक कंपनी का विजिटेड ए कंपनी एंड दे हैव डन वेरी हार्ड वर्क, वो डायलिसिस इंडिविजुअल डायलिसिस सिस्टम बनाने के ऊपर, एंड आई जस्ट वांटेड, आई वाज वेरी इम्प्रेस्ड विद दैट गाय, और मैंने कहा जी आई शुड मीट हिम, तो ही वांटेड मी टू साइन ए नॉन डिस्क्लोजर और दिस तरह का एग्रीमेंट के जी आप जो देखेंगे बताएंगे नहीं। तो अगर फर्ज करें मैंने वो साइन नहीं किया, लेकिन इफ आई वुड हैव साइंड, आई एम श्योर ही हैड, देयर इज नो लॉ टू प्रोटेक्ट हिम। इज देयर एनी लॉ? नो लॉ। तो ये जो है, ये सबसे पहले तो नॉलेज बेस्ड उसमें जाने के लिए ये है। दूसरी बात है कि डेटा की प्रोटेक्शन। अब आप देखें कि आप तो माशाल्लाह वो डॉक्टर गालिब बैठे हुए हैं और एफबीआर के डेटा के ऊपर अटैक हो रहा है, ठीक है जी। यहाँ पे ये हालत है कि एनी वन ऑफ यू जो कि स्टॉक्स कभी लें, तो वो जो है वो आपकी जो स्टेटमेंट है, पूरी स्टेटमेंट वो उठा के आपको मेल के अंदर वैसे ही ईमेल करते जा रहे हैं। हाउ डेंजरस दैट इज। फिर हमारे इवन गवर्नमेंट के लोग जो है या इवन जो हमारी मुख्तलिफ और लोग हैं, वो आज पकड़ते हैं व्हाट्सएप के ऊपर डेटा भेज रहे हैं, कर रहे हैं। तो ये जो है, ये वी आर गोइंग टू फेस लार्ज प्रॉब्लम्स बिकॉज ऑफ दिस। तो ये मेरे 2 पॉइंट्स हैं। बहुत शुक्रिया।
So thank you very much. So essentially intellectual property right और
दूसरा डेटा सिक्योरिटी
जी, legislation and regulations. Particularly पाकिस्तान का जो डेटा प्रोटेक्शन लॉ पास हुआ है,
वो इम्प्लीमेंट पता नहीं कैसे हुआ।
That needs to be looked into.
और उसमें वो डेटा प्रोटेक्शन इज डिफरेंट देन आपकी इंटेलेक्चुअल प्रॉपर्टी डिफरेंट।
ट्रू।
वो उसकी इंटेलेक्चुअल प्रॉपर्टी का भी होना चाहिए, प्रोटेक्शन होनी चाहिए। मतलब बंदा इतनी मेहनत करता है, वो बनाता है, दूसरा बंदा जाता है उसी चीज थोड़ी सी कम पैसों में बना के बेच देगा, वो बेचारा किधर जाएगा?
सही कह रहे हैं।
और दूसरा जो है, हम लोगों की जो है सिक्योरिटी ऑफ डेटा, उसके ऊपर गवर्नमेंट नीड्स टू टेक समथिंग, डू दिस एक्शन। बहुत शुक्रिया, थैंक यू।
Very kind, sir. So now we would move to the government side. If you have something to say.
Thank you very much for giving me the opportunity. वो फारसी में कहते हैं देर आयत जिनायत। So we have been a bit late, but I'm very happy that we actually made it to this forum. The first part of my comments would be purely in my personal capacity, because I shall be making a few observations with regards to the discussion that has been conducted in front of me. Second part के अंदर फिर हम उसको official या government का एक representation कह सकते हैं कि government किस तरह के steps ले रही है। जो intellectual property rights की अभी सर ने बात की, सर इसकी एक flip side भी है। Do you mind if I go bilingual? उर्दू अंग्रेजी मिक्स कर लेते हैं। सर, चाइना की हिस्ट्री है for the good 30-35 years, no intellectual property rights at all. International intellectual property rights को तो उन्होंने ट्रक के नीचे देके मार दिया। बिल्कुल, they copied everything, they engineered everything, they reverse engineered everything. But then that nation has actually pulled some wonders. वहाँ पे ना लोकल कॉपीराइट का कोई कॉन्सेप्ट था ना फॉरेन कॉपीराइट का था. दूसरा, ये जो टेक की अभी एज आ गई है इसमें, the moment you put your product up for take at the market, it is immediately going to get replicated. So the only way to protect is to keep evolving. Nokia बेस्ट एग्जाम्पल है इसको समझने के लिए. वो वक्त के साथ साथ इवॉल्व नहीं कर सके. एक ओपन सोर्स सॉफ्टवेयर था, ये जो एंड्रॉइड जिसको अभी हम कहते हैं, इट हैज इवॉल्व्ड ओवर द पीरियड ऑफ टाइम. और कितने हार्डवेयर के प्लेटफॉर्म्स हैं जिन्होंने इसको अडॉप्ट किया, अपने पर्पस के लिए यूटिलाइज किया, टुक द बेस्ट आउट ऑफ इट, एंड देन दे मूव्ड ऑन. सो एवोल्यूशन इज द ओनली इंटेलेक्चुअल प्रॉपर्टी राइट दैट प्रॉब्ली यू आर गोइंग टू गेट इन द फ्यूचर. नंबर वन. नंबर टू, सर, गवर्नमेंट की आपने बात की कि इसको ट्रेन करना चाहिए लॉयर्स को. अगर मैं बिल्कुल इंडिपेंडेंट पर्सपेक्टिव से इसको देखूं तो दिस इज अ कमर्शियल वेंचर. द लॉयर्स मेक अ लॉट ऑफ मनी आउट ऑफ इट, स्पेशली द लॉयर्स व्हेन दे आर एंगेज्ड फॉर इंटरनेशनल फोरम्स, डिस्प्यूट रेजोल्यूशन के, आर्बिट्रेशन के, दे मेक अ लॉट ऑफ मनी आउट ऑफ इट. इट गोज इन मिलियंस ऑफ डॉलर्स. सो क्या मार्केट ने सफिशिएंट डिमांड जनरेट कर ली है? I personally believe कि मार्केट में सफिशिएंट डिमांड आएगी ना, सर ये लॉयर्स भी, ये इंटेलेक्चुअल प्रॉपर्टी राइट एक्सपर्ट्स भी आ जाएंगे. पाकिस्तान का मेजर इशू इज नॉट अबाउट द रेगुलेटरी फ्रेमवर्क की अवेलेबिलिटी, इट्स मोर अबाउट कंप्लायंस. वी आर ऑलरेडी इन ओवर रेगुलेटेड इकोनॉमी. We've got at least 3 sets of laws for each of the business categories, 21 NOCs, 48 के करीब permissions, road की अलग permission. We are over regulated. The problem is compliance. Compliance का culture नहीं है, and that's where it falls in the society. So wrapping up this point, I would say कि overall sir एक awareness create करनी पड़ेगी, plus अपनी evolution को इतना rapid करना पड़ेगा कि ये IPC और ये जो intellectual property rights हैं ये हमें तंग ही ना कर सकें. आपकी बात ठीक है, scientific लोग थोड़ा सा discourage होते हैं इससे, but then there are certain ways to get the control of the situation. Government के पास framework देने की हद तक तो बहुत कुछ available है. They can give you the enabling environment, but practically वो आके इसको subsidize करे, intervene करे at the grassroots level, मेरे ख्याल में वो इतनी suitable suggestion नहीं होगी. Number one. Number two, sir, जो IT tech से related जितनी भी हमारी innovation है in the past at least 3 to 4 years, the regulators and the government has been maturing at the demands of the market. It's a demand pulled majority of the framework that government is now reacting to. जो recent sets of laws हैं, जो इस तरह की चीजें हैं, normally ये होता था कि government set of laws बनाती थी, enabling environment खड़ी करती थी और industry आती थी. ये इतनी rapid pace के ऊपर startups आए, tech startups आए, tech innovation आनी शुरू हो गई, knowledge based economy की तरफ हम shift होना शुरू हो गए. Labor force हमारी well trained थी, English speaking लोग थे, software enabled थे. उन्होंने इतनी तेजी से ग्रोथ देखी कि गवर्नमेंट इज नाउ एक्चुअली रिस्पॉन्डिंग टू अ सिचुएशन. इट इज नॉट क्रिएटिंग अ सिचुएशन. द सिचुएशन जस्ट हैपेंड टू द गवर्नमेंट एंड गवर्नमेंट इज ट्राइंग टू रिएक्ट टू इट. सो आप बिल्कुल ठीक कह रहे हैं, गवर्नमेंट थोड़ा सा पीछे रहती है, बट कैचअप की एफर्ट्स आर ऑलवेज देयर. इट्स मोर टुवर्ड्स द सोसाइटी, द एकेडेमिया, द इंडस्ट्री दैट शुड टेक द लीड. मैं आपको छोटी सी बात को रैप अप कर देता हूँ. फिर इंडस्ट्री एकेडेमिया का सर डी लिंक जो है ना, वो मैं आपको एक पर्सनल एग्जांपल से बताता हूँ. मेरी बेटी 3री क्लास में पढ़ती है. परसों वो उर्दू की एक एप्लीकेशन लिख रही थी, इज्जत माब, आली जनाब, मजमून, अल आरिज और इस तरह करके. Frankly speaking, in the last 15-17 years in the corporate world myself and then 5 years with the government of Punjab, मेरी email होती है, final draft put up on the table at 5 shall be signed. Cheers. This is done. This is all the communication that they need. They do not need वो पुराने दकियानुस के ज़माने की चीज़ें. So industry academia linkage जो है वो हमारा pure disconnect है, not only in terms of the curriculum, not only in terms of the training, also in terms of the kind of supply of the resources that we are throwing to the market. जो resources ऊपर जाते हैं उसमें बेशक इदारों का भी हाथ होता है, बहुत हद तक पर्सनल एक स्पार्क भी होता है जो किसी बच्चे को यूनिकॉर्न बना देता है, किसी स्टार्टअप को यूनिकॉर्न बना देता है. सो इस जो आपस का लिंकेज टूटा हुआ है, इसको भी थोड़ा सा देखने की जरूरत है. कमिंग बैक टू द गवर्नमेंट साइड के गवर्नमेंट क्या पॉलिसीज दे रही है.
We are really short on time.
I'll just wrap it up in 30 seconds. गवर्नमेंट ने अभी रिसेंटली सर स्पेशल टेक्नोलॉजी जोन अथॉरिटी के नाम से एक पूरी फेडरल बॉडी कायम की है. आई एम श्योर उसका लॉ आप में से कुछ लोगों की नजर से गुजरा होगा. सो एनेबलिंग एनवायरनमेंट ऑन द पेपर जहां तक है, Government has already provided the framework. It has given you the incentives. It has given you the tax breaks. But frankly speaking, it is not the tax breaks, it is not the incentives of the government that makes the business sense. It's not going to get you a good business plan. A business plan is which is commercially viable, which is financially bankable, and which is feasible in terms of the kind of resources that you can bring to the table. So government ने अपने हिस्से का काम एक हद तक कर दिया, government ने special economic zones भी बना दिए, government ने enabling framework भी दे दिया, और भी mature करने के लिए वक्त के साथ government grow करेगी. But industry should take the lead. Plus, the government can only learn. We can only react to the situation because lead इस वक्त IT sector में especially innovation में especially industry के पास है, लोगों के पास है. Government के पास lead नहीं है. Government is reacting to a situation. We can create more enablement. We can create more positivity by learning from the industry. So आपका feedback जो है वो government को सीखने में मदद करता है. Thank you very much, sir.
Thank you very much. From academia side, I think Dr. Mohammed Tahir wanted to say something.
Okay, my comments are going to be very different from what we are discussing right now. I'm not sure how many will agree, but I'm going to give a very different perspective what we are discussing right now. What I will start with is कि ICT ने हमें ना कुछ दिया है कि नहीं दिया, लेकिन spoil जरूर किया as a nation. This is the first thing when I will interact with my students. This is where I start. हम एज ए नेशन सबसे ज्यादा स्पॉइल आईसीटी की वजह से हुए हैं. मोस्ट ऑफ यू वुड एग्री विद मी कि आप देखें बच्चे से लेके बड़े तक हम हर कोई एडिक्शन इस वक्त एडिक्टेड नेशन बन चुके हैं हम. एंड दिस इज व्हाट इज हैपनिंग. हमने नॉलेज बेस्ड इकोनॉमी तो बाद में बना दी थी, हम उस आईसीटी टेक्नोलॉजी जिसकी बेस में नॉलेज बेस्ड इकोनॉमी बनी थी, एक स्पॉइल्ड नेशन जरूर बन गए. तो अभी तो हमें बहुत ज्यादा करेक्टिव मेजर्स की जरूरत है. आप देखें जहां पे भी आईसीटी ने सोसाइटी में इंटीग्रेट किया है, देयर वर रेगुलेशंस इन प्लेस, और उस इंटीग्रेशन में बहुत सारी चीजें करने वाली थी जो हमने नहीं की, बोथ एट गवर्नमेंट लेवल, एट सोसाइटी लेवल, और इंडिविजुअली एट ए हाउस होल्ड लेवल ऑल्सो. Being the head of the house, I am not being able to control my own children from unnecessary usage of these ICT toys. The same is happening. Access to any website is available in this country. It's not available in anywhere in the world. तो ये उससे बहुत पहले, अभी तो हमने शुक्र है कि सारी नेशन आईसीटी इनेबल्ड नहीं हुई, वरना सारों का यही हाल होना है. जो हमारे जिनके पास आईसीटी अवेलेबल है ना, उनके साथ हो रहा है. तो पहले हमें थोड़ा सा एथिक्स पे भी देखना चाहिए. हमारी आईसीटी से रिलेटेड एथिक्स इस वक्त बहुत ही ज्यादा लैगिंग है और बहुत बुरे हालात हैं. हमारे स्टूडेंट्स कंप्लेंट करते हैं कि we are having very tight schedule, this and that, and whenever I discuss with any of them, they are spending on average 2 to 3 hours per day on this Facebook and WhatsApp or any other forum. That they don't miss even if they are having an exam tomorrow and whether they are done with their preparation or not. So this is the ground reality. आपका अब आ जाते हैं इंडस्ट्री की साइड से. इंडस्ट्री इज कॉन्टिन्यूसली कंप्लेनिंग नॉट ऑन द आईसीटी स्किल्स. स्किल्स आर वन पार्ट ऑफ इट, बट 70% ऑफ द कंप्लेंट्स आर दीज पीपल आर नॉट ऑफ गुड एथिकल वैल्यूज. Ethics has become a bigger problem in ICT industries than the skill set. This is what I'm hearing again and again. तो ये सारी चीजें it boils down to the same problem जो हम एज ए सोसाइटी बीइंग द यूजर्स ऑफ दिस आईसीटी टेक्नोलॉजी सफर कर रहे हैं. एंड दिस इज वेरी इंपॉर्टेंट साइड इन माय ओपिनियन जो हमें देखनी चाहिए. ब्लाइंडली एडॉप्शन ऑफ थिंग्स इज नॉट द सोल्यूशन. इट शुड बी नीड बेस्ड. नीड ड्रिवन हमने करना छोड़ दिया है. सो दिस इज फॉर द टाइमिंग फ्रॉम माय साइड.
Thank you very much. We'll move to the industry, please.
मेरा ख्याल है मैं सबसे लीस्ट टाइम मैंने यूनिवर्सिटी इन्वायरमेंट में स्पेंड किया आउट ऑफ ऑल यू. सो विद ऑल ड्यू रिस्पेक्ट, मतलब आई एम लीस्ट क्वालिफाइड लाइक इन टर्म्स ऑफ फॉर्मल एजुकेशन. एक ग्रेजुएशन किया और उसके बाद इंडस्ट्री में निकल गया. सो इफ यू आस्क मी ऑनेस्टली, लाइक आई एम अ लिटिल सरप्राइज्ड एंड लिटिल डिसहार्ट बाय द डिस्कशन व्हिच इज गोइंग ऑन हियर एज वेल. उसकी वजह ये है कि हम गवर्नमेंट की बात कर रहे हैं, हम प्राइवेट सेक्टर की बात कर रहे हैं, हम एथिक्स की बात कर रहे हैं, एसटीजीए की डिस्कशन हुई. नॉलेज इकोनॉमी क्रिएट कहाँ से होती है? लाइक हम इस प्रेस्टिजियस यूनिवर्सिटी में बैठे हैं यूईटी में, यू क्रिएट नॉलेज, राइट, एंड यू इम्पार्ट दैट नॉलेज इन द यंग माइंड्स। पिछले 10 सालों में हमने एज ए नेशन, एज ए गवर्नमेंट, एज एकेडेमिया, हमने कितने नए इंस्टीट्यूट्स बनाए हैं। हमारी पॉपुलेशन कहाँ जा रही है, हमारे एजुकेशन लेवल क्या है, हायर एजुकेशन में कितने हमने नए इंस्टीट्यूट्स बनाए हैं। यूईटी एक इंस्टीट्यूट पिछले फॉर लॉन्ग टाइम सर्व कर रहा है। कितनी नई यूईटीज हमने पंजाब में खड़ी की हैं। वो जो भावलपुर में बच्चा बैठा है, आई एम सॉरी टू से, यूईटी ने ऐसा क्या काम किया है कि एक नया इंफ्रास्ट्रक्चर पूरा प्रोजेक्ट वहां जाके स्टार्ट हो रहा है। आई नो काला शकाकू में है, लेकिन और गवर्नमेंट लेवल एक फास्ट यूनिवर्सिटी 30 साल से चल रही है, 2 और कैंपस बना दिए। कहाँ है हमारे पीएचडीज जो बाहर पढ़े? किसने कोई प्रोग्राम लॉन्च किया कि यार ये यूनिवर्सिटी से फीस नहीं दी जाती, तो ये पहले 3 लाख रुपए हम देते हैं, ये आप फैकल्टी आईवी लीग का यूनिवर्सिटीज में पाकिस्तानी 150 प्रोफेसर है। किसने आज तक एफर्ट की कि उनको पाकिस्तान लेके आए? नॉलेज इकोनॉमी का क्या ताल्लुक है? जो एकेडमी, जो हमारी ऑफिस में हम डेली काम करते हैं, दैट्स द एंड रिजल्ट। We do not initiate anything in our offices which is the grassroots of knowledge economy. Knowledge economy कहाँ से स्टार्ट होती है? आपने डॉक्टर साहब ने नंबर कोट किया, 1 लाख आईटी प्रोफेशनल्स हैं। हमारी 200 मिलियन की आबादी है। 200 मिलियन का परसेंटेज निकालें तो 0.0 से आगे जाके कोई नंबर बनता है जो हमारे टेक्नोलॉजी वाले हैं। हम उनसे क्या कर लेंगे? अभी आप इरफान साहब से पूछें, 100 जॉब ओपनिंग्स इनके पास हैं, 100 जॉब ओपनिंग्स मेरे पास हैं। एक्सीलेंस पे हमने क्या काम करना है, लोकल इंफ्रास्ट्रक्चर पे हमने क्या काम करना है। सो इफेक्टिवली द ग्रास रूट इज कि हमने अपने बच्चों को क्या पढ़ाया है। हमने दुश्मन के बच्चों को पढ़ाना है, अपने बच्चे सारे वो सड़कों पे घूम रहे हैं, भाग रहे हैं। जो बेचारा किसी छोटे सिटी में किसी यूनिवर्सिटी में बैठा है, वो ग्रेजुएट होके 4 में से 3.8 जीपीए लेके आता है, मेरे पास वो हायर नहीं मैं उसे कर सकता क्योंकि उसका स्किल सेट नहीं है। उस बेचारे का क्या कसूर है? उस बेचारे का तो कोई कसूर नहीं है। हम फैकल्टी नहीं लेके आए, हमने एचईसी ने प्रोग्राम्स रन किए जिसमें इन्होंने फंड किया पीएचडीज को। जब उन्होंने वापस आना था वो हमने प्लान डिसकंटिन्यू कर दिया। एसटीसीए की बात कर रहे हैं, हमने एसटी अल्फा टेक्नोलॉजी पार्क बनाया। आज जाए ऊपर से नीचे तक सॉफ्टवेयर कंपनीज कहाँ है? गवर्नमेंट ने 2 फ्लोर उठा लिए, 2 फ्लोर गवर्नमेंट के किसी और डिपार्टमेंट को दे दिए। कोई मल्टीनेशनल आई, उसने आपको 2 फ्लोर दे दिए। एसटीजीए की बात हो रही है, आपको पता है एसटीजीए आईटी मिनिस्ट्री के अंडर नहीं है, ठीक है। आईटी मिनिस्ट्री से कहाँ, किसी को भी नहीं पता एसटीजीए में क्या हो रहा है। वहां पे कभी हार्डवेयर प्रोडक्शन होगी या क्या होगा? कहाँ है आपका एसएमई सेक्टर? एसटीजीए में कहाँ से बच्चे बैठाने हैं? मेरे पास 100 ओपनिंग्स है, मेरे पास जगह है, मुझे जगह नहीं चाहिए। सो आई एम लिटिल डिसहार्ट अबाउट व्हेन यू टॉक अबाउट नॉलेज इकोनॉमी। इट्स नॉट अबाउट कि जी आईटी इंडस्ट्री ने क्या करना है। इट्स ए कलेक्टिव एफर्ट जहां पे यू हैव टू ब्रिंग मोर पीपल इनटू द इकोनॉमी। अभी सप्लाई डिमांड का शॉर्टेज है। जब सप्लाई एंड डिमांड का शॉर्टेज होता है तो सप्लाई कभी भी एफर्ट नहीं करती। इस वक्त स्टूडेंट जब निकलता है उसके पास 4 जॉब ऑफर्स होते। मैं जब 15 साल पहले ग्रेजुएट हुआ था, एक मुश्किल था जी जॉब लेनी है। मेहनत करते थे, एफर्ट करते थे, प्रोजेक्ट में ग्रेड्स चाहिए। आज हर बच्चे को पता है मेरे पास 4 जॉब ऑफर्स हैं, वो क्यों एफर्ट करेगा? वो ड्रिवन ही नहीं है। हमारे पास आके बैठता है जिस पे स्टूडेंट पे प्रेशर, बच्चे पे प्रेशर डालते हैं कि तुम्हें पहले 3 महीने के हमने लर्निंग प्रोग्राम से गुजारना है। तो तुम्हें क्या पता भाई क्या लर्निंग किस चीज की? मैं तो सब कुछ सीखा सिखाया हूँ, मेरे पास तो 4 जॉब ऑफर्स हैं, मैं दूसरी जगह निकल जाऊंगा। सो आई थिंक वी हैव गॉट द बेसिक्स रॉन्ग। इट्स ऑल अबाउट 1 लाख बच्चे है, उसके साथ हम क्या ऐसा तीर मार लेंगे कि हम $200 बिलियन या $100 बिलियन या $50 बिलियन की एक्सपोर्ट्स ले लेंगे। दीज आर क्रेजी नंबर्स विच यू आर नॉट गोना अचीव अनटिल अनलेस वो 1 लाख का नंबर हम 1 मिलियन 2 मिलियन पे लेके जाए। उसका एक नेशनल इमरजेंसी प्लान हो। उसके अलावा देयर इज नो वे आउट। आप एसटीसीज बना लें, आप कहें जी हमने ये कर दिया, हमने ट्रेनिंग, ये बूट कैंप्स, जो आई एम ए बिगेस्ट सपोर्टर ऑफ बूट कैंप्स इन पाकिस्तान, बट दैट्स द शॉर्टेस्ट टर्म इंटरवेंशन वी कैन डू, राइट। बूट कैंप्स, इमेजिन करें डॉक्टर वकार की जगह आज से 20 साल वो बूट कैंप का बच्चा यूनिवर्सिटी में पढ़ा रहा होगा, ठीक है। वो हमारे साथ फ्यूचर में क्या करेगा उसको तो हम सोच ही नहीं रहे। ये तो वो प्रॉब्लम है जो हमारे अगले 6 महीने से 1 साल प्रॉब्लम सॉल्व करता है। लॉन्ग टर्म आई थिंक वी आर गोइंग इनटू ए डिजास्टर सिचुएशन। 2.5 बिलियन से 3 बिलियन पे जाना, 1.5 से 2.5 पे जाना पाकिस्तान के नेशनल लेवल पे, इट डज नॉट मैटर, ठीक है। इट्स सच ए स्मॉल नंबर कि ये हमें कहीं भी सक्सेस या कहीं भी प्रोग्रेस की तरफ नहीं लेके जा रहा। ग्लोबली एक टेक्नोलॉजी का शॉर्टेज आया है, रेट दुनिया में बढ़ गए हैं, 25% हर चीज महंगी हो गई है, डॉलर रेट बढ़ गया है, तो हमारे रेवेन्यूज बेहतर हो गए। अदरवाइज हमने कौन सा ऐसी कोई यूएस में जाके कोई ऐसे सेटअप्स लगा लिए हैं, या हमें प्राइवेट गवर्नमेंट पार्टनरशिप या कोई भी सपोर्ट प्रोग्राम है जिसपे कंपनीज यूएस गई हो, या फिर हमने कोई एडवांस रिसर्च सेंटर या फिर फ्रंट फेज ऑफिसेज गवर्नमेंट ने या प्राइवेट सेक्टर ने बे एरिया में बनाए हैं। हर किसी की अपनी एफर्ट है। 2 ईंट की मस्जिद है, जिसने बना ली वो अपनी बलबूते पे सक्सेसफुल है। अदरवाइज दिस इज माय ऑनेस्ट ओपिनियन। आई डोंट नो इफ इट इज टू हार्ड फॉर एवरीवन, लेकिन इसके बगैर मेरा नहीं ख्याल हमारा कोई फ्यूचर है नॉलेज इकोनॉमी में।
Reality bites. Actually, it did bite. मैं देखें, we are really closing in on time. We need to get at least one more round from the academia and from the industry. अगर हम 5 मिनट में या 7 मिनट में conclude कर सकें, I'm with you, and I would not like to disagree with you on any of the comments. But before we move to the academia side, I'm a moderator, but I also represent part government, part academia, because UET is a state-owned university. I personally think that essentially the buck stops at the government. The buck stops with the government. Why? Because we talk about compliance, but we don't talk about enforcement. When the government is essentially calling shots in matters that the government wants to, so the intervention that the government should be doing is not to that level where it should be. We being part of the same fraternity, the part of the onus goes to us as well. But I think that the cribbing and I would say, the distrust and the disillusionment on part of the industry is well justified, because they are getting the brunt of it, major brunt of it. Before we move on, would you like to just say something, just in a minute, in a jiffy?
So, with my personal opinion on this, I wouldn't tend to agree, with all the due respect, sir. क्योंकि मेरी जो thought process की vectoring है, that is not towards the government at all. हालांकि मैं कुछ सरकार के लिए काम करता हूँ. Government is not a cradle, it's not a mom. State माँ की तरह होती है, ये अफसानों के अंदर बड़ी अच्छी लगती है बात. But this is not the fact. This is a hardcore commercial world. Everything should make sense in the dollar terms. Everybody, as every human person walking as a resource, consuming electricity, consuming oxygen on the face of earth, should become, in the dollar terms, competitive, productive, profitable. This is it. This is how the business goes. This is how Chinese do the business. This is how Europeans do the business. अगर हमने sympathize करना है, अगर हमने empathy दिखानी है, अगर हमने बहुत benevolence दिखानी है, so let's not use the government's funds. We can start being philanthropic out of our own pockets. First comment. Second comment, बड़ा ठीक point out किया कि knowledge economy is a very broader phenomena. इसका स्पिल ओवर इफेक्ट जो है, हमारे साथ 2 प्रॉब्लम्स है फ्रैंकली, और गवर्नमेंट के साथ भी हैं ये. व्हेनेवर वी टॉक अबाउट स्मार्ट सिटीज, वी टेक अ ड्रोन, गुड ग्रीन हाई राइज बिल्डिंग्स के ऊपर से हम गुजारते हैं और उसको स्मार्ट सिटीज बना के पेश कर देते हैं. वी आर सम और द अदर फैंसिंग, वी आर इन लव विद द आइडिया कि खूबसूरत रियल एस्टेट होगा तो वो स्मार्ट सिटी होगी. रॉन्ग. स्मार्ट सिटी ऐसे नहीं होती. स्मार्ट सिटी में कच्ची कोठी के अंदर भी बैठ के, छोटी झोंपड़ी के अंदर भी बैठ के बंदा 5G सर्विसेज के एक ब्रॉडबैंड चैनल में से अपना हिस्सा ले रहा होता है, एंड देन ही इज ऑफरिंग BPO सर्विसेज टू समबडी इन USA. कॉन्सेप्ट्स और है. हमारी इन्फैचुएशन विद लार्जर रियल एस्टेट एंड खूबसूरत टाउन्स, दैट इज एक्चुअली रॉन्ग डस. नंबर 1. नंबर 2, नॉलेज इकोनॉमी हमेशा तब बनती है जब आपके रियल इकोनॉमिक सेक्टर्स के ऊपर IT का स्पिल ओवर इफेक्ट आता है. Our agriculture is absolutely disconnected. Our retail sector is now gaining pace, it is catching up, but it remained absolutely disconnected with your IT. आपका sports has remained absolutely disconnected. Sports सादी सी चीज है, एक academy of excellence है, उसके अंदर आज तक आपके पास बॉलर की चकिंग को ascertain करने की कोई टेक्नोलॉजी नहीं है. ठीक है. सो आखिरी चीज, आई एम जस्ट ट्राइंग टू कंक्लूड इट. गवर्नमेंट से बिल्कुल एक्सपेक्ट करें, गवर्नमेंट इज देयर टू गिव यू द एनेबलिंग एनवायरनमेंट, बट एवरीबडी नीड्स टू स्टार्ट टेकिंग देयर ओन बर्डन, नॉट इन द नेगेटिव सेंस. मैं ये कोई रिबटल नहीं दे रहा हूँ आपको, आई एम जस्ट सेइंग इट आउट ऑफ माय हार्ट. मैंने सरकार के लिए भी काम किया, मैंने प्राइवेट सेक्टर के लिए भी काम किया. जब मैं 9 घंटे काम करता हूँ तो मैं एक्चुअली 9 घंटे काम करता हूँ. अगर 9 घंटे के अंदर मैं काम नहीं करता तो मेरा ऑफिस वर्क डे 16 घंटे का भी होता है, और मैं 18 घंटे भी काम करता हूँ. क्योंकि जब मैं बाहर इटली में जाके काम करता था मुझे पता है कि जब मैं 8 घंटे अपना टाइम क्लॉक करता था, मेरे पास 1-1 मिनट का हिसाब होता था। हम में से कितने लोग हैं जो यहाँ पे करते हैं? प्राइवेट सेक्टर, एवरीबडी शुड डू इट। फ्रैंकली मुझे कोई पूछ नहीं सकता कि मैंने सारा दिन क्या किया। सोसाइटी, एज अ सोसाइटी मैंने ये रिस्पॉन्सिबिलिटी लेनी है। वी नीड टू टेक द लीड सर। गवर्नमेंट खुद फॉलो करेगी। गवर्नमेंट, पूरी दुनिया की गवर्नमेंट्स रिएक्टिव हो चुकी हुई है, वो प्रोएक्टिव नहीं है अब। नहीं सर, यहाँ पे भी गवर्नमेंट So to my personal understanding, सर वो सुबह 6:30 बजे भी आके अगर नहीं वो सर अगर उसने अखबार पढ़ना है, उसने आके
Sir, so जी, वैसे ना actually this is a good sign. Actually, when someone actually starts to trigger your reactions, it speaks of the intellectual activity spurred. Really, I think it's a good thing. मैं ये request करूँगा, हमारे पास time बहुत short है. We'll get a comment from academia and finally from the industry. लेकिन मुख्तसर, अगर आप इसमें if you have that seriousness of purpose, I'll request. I would like to run a Delphi over it. डॉक्टर आमिर महमूद साहब से बात हुई थी, अगर मुझे इजाजत दें, I'll over to the industry. मैं इस पर Delphi रन करूँगा. So we'll share this presentation, our findings. We'll share these with you. We'll expect your feedback. We might do this iteration 2 or 3 times, and we'll develop some consensus. क्योंकि अल्हम्दुलिल्लाह we are one team. हम एक मुल्क हैं, हम मुसलमान हैं, हम सारे we are trying to do better. तो मेरी रिक्वेस्ट है डेल्फी रन करेंगे, लेकिन अभी हम क्विकली डॉक्टर आमिर साहब के पास जाते हैं. So please.
Thank you. So we had yesterday a talk from one of the professor from Malaysia. So he said that in their university, the graduate employability is 91.4%. 91.4%. So what is the graduate employability of UET or the university in Pakistan? As Ahmed rightly pointed out, that we don't get a person who is qualified to do the work that we have. We have projects, research projects, but we don't find the actual right skill set person that can execute that project. तो हमें भी वही काम करना पड़ता है, रॉ रिसोर्स लेना पड़ता है, उसको 6 माह ट्रेन करते हैं. एंड इन माय टीम आई नो द हाफ लाइफ इज 1 ईयर. अगर उसने 1 साल तक काम कर लिया तो बहुत अच्छी बात है, अगर 2 साल कर लिया तो और बहुत अच्छी बात है, बट आई नो कि 1-1.5 साल बाद he will actually go somewhere else, right? So but that's fine. हमारा तो ये रोलिंग बिजनेस है, हम we are tuned to that one. So the question is, from my experience in Germany, previously they were focusing on, not on R&D, they were focusing on R&I, research and innovation. And now they have changed the same thing into another I, that research and impact. So the universities need to create an impact. But how they can create an impact when the industry is not willing to buy their products? So there is a big disconnect. So we need a whole complete ecosystem that industry. मुझे 10 साल मैंने ICT इंडस्ट्री में काम किया. We never bought anything from the local industry. अगर कोई राउटर लिया तो सिस्को का लिया, हुआवे का लिया, कहीं से लिया. पाकिस्तान की कोई बड़ी हुई चीज हमने नहीं ली. तो अगर आप कोई चीज नहीं लेंगे जो कि आपके रिसर्चर प्रोड्यूस कर रहे हैं, तो then how can we as innovators we can take the advantage of that one? So I quickly अजान हो रही है, मैं शॉर्ट करता हूँ. This is my percent.
अजान हो जाए, फिर हम लास्ट कमेंट लेते हैं और फिर सेशन कंक्लूड करते हैं. नमाज पढ़ के भी रिज्यूम, फिर वी सर अजान हो गई है, अगर आप में से कोई बात कहना चाहे फॉर्मली जब हम सेशन कंक्लूड करेंगे ना, वील आपका ओपिनियन लेने के बाद फिर हम आपके कॉन्टैक्ट्स पे आपके साथ ये फाइंडिंग्स शेयर करेंगे एंड वील रिक्वेस्ट यू फॉर सिंसियर फीडबैक, वेरी ब्लंट कैंडिड। कुछ कहना चाहते, आप कुछ कहना चाहते हैं?
One thing, most of the things you have said are very correct. And sitting in the interviews, I have seen one thing: the FYP, the final year project. If the academia can do something about it, like when a student is presenting it, and there should be a hold of like what they have done, they actually have done that, or if you can look into that one, that would be a great point.
No. So probably I think he is expecting it to be done in accordance with the demands of the industry and the trends and technology.
Yes. Very quick and short comment that the root cause we need to address is the schooling and the education, because in the last 10-20 years no more universities and schools has been established. So that is the main point from where the innovation will start, where the more because government has handed over the education system to the private sector, and they are doing what they can actually do to the education system, and output is in front of us. So creation of new universities, new schools is the need of the day and the most crucial item. Thank you.
Just one like 30-second comment. 1 लाख लोग हैं आईसीटी में या 1.5 लाख होंगे, इनसे हम क्या एक्सपेक्ट कर सकते हैं? जो ये कर रहे हैं इससे ज्यादा हम एक्सपेक्ट नहीं कर सकते। द ओनली सोल्यूशन इज टू क्रिएट 1 million पीपल एंड इट्स नॉट इजी, राइट? इट्स अ मेगा project across the country emergency. Unless we don't do that, I don't see any solution to our problems.
एक कमेंट अगर आप मुझे कि कई मिलियन लोग जो है वो खुद ब खुद अट्रैक्ट हो जाएंगे विद इन फ्यू इयर्स, थिंग्स विल बी फाइन। तो दूसरी बात मेरी गवर्नमेंट से रिक्वेस्ट है, तो अगर उन्होंने चाइनीज मॉडल फॉलो करना है तो वो पूरी तरह करें, अगर इस्लामिक मॉडल करना है वो पूरी तरह करें, या एंग्लो सैक्सन लॉ लगाना है तो वो पूरी तरह करें।
Hands up, ready? Bismillahirrahmanirrahim. Honorable Vice Chancellor Sir, Dr. Mansoor Sarwar, thank you very much for joining this closing activity that we are now conducting here. At the second day of the 2-day event of the conference and 3-day events of the student competition. So very quickly, I will just go through briefly what has happened. The students, those who have gathered here, they actually have gone through several competitions which were organized by the IEEE UET chapter, and the office bearers are here. They will actually get introduced. Before we get into their certificate and prize distribution, I will only take a minute or maybe two to describe exactly what has happened in the past 2 days. We started off yesterday with our opening ceremony, and we were fortunate to have messages available, which since we have this all the event going on as an online forum, so we had messages available from our chief guest, from our distinguished guests. So we had a message from Dr. Atar Rahman, initially the opening message. Then we have CTO from Huawei, who gave us his message. Then we have Minister for Higher Education, Rajama Yusuf Sahab, he gave us the message. And then we had the Chief Guest Federal Minister. In fact, the written message was also available from our Chancellor, Governor Sahab. Then he also gave us his recorded message, which we will display now. And then we had the Chief Guest message from Shibli Farah, the Minister for Science and Technology, Federal Minister. So we had 2 days of activities. There were 2 sessions in parallel. Day one. One session was, in fact, based on the invited talks, and the parallel session was consisting of the papers which were selected. This conference has been very high quality, and it's one of the most regular and finest conference in Pakistan. This is 15th in a series. We have kept our standard high. We only select very high quality, 15 to 30% papers out of the submitted papers to the technical committee. This year also the percentage of selection was less than 30%. And with the starting of the conference, we had the first session, which was chaired by Dr. Usman Hani, which was on the artificial intelligence domain. And we had the talk from Dr. Atar Rahman, keynote speech, which was on knowledge economy, the blended learning, distance ODL, and the way forward for knowledge development of knowledge economy. Then we had talk from Dr. Umesh, who was joining us from Carleton University, Ottawa. Then we had another talk, which was from Professor Ali Salamat. He's from the Malaysia Japan International Institute of Technology. Then we had parallel 7 papers which were presented. And then we also had the exhibition, which consisted of about 20+ industries virtually exhibiting their products. And we also had more than 20 projects from Al-Khwarizmi UET, which are either completed or they are at the level of delivery. They were also available in the exposition. So this was a virtual event that we organized. Then we had session 2. That was first part was handled by Dr. Ghalib. This was based on cybersecurity. So we had invited talk from Professor Olaf, which is from the Tallinn University, Estonia. Then we had Professor Irfan Ahmed from Virginia Commonwealth University. These were the talks on the areas of cybersecurity. Then the session continued in the afternoon, and then we had, which was based on some of the areas of big data and cloud computing. And we had 5 papers presented in parallel. So in day 2, we had a talk, which is today, from Dr. Ali Khan. He's actually handling the Amazon Web Services. He is managing. It was amazing that he's managing the whole AWS with large teams. He said they have teams all across the globe, and their closest node closest to Pakistan is in UAE. And they have nodes in India and everywhere in Europe and America. So this is the wide area network based talk that he had. Then we had a talk from Professor Fahad Saeed. He's from Florida International University. and Dr. Ingmar Weber. He's from the Qatar Computing Research Institute. Then we had two industry talks from IBM and Huawei. So this is how we concluded the invited talks, and then the papers. There were about 21 papers which were selected during this time. They got presented. So with these activities, very quickly, we have the media team, which has put together a small 2-minute video of showing exactly what has happened. Before I conclude here, I would like to thank, of course, the organizers who have done wonders in making this possible. Kashif is sitting just next to you. He's been liaising with the IEEE in making sure that we have the requirements completely done, since the conference is going to be now, the proceedings are going to be published in IEEE Explorer. Then we have the web team, which is handled by Muzammil, who looked after the web arrangements. And then the other IT arrangements are looked after by the team of Rehan. He could not really stay here at this time. Rehan team is sitting here. And Hamza is from IEEE Law Chapter. He's helping us with the WebEx, the tool that we are using here. So WebEx is something which is available because of Hamza. It's a high standard tool that we have used for online display of the conference. And then we have Farhan, who is looked after the listening with industry. We had a panel just before you walked in. We concluded our panel. We had industry folks from 5-6 different industries, and very interesting talk between industry, university representative, and also the triple helix government representative were present in the panel discussion. This was all managed by Farhan. When we have the committee members, they are not available at this time, but Dr. Ghalib looked after the technical committee, taking care of the paper reviews from 200 different reviewers. And Dr. Ghalib or Dr. Amir looked after the program for today. This was the program committee. And Akil is also sitting here, is looking after the arrangements. And there are many others who are participating. Maybe I'm missing a few still, but I think they have done wonders in making this conference very significant success for Pakistan. So with these words, I think I'll ask you to please ask Hamza to now display the small video that you guys have prepared. Okay, very good. Hamza, now can you please display the message from the Chancellor? In fact, recorded the message yesterday.
Open source software is massively popular because of the right reasons. First of all, it provides decentralized solutions, thus reducing the risk associated with the reliance on a closed source software platform. Furthermore, it can be customized to meet individual needs. The future of open source technologies is very bright, especially in Pakistan, because of its free availability and accessibility. We have seen open source making inroads everywhere. This is high time for us to pay due attention to these technologies by creating skilled human resources in the local and worldwide software development industry. Today, more than 80% of all software developers worldwide are using some level of open source one way or the other. I'm confident that future of the open source is bright, and by using open source technology, we can take Pakistan on a fast track towards development and prosperity. In this context, ICOST 2021 provides a unique opportunity for researchers and industry to come together for low cost and innovation solutions. The government can gain huge benefits by developing a cheaper solution for e-governance and social services to better manage the resources and provide quality living to the citizen. In the end, I would like to wish the very best of luck to the organizers and participants of ICAST 2021. Pakistan Zindabad.
Very good. Now we'll move to the certificate distribution. There are multiple activities that happened, as I mentioned earlier. The student competition and also the idea entrepreneurship competition. I think we will start with the student competition, which is organized by IEEE Lahore chapter, UET chapter. I think office bearers are standing right here. And okay, so you guys will introduce yourself at the time. I'll now hand over to Farhan. Kindly, please go ahead.
Assalamu alaikum, everyone. As had been very well explained by Dr. Waqar Saab, how brilliantly our conference was organized. We had fair representation from researchers across the globe and from industry, from academia, and from government as well. Since we believe in inclusion, we believe it's incomplete without our worthy students. And this is why in the ICOST conference, we had several tracks. So one of the very prestigious and flagship program and a series of competition we were running is called Brainiac, ICOST Brainiac by IEEE. And we had run more than 6 tracks of competition ranging from code champion to some hackathons to some other virtual and on-campus tracks. So I would like to thank the branch counselor, Mr. Salman Fakhr Sahab, and also the worthy faculty judges who judged all the competition. So just to do with the prize distribution ceremony, I would request worthy Vice Chancellor Sahab and Dr. Waqar Sahab to please come forward and distribute the shields and certificates to the students. So I will start calling out the names if we have settled. Right. For the third module, that was Code Champ. That was the on-campus modules. The winners are Shoaib Zafar and Zain Salman. If you're here, please come forward with a round of applause. So, So some PUCIT alumni making Vice Chancellor Saab proud, and that's really good. We had representation from other universities as well. For the fourth module, which was a little difficult one, I must say, that's Circuit Genie. So I'd like to call on first the second runner-up, Mr. Ubaidullah Hassan and Aisha Iman. Could you please come forward? Now, after PUCIT and from the second runner-up from the ITU, now we have the winner, and that is from UET. Haris Nabil and Aisha Islam, could you please come forward? So maybe they're not here. We'll move on to the other module. Right. For some reason they couldn't come. So the fifth module के लिए, which was math gauge. हम second runner up जो है Mohammad Tayyib and Zaima Suhail, if you could please come forward. UET Lahore. From UET Lahore. And
ये कह रहे थे कि PUCIT के alumni को मैं खुश हुआ मैं तो ये भूल गया कि मैं सबसे पहले यूपी करने की पसंद
नहीं सर मैं Great round of applause for Worthy Vice Chancellor sir. Okay, so the first prize goes to students from UET Lahore. Linta Iqbal and Saad Wakar, please come forward.
सर ये यूएल से टेकन वाला ये हमारे यूनिटी से
नहीं बैठे और मीडिया क्लब And as we have done some math competitions, circuit genies, and speed coding, now it's, as we say, all work and no play makes Jack a dull boy. तो हमारे पास गेमिंग के लीग ऑफ योर ओन हमारी एक चीज थी और गेमिंग में आई एम श्योर बहुत सारे लोग अगेंस्ट भी हैं, लेकिन पबजी के कंपटीशन में पबजी के चीते हैं जी अमीर हमजा साहब, प्लीज कम फॉरवर्ड. यूनिवर्सिटी ऑफ लाहौर, UOL.
ये गेम खेलने देखी पड़ी ना.
Thank you. Now for the Tekken, by the way, just a small tidbit of fact, esports has become a multi-billion-dollar gaming industry. If you play at the top level, that's some lucrative stuff. But हम फिर भी ये कहेंगे आप पढ़ाई पे भी ध्यान दें. But yeah, Tekken gaming, one of the most famous one. Every guy and girls like to play that. Tekken के winner है computer science department से Ramiz Ali. Please come forward. UET Lahore computer science department से Ramiz Ali. Media club. शुक्रिया अदा करना बोला. In the end, we'd like to present the shield and with a token of appreciation and thanks to media collaborators, UET Photography Club. Could you please come forward? Thank you very much. I believe all these societies and students are power of our university. It's a driving engine. So thank you very much. And with the support of the societies, and our whole administration, where the Vice Chancellor Saab, Dr. Waqar Saab, we have been running some campaigns for the Business Incubation Center recruitment, right? Because we're going to incubate the next cohort. And we have a... So for a few more minutes, please. Just try to make it short. So Business Incubation Center की recruitment drive के लिए जी सर ये रेडी कर लो आप उधर खड़े हो जाए ना डॉक्टर साहब जी तो बिजनेस इंक्यूबेशन सेंटर जो है हम उसकी रिक्रूटमेंट ड्राइव के लिए वी हैड बीन लॉबिंग अराउंड ऑल अराउंड द यूनिवर्सिटी फ्रॉम द support of the chairman and worthy deans to the with the help of the societies we lobbied and campaigned in more than 8 departments. Collectively, our message for the UET Startup Cup, which was a precursor to the recruitment drive, we had reached out to more than 500 students physically and thousands of students virtually via our social media channels. So we got 33 applications. Application rate could have been better, I believe. But out of those 33 applications, we had a virtual round and an application form. We shortlisted the 10. And out of those 10, we are going to announce the winners who will not only get the incubation in our next cohort, in the BIC, they'll get brilliant offices, but also they will get some credit from AWS, Amazon Web Services, and the one-on-one support from our whole team. So again, with a bundle of thanks to the Vice Chancellor Saab and Dr. Waqar Saab's support, I would like to call upon the, actually, generally there are top 3 positions, but we couldn't help but to announce the 4th, or let's call it amongst the winners. I would like to call upon Trivia Automation from Mechatronics Department to please come forward and receive their certificate. So what they're doing is a wonderful idea. They're making warehouse management. Warehouse is a big market size, and they're tackling it with computer vision. Warehouse management through computer vision. Thank you so much, Trivia Automation. Just right now in the panel, we had a discussion on nobody is working on that sports technology. So very interestingly, we had a brilliant idea in the big market size, which is a craze in Pakistan and abroad as well. Online coach for cricket. So for the 3rd prize, please come forward, online coach, and receive their certificate. So they're from the mechatronics department, and very interestingly, the whole idea around that is like they will be running the visual analysis of the cover drives. Anyone would be using via their cell phones. Using their cell phones, they would be analyzing just like what we see on the cricket matches by ICC. Thank you so much, online coach. For the second position, and honestly, between the second and the first, we were so confused, and because of certain extra edges, so I would consider both of them to be first. But technically, a very interesting topic. You're all going to need that rishtedari, a matrimonial app. But the way they're tackling the rishta dynamics of Pakistan, from a psychometric angle to the big data and all, I think so it deserves worth. And I really love the spark in the founder. Thank you, Talha, and all the team. IBM department, UET Lahore. This is from our business school, and brilliant insights on the competitive landscape. Remember the name, Rishtedari. Talha, would you like to please briefly explain?
वो एक तो कन्वेंशनली जो आपकी मैथ में या रजिस्ट्रेशन के थ्रू आपको कराते हैं मैथ पे जो करते हैं आप टेंडर पर फाइल करते हैं जो हमारी ऐप है वो एक तो मशीन लर्निंग यूज कर रही है दूसरा आपके इंटरेस्ट बेस पे और आपकी जो कंपैटिबिलिटी टेस्ट होते हैं उसके अकॉर्डिंगली रेलेवेंट जो है प्रोफाइल आपको प्रेजेंट करती है जिससे आपका टाइम जो है बहुत सेव होता है और सेकंडली हम प्रॉपर केवाईसी के थ्रू अपने रजिस्ट्रेशन करते हैं जिसमें आपके क्रिमिनल बैकग्राउंड होते हैं आपके मतलब के जो आप डिक्लेयर कर रहे हैं आपकी आइडेंटिफिकेशन या इंफॉर्मेशन उसको कंप्लीटली वेरीफाई करने के बाद हम इसको ऑनलाइन शेयर करते हैं। और थर्ड चीज ये कि हम वर्चुअल मीटिंग्स करवाते हैं, फिजिकल मीटिंग करते हैं। तीनों चीजें नहीं है किसी में भी ठीक है। बताइए IBM में जो पहले लगा था ना जी जी वही था कि अच्छी आइडिया है, लेकिन आई थिंक कुछ ऐसे 0 to 1 में कहते हैं ना कि किसी कोई काम चल रहा है तो उसी को सस्ता करके आप करेंगे तो आप और उसमें मार्जिन कम कर देंगे और सक्सेसफुल होगा। उस तरह की चीज नहीं है। आपको कैसे पता डिवोर्स ट्रॉमा?
सभी ने मैरिज ट्रॉमा का भी नहीं पता।
तो शादी का ट्रॉमा
Thank you. Love their energy and spark. And as I said, we were very confused between the second and first position, but with a little bit of the leverage they got from the corporate experience of more than 10 years. So I would like to announce the first position for Go Global. Mr. Abdul Manan, please come forward. And they're from the corporate world. They've resigned and left their jobs and working on the hospitality and ticketing industry. A quick pitch, Abdul Manan, please. And why you're different.
cheap tickets and all that.
सर इसमें हम ऐसा कर रहे हैं कि यानी कि 2 लाख की टिकट है उसके लिए जो मोस्टली लोग हैं वो किसी भी हम चाह रहे हैं कि ऐसी बेहतरीन सर्विसेज उनको प्रोवाइड करें कि उनको they don't feel like कि अगर उनको सर्विस गलत देंगे तो उनको पैसे
एजेंट को ये लोग रिप्लेस करना चाह रहे हैं. They're trying to disrupt. It's a very competitive market. I agree. They're trying to replace the agent. जी सर, आप कुछ कहना चाहेंगे?
मैं कह रहा हूँ बाकी जो सारी है चीप टिकट
सस्ता टिकट भी है और बेशुमार
तो मुझे अपनी सर्विस को भी सर्विस की तरफ जाना है. सर सर्विस का कस्टमर सर्विस की तरफ जाना मतलब निर्देशन में टिकट भी यहाँ है सर्टिफिकेट देते हैं हमें पूरा सेव है बैक में कंफर्ट है.
What I love about this startup is they have a brilliant exposure to their customer and experience. Abdul Manan has about 15 years of experience in jazz and modeling with our customer relationship management. And his brother, he couldn't make it. He's a sales head in Pearl Continental Hotel at the moment and had worked with other companies. So they know their customer. They are working on creating that competitive leverage, but I totally agree, sir, it's very competitive. It has to be some silver bullet, which actually makes a difference. And we'll try to work with them. Thank you so much. And just the last few minutes, we would like to announce and thank the community partner AWS Pakistan, Amazon. And just two last token of appreciation and shield for the organizers of Brainiac. I would like to welcome, and he's standing right next to the worthy Vice Chancellor Saab, IEEE Lahore section, Mr. Kashif Bashir Saab. Please receive the shield.
Actually, very hard से हमें आना है.
ठीक है. And the last but not the least, the organizer and the IEEE from IEEE UET Lahore, I would like to welcome Ms. Amna to come forward. And all the team, please.
Very good, guys.
Thank you so much, Worthy Vice Chancellor Saab and all the students. Okay, so now we'd like to. We have the shield. So, Mr. No, sir, वो था थोड़ा सा वो जंबल अप हो गया. So, in the end, we'd like to present the shield to Mr. Salman Saab. Please come forward. और आखिर में मैं एक लेवरेज लेना चाहूंगा कि हम जैसा इंक्यूबेशन के अंदर वी आर ट्राइंग टू प्रमोट द एंटरप्रेन्योरियल कल्चर बट द आयरनी इज समटाइम इट कैन help the entrepreneurial landscape, but sometimes not. With a heavy heart, I would like to just extend my farewell and token of appreciation for Mr. Hassan. He's leaving for his own venture. He was working in our BIC and Tech team. And just a round of applause I would request for him. Anyway, so we are walking the talk. Thank you very much. Thank you very much, sir, for your time.
Just in case it doesn't work out for you, you're always welcome to come. Thank you so much.
So you have a safety net to fall back on. बहुत शुक्रिया सर आपके टाइम का आप तमाम लोगों का भी बहुत शुक्रिया. Yes, sir.